Good morning, ladies and gentlemen. Distinguished guests, esteemed experts, visionary leaders and delegates present here. On behalf of Telecommunication Engineering Centre, I extend a very warm welcome to all of you to the International Workshop on 6G Standardization being held here at Vigyan Bhavan, New Delhi. This workshop brings together global experts from industries and research institutions to deliberate on the future of 6G technologies, global standardization roadmap, spectrum strategies, intelligent networks, and emerging applications. With such an eminent gathering of thought leaders and innovators, today promises to be a day of insightful discussions and meaningful collaboration. So without further delay, let's begin the technical session of today's workshop. And once again, I request everyone to please put your mobile phones on the silent mode. Thank you. So we now begin session 1, Global Standardization Roadmap. This session provides a status of roadmap of 6G standardization in ITUR and 3GPP, outlining major milestones and global alignment efforts. To chair this session, it is my privilege to invite Dr. Vinosh Babu James, Director Technical Standards, Qualcomm and 5G India Forum. Can I have a big round of applause for him? Dr. Vinosh leads Qualcomm standardization engagements in India and Southeast Asia and works closely with Indian and international stakeholders on radio standardizations and regulatory matters. He holds a PhD degree in electrical engineering from IIT Madras, specializing in wireless communication and next generation terrestrial and non-terrestrial networks. We welcome you, sir. Now, I invite our first speaker of this session, Mr. Yane Pesa, Head of Connectivity Network Ericsson. A big round of applause for Mr. Yane. So kindly take your seats on the dais. Mr. Yane has been working at Ericsson since 1998 in research and development of 3G, 4G, 5G, and now 6G systems. He has coordinated Ericsson's radio access network standardizations activity in 3GPP and led research programs for 5G and beyond. He holds both MSc and PhD degree from the University of Helsinki, Finland, and was awarded the Ericsson Inventor of the Year Award. We welcome you, sir. Now I call our next speaker, Mr. Matthew Baker, Head of Global 3GPP Standardization at Nokia Research and Innovation. Please take your seat on the dais, sir. Mr. Matthew is a distinguished leader in telecommunication and a Bell Labs Fellow at Nokia. He previously served as chairman of 3GPP RAN 1 from 2009 to 2013 and vice chairman from 2013 to 2017. We welcome you, sir. So now it's a time to welcome the session chair and the speakers with the bouquet. So for that, I request Shri Vineet Malik ji, Director Radio, to kindly present a bouquet. Shri Vineet Malik ji. Please present the bouquet to Dr. Vinosh Babu James. A big round of applause. Bouquet to Mr. Yane Pesa. And now I request to present a bouquet to Mr. Matthew Baker. Thank you. So now, Dr. Vinosh, the stage is yours.
Very good morning, and welcome you to this session 1. Thank you, TEC, DOT, and all colleagues for facilitating this international workshop. I'll be brief with my slide presentation. It's just 3 slides. I'm not here as Qualcomm alone. I'm basically represented today as the convener of the 5G India Forum. right? So I just want to talk about two things on what we do, and then lead on to what my fellow panelists will be then talking about, right? So we are just an industry collective. We are housed within the Cellular Operator Association of India, and we have a very simple charter. It is to basically promote 3GPP technologies in the region, right? So what we actually do is very simple. We have a simple charter which basically focuses on bringing 3GPP meetings to the country, developing technical studies which will be about spectrum engineering, and what COI can then use it for policy advocacy. We'll also do a lot of technology studies focusing on new emerging areas, which is beyond cellular, and then try to create a knowledge house within the country, which is then used elsewhere. And then we also try to ensure that we are synergizing the mind share of companies, entities who are actually participating in India. And how do we do that? We actually have a few working groups where our members participate, and then we do that, right? So we have a technology working group, we have a spectrum working group, we have one focusing on industries. We also are a recognized evaluation partner for ITU on IMT technologies. And then we also expanded this membership to include Indian entities to come participate in COAI, in 5GIF, in what is called as the 6G coordination group, right? And then this is the sort of membership which we have today. Most of them, again, are COI members, but with the exception to some of the academia who are also part of the ITU and other studies which we are doing, right? That being said, this is nice, a good segue now into figuring out what we are going to do next in these sessions. We have two speakers, eminent speakers, again focusing on two eminent topics of interest to us. 6G standardization, as we know, have started. And then there are two main organizations which will be handling that part. There is a activity happening at the international standardization body called ITU, where it's important because spectrum comes from there, so the technology will have to be standardized in there. Yanni will be speaking about that. He'll be speaking about what are all the developments which is actually going on in there, and then he will also give what is achieved, what is yet to be achieved, right? So I think it will be better we hear them first and then get into Q&A, and then we'll have the discussion. So Yanni, without anything, please, your stage is yours. How do I get my presentation on? Can we have Yanni's slide, please? Thank you.
So thank you. So I will indeed talk about the ITU, which is one of the two organizations that are really important for the development of our generations. So let us first start though by imagining. Let's think that we are at the peak of the 6G era. So we are in 2030, and imagine you are walking on the street and you have your 6G mobile glasses on. They are, of course, connected with 6G. They are AI native. They provide you with an augmented reality view of the everything you see around it. You are communicating with the satellites. You are communicating with the drones. You are communicating with everything you can see. You are sensing your environment with the 6C joint communication and sensing. So basically getting a radio view of what you can see right for you, using all the applications that can only be enabled by 6C. And with this picture in your mind, I think I want to make two observations. The first one is 2030, that is less than 4 years from now. So this vision in 2030 is less than 4 years ago. We are in a bit of a hurry of developing this technology. And the other point I want to make is, of course, this is not what you will get. So I think we can all look at the picture, we can all look at the technology. We know that in 2030, which is less than 4 years ago, you will get something that is much more down to earth, much more looking like your mobile phone with a G on it. But I think the reality of what 6G can offer is somewhere in between. Maybe we'll never get into this more futuristic look, but I think we should make an aim of taking our technology towards that. Yeah, with that in mind, let's talk about the ITU. This is the overall 6G standardization timeline, and I took the liberty, being the first speaker, to pull in all the major forums into one slide. And the main point of this slide is to note that we are not at the beginning of 6G. We are not at the end of 6G for sure, but we are getting very close to the end of the beginning. We have the 3GPP that has started and almost completed the requirement work. We have the technical studies ongoing 3GPP. Matthew will talk about the results that we have achieved from 3GPP. We are approaching the point of time when we are completing the technical studies, in not that too far in the future. We have ITU that has done a very good job of setting the framework, has done the vision for the future, have prepared us for the next Mobile World Congresses, has completed the requirements, is now working on actually endorsing the technology proposal from other organizations. And we have ORAN, that is the new kid on the block. We have also ORAN that has also started to work. So we are very much in the midst of the 6G standardization, approaching the point of time when we are doing the technical details, no longer the visions like I had on previous slide. So trying to make it reality. Then talking about the ITU. I will focus on Working Party 5D. That is the forum that develops IMT technology. I think they have done an excellent job in shaping the 6G journey. So they have pretty much created the framework for 3G, 4G, 5G, and now for 6G that allows all of us to work with the confidence that we know roughly on how the process works. We have the ITU that sets the requirements. We have the ITU that secures the spectrum for technology. And then we have 3GPP that develops the technology that will be deployed on the spectrum. And it may sound a bit trivial, but fundamentally, this is the most important thing. We know how we can be relatively certain that we get the overall flow of technology from idea to market using this ITU 3GPP interworking. We had a successful World Radio Congress 27. We secured a spectrum item for 6G in 2031, in 2027, and what we have done lately is then a sort of maybe the fundamental milestone for the 6G is setting technical performance requirements during this year. So we have the agenda for the spectrum. We have the requirements. We basically have the two important milestones for the 6G development. And looking at the technical performance requirements, what I have shown here is a slide that shows the evolution from 4G to 5G, and then these are the blue bars and the orange bars, and then in this magenta color we have the initial aspiration or discussion on what could be potential ranges for the 6G. And what you can see is that during the discussion phase in ITU, there was quite a big range on what kind of an evolution of technology we would expect to have. Then the actual agreed technical performance requirements, TPRs, they have been marked with these light magenta dots. And I think there are 3 points that one can make on these agreed requirements. The first one, I think, is that we are definitely pushing the envelope. We are developing technology that is significantly better than 5G. So we are taking technology forward. However, we have not gone to the very extremes. We have not gone to a situation where what I would call is paper products, science fiction. We don't push the technology beyond what is feasible today. So the values that we have, they are, I wouldn't say conservative, but they are based on the industry needs, what we feel is needed and what is necessary. And one indication of that is that for some of the values, we have actually chosen not to improve over 5G. So if the requirement is good enough for in our estimation, for the industry needs for the next 10 years. We have really used these number of connections, the latency requirement, as sort of 5G values are sort of values for 6G as well, because that is what is needed by the market. Then I think one should maybe highlight that we have some new things. We have these combined requirements, for example, where we combine the multiple different requirements to create a combined requirement that is especially targeting immersive communication. So basically it is having this virtual environment created around you. And it combines the data rate with latency, with reliability. So kind of having a reliable, high latency, sufficient data rate communication. So these I think are the 3 points I wanted to highlight from these technical perf requirements. And as said, this is the key milestone from the ITU point of view. This basically tells us what kind of system we want to have from the governments, but also from industry point of view. And let's 3GPP start working on technology to fulfill these requirements. And knowing how 3GPP works, I think they will definitely meet these, and in many cases also exceed these requirements that we set forward. Then looking at what happens next in ITU. So there is still some administration work for the requirements. We need to define the evaluation environments. We need to set out what exactly are the environments where we evaluate these performances. But in practice, we are pretty much preparing now for the incoming submissions. So there will be a workshop at the beginning of 2027 here in India, where we will get the first glimpse of what kind of technologies will be proposed into ITU. There will be presentation from 3GPP, potentially from other organizations as well. And at that point onwards, I think the role of the ITU is to simply receive technical proposals and develop consensus and evaluation of the received proposals. The expectation that we would have from 3GPP point of view is that the first submission to ITU will be mid-2027. And this again is then one of the timelines to keep in mind. We really are talking about between now, which is March 2026, and mid-2027, so 1 year, 3 months, for the timeline during which 3GPP will develop the basic technology that will then be the baseline for submitting the IMT 2030 proposal from 3GPP to ITU. 1 year and 3 months. It's not a very long time. Then we have the World Radio Congress 27 coming in. This is the other important milestone. We have to really work hard to make it very clear that the technology that we have on table, the IMT 2030 technology, is the technology that is pushing the limits as far as possible so that we can secure spectrum for the 6G networks in 2027. Then after that we have the evaluation and the specs and so on. So that is sort of roughly how it will look like for ITU. Then I will take the opportunity of showing a bit more on what can we expect from maybe more from industrial point of view. So how does the 6G timeline look from the industry point of view? So this is a high level Ericsson view on how the commercialization of 6G will look like. And where we are now, we are kind of test bed standardization research phase. And this is something that will continue until the end of 27 perhaps. So during this time, we have the standardization process in ITU, we have the standardization process in 3GPP, as we have discussed. But also what we can see is that there's a lot of different initiatives. We have company initiatives, we have regional initiatives, we have government initiatives that are pushing the technology forward by doing test beds and trials and research. That has been going on for the last 5 years or even more than 5 years. However, the time for that is coming slowly to an end. So we are moving from this let's do trials, let's do test beds, let's do research into pre-commercialization in 2028. And then we would expect the first actual commercial system to happen sometime in 2030. So this is the timeline for industrialization. And again, I think it's not a very large amount of time that we have for research and experiment and trialing ahead of us. If you have pre-commercial system in 2028 and commercial system in 2030, we are talking about 3-4 years of time that we have before we have actual commercial deployments of the 6G out in the field. Then a few slides on what will 6G actually deliver. So we have a few cornerstones that are kind of areas that we are hoping to look into, and maybe the most important one that we are getting a request on is let's make sure that the technology that we develop will actually give us the reduced total cost of ownership for our customers, Ericsson customers, the operators. And this, I think, is important to make it commercially feasible for us to actually roll out this new technology that will enable new applications, but it needs to really be commercially feasible. We of course are looking for improved end user performance. I think this is an absolute need for commercial success of 6G. I am fairly confident that we will end up delivering that. We will need to support technology that will handle the data growth. I mean, we are still in a point of time when data is growing. Maybe it's not growing as highly exponentially as before, but it still is growing exponentially, and we are still facing a situation where we need to have, with not that dramatic increase in spectrum, much more bits delivered to our mobile systems. Then of course, the whole point of 6G is it's not about making it cheaper, it's not about making it better, it's about making something new. So this is where the augmented reality, AI-enabled glasses come into play. Kind of a stuff that we do not know yet, but that will look quite impressive. Then on the other side, I have some potential improvements that one could see. These are Ericsson values. They are kind of a Ericsson estimate on what we might see with 6G. Of course, we don't know that until the 6G technology is decided, but it's kind of initial first guesses. And to cherry pick some of the numbers, we have some key points, and I think one of them is the uplink performance. And what one can see is that there is a fairly high ambition on improving uplink. Even though it says we may get 25% throughput, I think we also are looking at getting significant improvement in the uplink channel access delay. We have an increase in downlink, where I think we want to double triple the downlink data rate. We are looking at the energy performance both for the UE and mobile networks, for the mobile networks and the mobile phones. And we are looking at things like position accuracy and sensing accuracy. So it's kind of a number of things that can be delivered with 6G technology. We will need new spectrum to deploy 6G. This is the Ericsson view on what we expect the spectrum for 6G to look like. And I think a couple of points to note. The first one to note is that 6G will work on all the existing spectrum. So the ambition is to develop a system that is as good as 5G, preferably better in many cases than 5G, and allow us to deploy it on low frequencies and high frequencies, both on these coverage layers, some 1 gigahertz, but also on millimeter wave frequencies. Then I think it's also important to note what is not on the slide. We don't have terahertz on this slide, so in Ericsson view, at least the initial 6G will not look at the terahertz range. That is simply too far in the fuse from commercialization point of view. And then maybe the main point of the slide is the spectrum that we would really need for 6G to fly is the centimeter wave range spectrum. So the target of the World Radio Congress 27, focusing on 7 to 8 gigahertz of spectrum. Even though we can go a bit higher, but from the spectrum point of view, this 7 to 8 gigahertz is really the key spectrum for 6G. A few more slides. One is the role of the ORAN. So ORAN is the new organization coming into international standardization. There has been quite some discussion in the industry on how do we fit in ORAN into 3GPP, how do we fit it together with the ITU. I think we have a fairly good understanding now, and the ORAN will have a complementary role. It will have a role that is the prime technical area is still 3GPP, but ORAN will complement that by defining some of the functions not defined by 3GPP. And there are two main areas for ORAN to work on. One is the open front hall. There is an agreement in a bit of a small text at the bottom left corner of the slide, saying that 3GPP acknowledges the existence of open front hall. However, the front hall is specified in ORAN. That is sort of the definitely the key area for the ORAN, and they will definitely define the open front hall. The other key area for ORAN is handling of network automation, and they have a fairly advanced concepts. They have this R apps. They have this sort of AI framework that relies on 3GPP baseline, but is really building on top of that. So ORAN is really complementing 3GPP by doing open front hall and doing network automation standards that allow interoperable applications for the automation. And with that, I have one request, and that is a call to action. So like I have tried to highlight, the time to develop 6C is now. And we need people who engage in ITU, engage in 3GPP, engage in ORAN, in all other forums. So it is this year and next year when you can make technical contributions, primarily in 3GPP. Then after that, it will turn more into specification work, evaluation work, understanding what has been done. But the time for new brilliant ideas is pretty much now. And if you want to engage, please engage in the right forums. ITUR is still the place for spectrum. So this is where we need people and governments and countries to engage and secure the spectrum that we need for the 6C. The place to engage for technical specification for our mobile technology is primarily 3GPP. So this is where you can bring in your brilliant technical ideas. The other forums, they are complementary. So if you have ideas for open front hall, for network automation, ORAN is a good place. If you want to do APIs to access the network, we have Camara, we have TM Forum. And that, I think, is really my message is, please contribute now, not in 5 years' time when it's too late. Thank you.
Thank you, Anne. I think this was really informative. I did take some notes. I think I like the phrase that we are at the end of the beginning of 6G, which is really cute. And he did also point out that we have reached a pivotal point where technologies are now evaluated and standards are about to be written. We still have 4 years for commercial solution, but I think it's 2 years for standardization and technology development, which is noted correct. And then there is a milestone which was achieved with this TPR, which was released. Of course, 3GPP has started working. That's where we will have Matthew tell us what's needed. Of course, I also noticed from his slide that there are other entities which will be developing APIs and others, which I think Nirand and others will be covering in their sessions as well. So I think TEC did a very good job packing up what is needed for the day. And then I think you sneaked it very nicely that ITU focus now shifts to spectrum. So no technology? I'm disappointed. But okay, we'll keep that for a question a little later. And then they are expecting their first solutions to come in 2029 timeframe. With that, Matthew, can you help us with what's the interesting things happening in 3GPP? Please, thank you.
So, ladies and gentlemen, good morning. Very good to be here. And I'd like to start by thanking you for your welcome to India. I'm always delighted by the warmth of the welcome here, and it reminds me of the importance of global collaboration. When we do standardization for the next generation, it requires global collaboration and working together across boundaries to achieve that. I come to you direct from 3GPP, in fact. Last week I was in Japan, in fact, until yesterday I was in Japan, where we had the 3GPP plenary meetings taking forward, indeed, the technology. So we can now talk about technology and how that relates to the ITU requirements that Janne has just explained very well for us. Okay, let me start by taking you back 1 year. One year ago. This was March 2025 in Incheon in Korea. 3GPP held the first workshop to discuss the technology for 6G. More than 800 delegates from across the spectrum of industry, from network vendors, device vendors, chipset vendors, operators, regulators, all segments of the ecosystem that have an interest in the next generation of technology were gathered there to start the discussion on what will make up 6G. We're now 1 year on, and where have we got to? This is a little bit zooming in on the timeline that Janne already introduced, and showing some of the key milestones along this journey to the big milestone, which is the one in the bottom right, commercial 6G. That's where we're aiming for by 2030 to have the technology that we're working on today commercialized and deployed, and bringing benefits to society, because that's why we do the work. We want to bring benefit to all of our lives, to the whole of society. So 3GPP operates very much in synchronism with the work in ITU. The ITU requirements feed into the technology that 3GPP then develops. And 3GPP takes that first by working collaboratively with the ITU to develop those requirements, and then to flesh those out in terms of what they mean for the technology that is then standardized in 3GPP. So in the slightly lighter blue colors of the bars on the left-hand side, where 3GPP is currently working, we have a set of studies looking into the details of the requirements and what those mean for the technology. At the earliest level, the service requirements study is actually now complete as of last week, and moving into the normative phase to define the normative requirements for the services that will be supported by the 6G specs. And in parallel with that, we have some radio access network studies looking at the high-level technology decisions that need to be taken around the RAN and the architecture in order to satisfy those requirements. And those will, in 2027, lead into the normative technical work. So some early decisions are already being made around technology in the study item, but the main detailed technology focus will then be in those darker blue bars of the normative work. And one of the key pieces of news I can bring to you from last week is around the crystallization of this timeline. I think there's been a lot of debate about what exactly is the timeline for 6G, and now we see the industry consensus converging on the timeline that you have in front of you on the screen. Targeting the final, what we call stage 3 freeze of the 3GPP specifications at the end of 2028. That freezes the technical functionality. And then the ASN.1, which is the coding for the protocol design, and the open APIs of the system, targeting then March 2029. That's still to be confirmed, so in 3 months' time we should have the definitive confirmation on that. But that seems to be where industry consensus is settling. And that then leaving just a few months for the final implementation work leading to the commercial deployment of 6G. This timeline, of course, has been a significant amount of debate back and forth. Should it be earlier? Should it be later? And I think I want to argue that it's just right. It's neither too early nor too late. It's soon enough to meet early demand, and that early demand comes from, in part, the increasing capacity requirements that we see in today's networks, the growth of data, which has consistently grown over the years. We've been very good at predicting that data traffic will grow. We've shown ourselves to be much less good at predicting where that traffic growth will come from. So we can be more certain that traffic growth will come than what will actually drive it. But it will be there, and it will drive the need for network capacity. But the time is also late enough to give us just enough time to deliver quality specifications. And that's absolutely critical, that 6G delivers on the performance that we need from it, that it delivers on an improvement compared to 5G. So the timing is just right. And now we have to translate the requirements into the technology. So there are pages of requirements. The 3GPP has developed a technical report, which you can download from the 3GPP website, going into significant detail, significantly beyond what the ITUR has produced, to define how the industry sees the requirements for 6G. And what I've tried to do here is to collapse that broadly onto one slide. If I were to categorize how the requirements describe 6G in 4 words, they would be that it has to be high-performing, a performance network. It has to be significantly better in radio performance, in spectral efficiency, in network operation than the previous generation. Secondly, it needs to be intelligent. It needs to leverage the latest technology that we have, and wherever you look, AI is going to make an impact. AI will impact how the network operates. AI will impact the traffic that's carried over the network. And 6G needs to be designed from day one for supporting and using AI. Thirdly, it needs to be sustainable. Energy efficiency is critical, and OPEX for the networks is probably one of the greatest headaches that many network operators have today. So 3GPP for operational efficiency and the good of the planet needs to be sustainable. And fourthly, it needs to be secure and resilient. I think you don't need me to explain why that's important. But let's move on and look at some of the technical details, the decisions then that are starting to be made in 3GPP around the timeline and the requirements. And first, on the architecture. Now, in 5G, you'll remember that we had multiple drops of the specifications at the beginning of 5G with different architectural variants. And that was, to be very honest, not good for the industry or for the success of 5G. What is clear from the industrial perspective today is that we need 6G to provide fundamentally a single standalone architecture that the industry can migrate to from day one. And this is broadly the baseline which fits or emerges from the consensus in 3GPP, that the fundamental baseline architecture for 6G will be based on multi-RAT, that's multiple radio access technologies, in other words, 5G and 6G spectrum sharing. As Janne mentioned, 6G will be able to operate on a wide range of spectrum, and that includes all of the spectrum that we have today for 5G. That 6G will be able to share that spectrum in a dynamic and efficient way, so that existing 5G carriers can be migrated to 6G. And with a little bit tongue-in-cheek, I could say that perhaps the best thing that 5G has given us is the ability to migrate easily to 6G. So when we designed 5G with a relatively lean carrier design, that made it much easier to share the carriers between 5G and the future 6G than it was between 4G and 5G. So 5G has made our lives easier in the migration in that respect. And then in order to achieve the aggregated data rates of 6G, then carrier aggregation is the fundamental feature by which 6G carriers, whether they are sharing a 5G legacy carrier or in new spectrum, will be able to operate together to deliver the data rates that 6G will provide. Okay. Oops, that's going the wrong way. Sorry, I seem to be having some difficulty with... Okay. So what will the 6G radio look like? Some of the key technical decisions now being made as part of the studies are derived from the need to share spectrum between 5G and 6G as part of a smooth migration. So 3GPP has been carefully prioritizing the technical decisions that need to be made early in order to provide the foundation for the 6G architecture and for implementation. And among those are the waveform and modulation, where the waveform needs to be compatible with the MRSS multi-rat spectrum sharing. And by the early decisions made to focus on the modulation schemes of OFDM and DFTS OFDM as used in 5G, that enables then MRSS to operate smoothly on the legacy carriers. And secondly, around some of the more hardware impacting features of 6G, as the timeline for implementing and developing 6G equipment is relatively short, it's important that the particular technology decisions that impact the deep hardware implementation are taken early. And one of those areas is around the channel coding. The channel coding was very heavily debated and optimized in 5G days. And in fact, I was chairing some very late night and difficult discussions in 5G days to arrive at the conclusions on 5G channel coding with low density parity check coding for the data and polar coding for the control channels. And broadly speaking, the principle for 6G has been established to continue with those as the baseline, with the possibility of some extensions for data rates beyond what 5G supported. And that enables us to build on the legacy of 5G, which I have to say in this area was actually pretty highly performing and very close indeed to the Shannon limits of what can actually be achieved. So typically when somebody comes to me and tells me that they can improve 6G by 3 dB by improving the channel coding, then I can give a very easy answer that will simply not happen because Shannon's limit still applies. But where 6G will move on from 5G is around the device types that we need to support. And there's been significant discussion in 3GPP of how the requirements that we have from the different services that 6G supports relate to the different device types that we need. And of course, smartphones will always be the largest market, and mobile broadband, predominantly for the smartphone devices, is going to be key to the success of 6G. But we also see fixed wireless access as a big growth area, providing typically very good radio conditions and supporting the extreme data rates that 6G will be able to deliver without some of the constraints in terms of power consumption and form factor that may apply to some of the smaller and more mobile or more personal devices. And the third broad area would be massive IoT, where 6G also needs to support devices that will typically have much lower data rates and different requirements in terms of the data traffic that they generate. And so what we need for 6G is not exactly a single baseline, but a scalable modular baseline that will support different device types across the broad spectrum of where the traffic will be generated. Now, Yanni already presented a similar version of this slide, so again, just to highlight that 6G will be operating on a wide range of spectrum, from the lower frequencies for wide area coverage to the higher frequencies for capacity. And some of the spectrum has already been identified by the IMT. We also look indeed very much to the coming World Radio Congresses of 27 and 31 to continue and complete the story of the spectrum that's needed for the 6G decade, for the 6G era. Seeing indeed the need for greater capacity will bring the need for new spectrum as well. But the implications of this spectrum then very much relate to the decisions that we're now taking in 3GPP. And here we come to one of the hottest decisions of the meeting in Japan last week, around the maximum channel bandwidth. So as we look at the wider spectrum bandwidths that operators will have, we need to make sure that we use that efficiently. And it seems very clear that there will be many operators who have spectrum wider than 200 megahertz in the 6G timeframe, and therefore having devices that can support those wide bandwidths with a high level of efficiency is very important to the success of 6G. And so very happy to report from last week that 3GPP was able to agree that not only will the 6G system, the network, the base stations support single carrier bandwidths of 400 megahertz in both uplink and downlink, but also from the device perspective. We're now stretching the capabilities of the devices to take advantage of what technology can achieve. And support for 400 megahertz as a single carrier in the device in the downlink will also be achieved by 6G, together with 200 megahertz in the uplink and the possibility of adding devices with wider than 200 megahertz uplink in the future. Now, another interesting implication of the spectrum is that it's been identified as a key requirement of 6G that we can deploy 6G at the higher frequencies using or reusing the mid-band site grid that's commonly used for 5G. So being able to deploy 6G around 7 gigahertz, 7 gigahertz, delivering the same coverage as 3.5 gigahertz site grid. And that's not science fiction. We have in Nokia a nice demonstration at our headquarters in Finland, showing indeed that this is perfectly achievable by a number of techniques, including, of course, the increase in the number of antenna elements that can be achieved within the same antenna aperture derived from the higher frequencies. And this performance is critical for wide area coverage. I know in India this is one of the priorities, to give not just wide area coverage, but really focusing on the cell edge performance and also the uplink coverage as well. Now, as for the traffic that 6G will carry, undoubtedly a lot of the traffic that we carry will be based or derived from AI. So we'll have new AI applications, but we'll also see the possibility to use AI to optimize the network. And 3GPP is working on both of these. First, looking at the AI traffic and other kinds of traffic, we're moving towards what we would call a service-aware RAN. So the RAN needs to have information that will enable it to understand and adapt to the different characteristics of the applications, including AI, XR, cloud gaming, video streaming, and so on, in order to deliver assured end-to-end user experience based on the understanding of the service characteristics. But on the other way, we use AI as our friend. And here we have a lot of discussion in 3GPP around the different areas where AI can benefit and optimize the 6G radio. A lot of that relates to reducing the overheads by looking at the CSI feedback, the beam management, the reference signal overheads, the mobility measurements, the energy saving, a whole plethora of areas where AI-based optimization can enable 6G to reach new heights in terms of its performance. And 6G will also couple for the first time from day one in a collaborative and complementary way terrestrial and non-terrestrial networking. So we see different benefits that terrestrial and non-terrestrial networks can bring. While the terrestrial networks very much excel in capacity and latency, the non-terrestrial networks can help with coverage, with steering capacity to where it's needed, what we've called dynamicity on this slide, and with resilience. And we have a challenge there in 6G to ensure that NTN operates in a harmonized way with the terrestrial network, with a common air interface that can be easily implemented in the same devices, direct to the smartphone, and with smooth interworking and mobility independently of GNSS in 6G. Energy saving, of course, is also critical. I mentioned at the beginning the sustainability and absolutely security, where we face an ever-increasing range of threat vectors attacking different areas of the system and fake base stations, for example, causing new challenges for us in the network. These aspects need to be, of course, thoroughly included from day one so that we develop security for tomorrow, today. And finally, I want to end with sensing as a new application. And here we recognize a range of different sensing applications. We can't predict today how 6G sensing will be used. It's very clear that detecting drones UAVs is an obvious example. But I've always liked, from when I was chairing the sensing sessions in 3GPP, the example that came from the Indian Railways. If we can use the cell tower network to detect the wildlife on the railway lines, then that might help to make the railways safer for us all, as well as enabling communication. So in summary, 3GPP is now full steam ahead for taking the decisions to define 6G. We know what the requirements are now. The timeline is clear. The key decisions are being taken for timely implementation according to the prioritization that's needed for implementation. And all the foundations are now being set for a high-performing, AI-native and service-aware design for 6G. Thank you.
Thank you, Matthew. I think a quick summary about what he mentioned is, if you can get a hold of these slides, then you have everything 3GPP did until last week, right? So, and he also touched it very nicely, right? So, beginning with mentioning that standardization of the next generation solution requires global collaboration. And then you're also stealing some nice thoughts: soon enough, late enough, to be all right? So which is all good. And then we also touched on several topics, including AI for RAN, ubiquitous 6G, energy saving, security, sensing. I was watching the room, and every time he actually had a talk, there is a section of the people whose face blowed up. I'm actually working on it. So yes, it's a 6G topic, right? So which is very good. Thank you, Matthew, for that. With that, maybe you can have like 2-3 questions from the audience if we have. I would request you keep it brief. We are over time. And also please mention who is it addressed to.
Who is asking?
Yes.
Good morning. I am Ashok Jha. I am Principal Advisor in TRI. So from both the speakers, what I have got is that probably the timelines are getting extended. What we used to hear, what we hear today, maybe that is the reality that we hear it. But probably timelines are getting extended, and probably the doubt is that it is due to the spectrum. You are already looking towards WRC 27 and probably to 31 also. So that is my first question, that how, or rather maybe the only one question, that do you really feel that it's getting extended, and do you still you are asking for the support from industry to collaborate so that this can really pick up? So is there a fear that probably things will be slowing down unless until it is pushed really in a better way? Thank you.
Yanni, if you can take this question.
Which of the microphones picked up? Maybe it's this one, yes. I have to say, when I started working with 6G, that was 2018, as sort of Ericsson internal processes, I drew a timeline for 6G, and that timeline is still within 3 months accurate of what we have. So I would say that the timeline that we have had for 6G is something that we have consistently applied throughout these years. I do not think that we are extending it. I don't think that we are slipping. I don't think we are lacking momentum. If anything, what we are hearing from number of operators is an increased interest in 6G, much less questioning on the need of 6G. So I would say that at least from my point of view, I feel that 6G is really picking up momentum at the timeline that we are exactly predicting from the very beginning. So maybe it's a bit optimistic view, but at least I feel very confident that the timeline we have is exactly right. Okay, then on the spectrum, that I think is a much more difficult question. So sort of on the spectrum side, of course, the main focus is World Radio Congress 27. This is where we would need to get the spectrum for 6G. Then it's not an easy meeting, but I have worked with my Ericsson colleagues and other colleagues in ITU before. I have high expectation that they are able to deliver. Even when it looks impossible, they are able to deliver the spectrum that we need. So my expectation is that, yes, we will get spectrum in 27. It is tough, it's not optimal spectrum, but being an optimistic person, let's work towards 27, not 31.
Thank you, Yannick. Be positive, that's the symbol. Yes, sir, please.
Yeah. So my question is to Mr. Yanni and Matthew. So a lot of complexities are there in the new generation networks, and you talked about the performance, and the peak performance or the average performance, cell edge performance are varying by a ratio of more than 100 or 1000. But service-aware networks are there, AI natives are there, a lot of data will be utilized. So with this complexity, regulators, it is becoming challenging for the regulators to regulate and observe the performance, because users see a difference between the promises and the expectations from their angle. They see the peak, they expect the peak performance while the actual performance may be very different. And regulators with the technology or with the deployed networks which are morphing themselves on a regular basis to serve the demand. So they used to be observing a rigid kind of a structure for their performance management. Whether standardization is also dealing with the regulatory layers where intent of the regulator can be translated what they want to see, and on a continual basis that can be observed and that can be presented to the public.
Can you take it? I think it's more like the role of regulators in 3GPP and other standards bodies.
I think what you very helpfully highlight is the distinction between some of the headline requirements, the peak data rates, and the actual user experience that's delivered in reality. And that is, of course, something of great import to regulators. That's a bit reflected in some of the discussions around the ITUR performance requirements that we have for IMT 2030. So the emphasis on peak rate is very visibly not the only driver of 6G. And I think the two areas I would really see a strong consensus that we need to work on for 6G are, first of all, cell edge performance to get more uniform coverage for the end users, and secondly, the uplink data. So previously, networks have typically been more dominated by downlink traffic, but that's already changing with the traffic patterns that we see today, and we expect that to change more with new types of traffic, both AI and XR related traffic. We see more uplink content being generated. And that's where then indeed service awareness comes in as well, that the network has to have the information that it needs from the devices to be able to handle the traffic in a way that delivers the end user experience. And although we did a little bit of that in 5G with quality of experience standardization, what I see today is a much stronger awareness across the industry that regulators should be able to take comfort from, that both the device side and the network side see the importance of that optimized traffic handling.
Yeah. Last one small
Sir, I think
question.
we are over
Yeah,
time.
I think just one question if you can.
Yeah. I'm Rajesh
Hello.
Gupta from National Communications Academy. So, just want to pose small question. In the technical performance requirement, what's shown by Mr. Jane, is not given any comment on ubiquity requirement or end-to-end integration or D2D type of communication in the technical performance requirement. So, are they being considered simultaneously or separately?
Yeah, it is true that I did not highlight the requirement on ubiquitous connectivity. It is part of the requirements. It is true that it will be addressed by the proponents when they submit technology. There will be different ways of addressing that, ranging from using satellites to using extended range and so on. So I think from a requirement point of view, yes, it's part of the IMT 2030 template, and yes, it needs to be supported by the technologies that come into.
6G would be able to kind of have the same kind of network requirements as 5G in 3.5 gigahertz for the 7 gigahertz as well. But the fact remains that the 6G will be more effective if it is kind of launched in 100 gigahertz bands or so, because the real capacity and the latency requirements will be met in that area. So how do we see that the network requirement for 100 gigahertz and above would be able to kind of meet the operator's cost of network deployment, which will be approximately 5 to 6 times that of the 5G. And in terms of the applications, just we saw in case of 5G, EMBB is the most dominant application so far as monetization is concerned. So how those services will be monetized to kind of recover the cost of deployment and the spectrum in 6G?
Sir, thank you so much for your question. We'll take your question offline. We are running short of time. Thank you so much. And once again, thank you so much, our session chair and speaker, for your insightful perspectives. So as a token of appreciation, we will now present mementos to the session chair and speaker. For that, I request Shri Rakesh Desai ji, DDG Radio, to kindly come forward and present the mementos. Can we have the mementos, please? I request sir to kindly present the memento to Dr. Vinoj Babu James. Can we have a big round of applause? A memento to Mr. Yani Pesa. And a memento to Mr. Matthew Baker. So once again, thank you so much, everyone. Thank you. Thank you. So without further delay, we now move to session 2, titled 6G, Network Architecture. This session examines the architectural evolution of 6G networks, focusing on both RAN and core network transformation towards cloud-native, service-based, and programmable architectures to enable scalable IMT 2030 services. To chair this session, it is my privilege to invite Professor Prasanna Chaporkarji, Department of Electrical Engineering, IIT Bombay. Can we have Professor Prasanna on stage, please? Professor Prasanna has been serving at IIT Bombay since 2016 and previously worked as a researcher at NTNU, Norway and INRIA, France. His research focuses on wireless networks, resource allocation, scalable 5G and 6G architectures, multi-rack systems and telecom network security. We welcome you, sir. So now let me invite our first speaker of this session, Mr. Nirant Amok, Head of Apex Standardization's Leadership, Nokia. We welcome you, sir. Kindly take your seat. Mr. Amok drives strategic efforts in shaping global and regional telecom technology standards. His work focuses on 5G evolution, 6G systems, network softwareizations, and AI-driven automations. He also serves as the chair of the Services and Solutions Study Group of TSTSI. We welcome you, sir. And our next speaker for this session is Professor Rohit Buddhiraja from IIT Kanpur. Kindly take your seat, sir. Professor Rohit led the development of India's first indigenous 5G network, which has been now transferred to industry. He's currently led a government project on 5G plus and 6G standards and serve as a vice chairman of the Bharat 6G Alliance. We welcome you, sir. So now may I request Ms. Mudita Chandraji, ADG TX, to kindly present the bouquet and welcome our session chair and speakers. You kindly present the bouquet from here. Okay. So may I request Ms. Mudita to kindly present the bouquet to Mr. Prasanna. Bouquet to Mr. Nirant Amok. And the bouquet to Professor Rohit Buddhiraja. So Prasanna sir, the stage is yours now.
Okay, good morning everyone and welcome to this second session. We have very exciting session with two very renowned members to talk to you about both core networks, what are the changes required, and also RAN. So I prepared few slides just to introduce the session, but I think after what Yane and Matthew has presented, these slides are pretty much redundant. However, since I took some effort, I will quickly I'll quickly just rush through them and sort of revise what Yane and Matthew had talked about. So for slide change. Okay, so all these things. So I'll skip this slide, and mainly this slide tells the agenda that we have and why this session is so important. Okay. So in this slide you can sort of when I was thinking about 6G, right? So I was specifically driven back to when 4G was introduced. And from a common person's perspective, 4G brought a lot bigger change in his life when he moved from 3G to 4G. Unfortunately, 5G was it came and it went by without a common person noticing it. But after what Jan said and how the picture he presented about what 6G can bring, what kind of application 6G can bring, I think 6G, everybody is looking forward to 6G, and it can cause the second disruption in the communication and the applications that it is going to enable. And to do that, basically IMT 2030 has few key things that they want to achieve through this. One is inclusivity, ubiquitous connectivity, sustainability, innovation, interworking, enhanced security and resilience, and standardization and interoperability. Okay, so I think Matthew put it in 4 nice things. He said performant, secure, intelligent, and sustainable, right? So now when you have to achieve these things bring some unique, I don't know why this is not working, but okay, right. So, okay, so key applications new applications that 6G network is targeting is energy efficiency and sustainability, ubiquitous connectivity, AI and communication, and integrated sensing and communication. Okay, so essentially, we want the upcoming 6G network to be sustainable and intelligent. Now, intelligent means we will have to use a lot of AI, a lot of deep learning on the devices, in the network, and in my view, this is one of the most disruptive thing that is going to happen. So until now, from 4G to 5G, we always thought of a network as a bit pipe, right? So whatever application we build, communication needs of that application will be sorted out by the network that we have. Now, when we go to 6G, and particularly when we want to support intelligence and use intelligence to optimize our network, so AI for network and network for AI, both these things, then the network is not only a data pipe, but network will also able to support intelligently the computation requirements of different applications. And this will change the way the traffic flows in the network. As previous speakers pointed out, until now, most of the traffic is a downlink traffic. Now, with the advent of AI, where the cloud computing based on the data gathered by the UVs will be one of the key things, lot of traffic may turn out to be uplink traffic, where people are sending their data for getting the AI driven inferences on them, right? Moreover, a lot of application or the devices which are constrained in the computation may require network support to carry out their computation with the QoS guarantees that they want. For example, if you have a critical applications like self-driving car, they want a very low latency AI support. So network is not only a bit pipe in this case, but network has to actively participate and enable these AI applications. The second thing that is going to happen is it may lead to so if you have a lot of AI driven applications which use deep learning models, then all these models need to be updated time to time, like what we have app updates happening in our network. And these large models getting downloaded on many devices will encourage the need for a broadcast kind of a service rather than a simple unicast that we use right now. So though there are broadcast related standards in 5G, it is not really implemented as of now, but as we go to 6G, maybe they will become very, very important. The second aspect is sustainability and security. Now, both these aspects will require you to collect data from various parts of the network, from RAN, from users, and from inside the core, and how this data has to be collected, what are the processes to be followed, how this data to be stored, how this data to be utilized and drive the intelligence in the network. That is going to be another key point that the 6G has to address, right? And this brings us to this current session where the two eminent speakers that we have will explain how these things can be brought in through the changes in core and through RAN, right? So Nirant Amogh, as was introduced earlier, is a very eminent researcher. He heads standardization activities in Nokia, and I'm fortunate to had opportunity to interact with him and work with him in the past. And he will be talking about the core architecture that is going to enable our new shiny 6G network. And Rohit, he is a faculty member in IIT Kanpur. He has worked on the 5G testbed, indigenous 5G testbed project, and he was instrumental in designing the RAN part of that. And he is going to be talking to us about the RAN requirements for 6G. So we have both industry viewpoint, academic viewpoint, and this session is going to be very, very interesting. So I don't take any more time from them. We are already delayed. So I invite Nirant to start his talk. Thank you.
Namaste everyone, good morning. So today's session, thank you for giving the background and setting the stage. In this session, we'll be speaking more on the transformation that we are going to see, technical transformation that we are aiming to see in 6G. I will cover the core network aspects, and Professor Rohit will cover the RAN aspects. We'll start. So my agenda, I'll keep it simple in the sense saying that quickly we'll go through the ambitions that are set forward by ITUR and ITUT, in that sense the entire ITU community, in terms of IMT 2030 and services, and which we popularly will now going forward also use the terminology of 6G services. And I try to divide my perspective on architecture, both from how the industry views it and the standardization bodies are viewing it, into around 8 aspects. So system, AI native. Of course, I'll stick more on the AI native part. I think that is going to be more interest of people in here to see how AI is transforming 6G, and especially from a core network perspective. And of course, there are other aspects like modularization and optimizations related to newer services, and how are we going to look into exposure parts, which is the APIs, and also briefly touch upon sustainability, resiliency, and security. And I think, yeah. So on the, I mean, this is something that you've all seen in multiple ways. Maybe there's another way of showing it. What I try to do is also not give you what the labels, right? I'm just giving you the numbers here. So as you can see, if we have to look into the 6G services, the requirements and the KPIs, they're bucketed into at least 6 type of aspects, right? Like one is immersive communications. I think in 5G also you had immersive communications more from an enhanced broadband perspective. Then you had, of course, ultra reliable and low latency services. Now in 6G we term it as hyper reliable and low latency services. Massive communication, and all the numbers that you see, they are much, the expectation is much beyond. Is it point of children? Yeah. Much higher than what we saw that in 5G aspects. And of course, ubiquity connectivity, which also includes the NTN aspects. And of course, newer services like integrated sensing and communications, which have more KPIs and also service requirements from 5G. And AI native communication, of course, AI was supported in 5G and now is becoming more native in 6G. And also some of the cross-domain targets, let's say in terms of positioning and synchronization aspects and efficiency and sustainability. So given these aspects about services, right? So we have to design a network and its architecture where, of course, RAN needs to support many aspects, and also core network needs to also scale in a way that we see. So I think I'm sure the audience is also very comfortable with 4G core network architecture and 5G core network architecture, and probably I'll try to build on these aspects going forward in the slides. Let me try again. Oops, how do I go back? Can I take things back here? Other button? Oops, thank you. Yeah, so while the networks, right, today's networks we are seeing, we saw them now, they are very good at connecting people, devices, right, and also quite reliable in that sense, right? And they're optimized for a lot of the speed, coverage, and capacity, but they are behaving as data transport networks, right? In terms of the value chain of what we see as services, they're mostly the connectivity and transporters of data, right? And it has been in the legacy of these networks that they do that, but with all the revolution and evolution that we are seeing from AI, right, with large language models in place, so these are actually kind of redefining the network needs. So the network expectation, especially aspects like AI agents, right, they are redefining the way the networks would be part of the value chain of services that we are seeing. So all the services that we saw previously, and the way AI is going to redefine it. So now we are moving from just connecting data to now connecting intelligence. What that means is AI is not just going to merely be using network as a type of a tool, but be integral part of the network in reasoning, in automating things, understanding consumer behavior, self-adapting the networks. So we are going into that era, and this is the interesting part of the evolution of the 6G system. So as I mentioned, I'm going to bucket this core network aspects, and especially the architectural aspects, into 8 aspects. One is, of course, the 6G system architecture itself. Then I'm going to touch upon the AI/ML native architecture and how it is aiding automation. What are the aspects of that AI would be offering from the core network perspective. Then I'll, given the paucity of time, I will also quickly touch on what is the aspects of modularity, optimizations for new services like we're seeing for sensing and immersive communications. And an important aspect as to, of course, we all see that, okay, network will do a lot of things, but then how about the verticals? How can they consume network capabilities? So how is industry looking into a unified network exposure framework? And then quickly on sustainability, resiliency, and security. So the first one, in terms of 6G system architecture, I mean, this particular picture might be very familiar to all of you. Does it look very different from 5G core network architecture? In some aspects, yes. In some aspects, no. So what it means is we're going to reuse, and for the core network architecture, we're going to reuse the 5G core network architecture and expand it to introduce new network functions with open interfaces in 6G. So of course, the 6G ran as an initial element of it. We will have the 6G RANs, both terrestrial, non-terrestrial, the N3 IWF is the Wi-Fi interworking, and the 6G UE, all consuming 6G services directly from an enhanced version of the 5G core. So as speakers were telling today in the morning that, of course, 5G, when it started providing 7 architectural options, and now they're popularly implemented into as non-standalone and standalone. But in 6G evolution, we will only have a single architecture, and we will see more in today's session later down by different speakers of how the migration towards 6G can be done. And of course, what we mean by we're going towards 6G is that if there is 5G network today, there's going to be a smooth migration path towards the 6G core. Right. So in that sense, of course, everything will be available from day one. Maybe the wireline access would be something that we think would be an aspect that will come a little later. But considering this, the core fabric of 5G core network would be based on the service-based interfaces. And as you can see, the philosophy of 5G core network was based on modularity, in a way, keeping independent functions and then allowed to scale. So that is going to help. And this architecture will then also support, now going forward, an aspect about AI. So now how that is going to happen? So the first aspect is in terms of AI native 6G. So we have to understand the value creating potential, right? So why do we want to introduce AI into the core network, right? Of course, perspective like cost efficiency, performance, I think we all understand that, and that's going to aid revenue and growth. But if you really look into the buckets, right? So first aspect, very critical aspect, is the data. So 6G is going to 5G on the later side, and now with 6G, it is going to see data in a very different way. So very curated way of handling data. So the need for something like a data framework is emphasized. Then an aspect of how will the network offer AI as a service, right? So of course, there are a lot of businesses that they are handling AI by themselves, the big enterprises, but let's say from a use case like in India, telecom, everything is centered around telecom, right? So telecom becomes the first user or first network that somebody experiments their use cases on. So in that sense, I think AI as a service will become very important. Next is, we've all heard about agentic AI, a lot of autonomy and a lot of things that gets done on behalf of the user and on behalf of, let's say, humans. So we would also see how agentic AI systems will get integrated into 6G. And rest of it, of course, there are aspects like, of course, when we have AI powered solutions, we will see enhanced customer experience. We will see better handling of security and trust, and also sustainability and energy efficiency. So AI helping with energy efficiency of the networks. So the first aspect about data. So data is the foundation and fuel of AI. So here the aspect like data collection for the network's own continual learning, and then as we progress towards agentic AI, so the new data requirement which helps the agents to plan and orchestrate things and then execute more in terms of a goal-driven perspective, right? So we are transforming towards seeing the network saying that we give a goal and the network is able to realize that particular goal by organizing itself and adapting to different situations and context, right? So data is very, very important. And now we have to rethink from a perspective of from 5G, what is that we'll reuse? So in most of my presentation, you will see these three things. What is that we will reuse? What is that we will redesign? And what is that we will reinforce? So 6G is all about these. So in terms of course, reuse, we have seen the architectural perspective that will be reused. In terms of redesign, I think the way we will look at data aspects and the way data is going to be handled, the initial elements are going to be there in 5G and then a more pronounced framework in 6G. So the CSPs, the device chipset vendors, the infra vendors, everybody will need to share data amongst themselves, and especially hence the data collection requires standardization. So data is a fundamental element that will be the key game changer as we see going forward in enabling a 6G or let's say AI-oriented 6G. A bit peek on 6G data management framework. So this is the architectural perspective. I think you guys understand RAN, core network, you see the UE, and then you also see the network and the service management and the automation blocks. So three key elements come into place. One is the collection. As you can see, there is a data functionality that is there is a requirement of this data 6G data functionality across all the domains of the network, RAN, core network, and the network and service management and automation. So data collection is important. All elements, right from UE, the RAN entities, core network entities, and even the application, external application entities will all kind of feed in data into the 6G network. And then we would also have the management network, which is getting that insight. And in one sense, what Kadyanji also mentioned, how to obtain a real-time insight into how the network is operating, right? So this type of aspect will come into 6G. So this will be standardized in terms of collecting data. Next is also providing access. So who will have access to this data? So we need, which needs to cater to privacy preserving aspects and also to external sharing, like to non-6G system aspects, this 6G system entities, right? So they will also be the consumers of data. So how to provide access to them. And then there is an important element of how the data is going to be processed, right? So the output of data access and exposure, they need to be processed. And this architecture, so currently right now the discussions are ongoing in terms of it's centralized, distributed. There are so many models being discussed. So this is, as they mentioned, this is the right time to get engaged into these discussions. But these are the fundamental aspects that are going to transform the way we look at 6G data management in 6G. Next is a bit more about data. And when we see data, and I think we've been always looking at, I just also pull out an example about how we have been dealing with data, right? So you're all familiar in terms of the way information goes today. It's going like XML. Some are structured in terms of XML, some are unstructured, right? So even the way the data is moved today is in terms of, okay, there are labels of the data and there are values. And then somewhere down the line, I think we have a lot of rule-based systems where we provide rules and we try to extract knowledge out of these data, right? So in 6G, what we perceive is that there will be more emphasis on what we call as knowledge management. So how to relate these data items more fundamentally, and then kind of structure them in a way that it is structured well, because we know that there are technologies like knowledge graphs which we can use. We can structure them and then they can be exchanged. And then this knowledge graph, when processed, it can also help in creation of new knowledge as well. So this is an element that we see from a network aspect that is going to be included, where knowledge management, we will move from not just data transport to data management and also to some level of knowledge management. And that knowledge management will translate to what we call as business wisdom. So the operators, the users, they will all have insight into aspects of data, an aspect of knowledge, and they'll be able to now say that they want to trigger a new service or they want to optimize the network. So for different users, there are different views. So that's another aspect that we will see in 6G. The third aspect is AI as a service. So in AI as a service, of course, there is going to be data, then as I said, a lot of applications would want to use for them, the first time that they may use AI in, let's say, small to medium enterprises, they would see the big larger enterprises who could host them in terms of those AI services. But I think this is an opportunity also for the telcos to offer AI as a service because of their large scale deployment, right? So they can cater to every part of the region in the country. It's a country like India, so huge, and the smaller businesses that are there and they want to utilize AI, they need those services more closer to them. And the only provider in large countries like India are the telecom operators. So they would then there'll be a demand for this AI as a service where they can offer services like training, inference, like testing, like explainability and everything. So those type of AI services, and also they would expose the data capabilities and the knowledge aspects as well. So this would also be on demand. So one of the aspects of the exposure would be that, let's say the UE has applications, then there are network applications, or let's say vertical domain applications. They all can consume this telecom network more as an AI as a service. So important aspects is this data and AI services, they need to have interoperable mechanisms. So an aspect like how we, let's say, perceive intent, maybe more structured intent, so that it does not hamper a lot of interoperability issues, especially in a multi-vendor scenario, will be the aim. Next is the agentic AI system. So now, before we start looking into, of course, it is proliferated much now as we see, but in terms of 6G networks, the way agents will play a role. So there will be, of course, we have to cater to, first is the telecom network has to cater to a lot of these AI agents in the vertical domains, right, outside the 6G network, and then enhance themselves also with agentic capabilities because of autonomous, how to improve network performance with the least latency, keep human in loop, but reduce the latency of human decision making, right? So these are aspects that will play a very important role in how we will start seeing some of these network functions of the core network being upgraded with agentic capabilities. But the interactions between them will still be controlled. So you may ask that if there is agentic capabilities in NF and the other agentic capabilities in NF, are we looking at some kind of A to A type of a system? Of course, that is the final evolution that we want to see. But now from 6G, we would see that the service-based interfaces would deal with structured intents. So a network function talking to another network function, there should be a very structured intent so that the indeterminism factor does not break interoperability. And telecom system also supports roaming. So in any case, we do not want the way that AI agentic systems are going to be implemented, they impact roaming. So we take care of these two aspects, and there will be an interoperability enabled agentic AI 6G ecosystem that will be supported by the telecom operators via their 6G core network. So what does where are we right now, right? So in terms of what 5G did, we already start seeing those elements of AI within 5G, and it is making the AI work. So that's how I put it. So it's making AI work, but in 6G, it will make AI more trusted, right? So you could have more control, network will have more control over the UE, network will have more control over the devices and the AI data collection points, so that there is an understanding of misbehaviors, there is understanding of aspects, and network could control those elements as well. And the other aspect is trustworthiness will be improved, so explainability will be integrated into the core elements of 6G core network, and it would also support a huge testing framework as well. So now when we look into 5G and 6G, making a bridge in this way, so now what we see is there's a dual nature, right, in terms of what AI is posing on the businesses today, especially on the telecom operators. So AI consumes network, and also network consumes AI. So this is a dual natured thing. So in that sense, so the standardization world will not look into standardizing models So we will not look into standardizing models, but what we will look into is creating a framework and enablers which will proliferate the usage of AI and agentic AI as well. So an entire framework, as you can see in here, which consists of course, an end-to-end AI lifecycle management with AI proliferated into all domains, and they would be interacting with some harmonized APIs in a bi-directional way. Between the other enablers that the network offers. Of course, both from the AI enablement capabilities, as you can see, there is a catalog of those capabilities, and then there is also the data capabilities. So this is what we're going to eventually see from a very high level perspective when we look at 6G, and this is going to be the value provider for the telecom operators. In fact, my time shows us up, but I hope I have 10 more minutes. So I think the most interesting aspect of AI aspect is included in 6G. I think that was the most interesting part of the transformation. But then I will maybe quickly skim through the others so that you get a view of the key messages. Support for 6G device types. So as you can see in 4G and 5G, so we had ways of different categories of course, devices that catered to, let's say in 4G we had NB-IoT right up to very lower bit rates to a very high LTE categories of 100 Mbps. Similarly in 5G. In 6G, we are going to see all of them bucketed in a uniform perspective from day one. So there will be native support for all these different 6G device types. Slides are not moving. Yeah. So an interesting aspect, as I said, is redesign. So until now, we were from 2G to 5G, we were already considering that a single one-size-fits-all design, but we are moving away from that, where we'll have a more modular radio protocol as well as an ASP protocol. So that means that it will support diverse use cases and diverse devices, right? So you could, if you want a very low-cost UE, you could have the, let's say, anchor protocol, and then you can have additional processing units. While also in the NAS, you could have the elements that you want. A very low cost UE could just have the mobility management NAS functionality, but mainstream UE and high-end UE could also combine other like policy control and location and session management type of functionalities. Next, interestingly, in terms of services optimization, so you all know that we will start seeing glasses, and the glasses would process a lot of information. Of course, there's a limit to it, and then when we see the network, so we also see that they are also scaled with edge, and also now with AI and RAN, we would have a lot of compute also available at very close to the user connection point, right? So in here, there is an element that the processing can be offloaded, right, on demand to the network. So what this means is, if a UE is running, let's say, processing elements A and B, and the network, it can communicate with the network and decide to offload B, considering that there is a placement location with a very low RTT and also meeting all the QoS perspectives and the compute requirements for B. So these are the type of enhancements, or let's say capabilities, that we will see in the way compute is organized evolving from 5G. I should stop? Okay. Yeah, I will. So it's an architecture topic. I mean, it's very difficult to squeeze in anything in 20 minutes. So I put a timer of 20 minutes, it has got up. So I don't want to eat your tea time as well. So let me then skip through this. Maybe one last slide on unified northbound exposure. As we were discussing, there will be different layers of exposure, and it needs to be done in a nicer way, because the whole industry is exposing different capabilities, both as we said, data, AI, fundamental network capabilities. So what we envision is there is this framework from 3GPP called as CAPF. So that is going to be a unified framework for exposure in 6G. Until now, it was only applied to network exposure function, but now it will also apply to O&M and any other, let's say, capabilities coming in from maybe IETF, ORAN, and others, right? And that network capabilities will be translated to what we call as application-bound APIs, and that's where your camera work would happen, where they will work very closely with the application layer, define those APIs, when it will go through this value-added network platform, which will translate and then invoke different services in the underlying networks. So maybe I'll stop here with the key message in the last slide that I would like to show with you is that 6G, one is we are reusing a lot. So the investments are protected of the operators. They need to do a lot of upgrades, but we would emphasize on reuse. There are some shortcomings for which redesign is required. And then, of course, we are reinforcing that some of the things that were already applicable in, let's say, or provided in 5G, they need to be applied also on 6G in a uniform way across all domains. So reuse, redesign, and reinforce would be the key technical directions from a core network perspective that I'd like to let you know that the way 6G is going to be designed, 6G core network is going to be designed. Thank you.
Thank you, Nirant. And I am sure all of you must be having a lot of questions, but we can take them at the tea. So best thing about this session is after this we have tea and coffee. So with refreshment you will have speakers to talk to as well. Please, Rohit. So go on.
My slides, please. So I'll begin by this session by saying that I'm a teacher, and if you give me a mic, I'll take 50 minutes. That's the minimum duration in which I can express myself, but I've been told to, like, this is a 20-minute session, so I'll restrict myself. Then my topic is RAN evolution for 6G. So I'll immediately get going with what I intend to cover over here. So, okay. Can somebody help me with this? How do you like? No, next it's center पीछे reverse के लिए So this slide basically states the holy 6G goals. Let me begin by how do we want to design 6G, and how does all this philosophy percolates into RAN design. So the first thing is we want to have better customer experience, and basically how do you improve customer experience? By providing them high quality service and ubiquitous coverage. Of course, there are a lot of other aspects as well, and we need to design the 6G such that it is efficiency in terms of reducing the cost. And all of us are talking about AI-driven automation and how AI can enhance the quality, how AI can enhance the efficiency. I'll briefly cover that, and sustainability. So there's a lot of talk about energy. Okay, so how can we make the 6G network green? How can they be more energy efficient? And I'll briefly touch upon how AI can help, and though they are conflicting objectives, AI consumes a lot of energy, but can it help us in saving energy? And that's what I'll talk about. And of course, we have to think about operators. Like when we design 6G, they should be able to make money. They should be profitable. Okay, we hear that in 5G operators have not been able to make money. So how can we design 6G such that all of us are happy? Okay, so let me get going with this. I'll keep coming to these 6G goals. I'll start with customer experience, wherein I spoke about ubiquitous coverage and high quality services. So let me move on to the next slide. So this is what I'm going to cover. So we spoke about this high quality service, and when I talk about it, it's basically immersive communication, and we talk about Internet of Senses. Okay, can we basically design 6G such that it helps us in transmitting senses, and whatever sense we intend to transmit, then basically you increase the data rate. And 6G is being designed to support bit rates of downlink bit rates of 36 gigabit per second, uplink bit rates of 18 gigabits per second. Earlier speakers also spoke about that. So this basically is a repeat of what has been said earlier. And but at the end of the day, all this is going to support holographic immersive communication. That's one idea, and in this way we can enhance user experience. Okay, that particularly happens in all the generation, and 6G is also going to do that. And RAN, we have to design our RAN. So I'm focusing on broad aspects of RAN, which will basically help us in delivering that promise. Okay, so and now immersive communication spectrum, okay, how, like, what spectrum, which is the spectrum in which 6G is going to be designed. So there'll be support for existing spectrum, FR1 and FR2, but the performance and efficiency needs to be enhanced in the existing spectrum. We are going to reuse that. And the support for new spectrum in upper mid-band is also critical. So if you go towards the lower end of the spectrum, basically you have shortage of spectrum, but that gives you a lot of coverage. If you go about the right end of the spectrum, there's a lot of spectrum, but the coverage is very limited. This is the sweet spot which we are talking about, between 7 gigahertz to 24 gigahertz, that's 7 to 13 gigahertz primarily, okay, wherein we have both a mixture of coverage and capacity. Okay, so operators are looking for like 400 megahertz of spectrum in this band. So that's where the 6G will be designed. Okay, and now, so in this band, when we speak about this new band, so we are talking about new kind of MIMO. And so you look at this, wherein for the same form factor, wherein we had basically in 3.5 gigahertz, you could have 64, 128 antennas. Now, when you move up the spectrum a little bit, okay, you can, in the same form factor, you can support many more number of antennas. And if you look at this, so there are like, earlier if you could support 64 antennas, there in the same form factor, close to 3,000 antennas you could support. Okay. Now what this leads to basically is something we are moving on to something near field MIMO. Okay, so what it helps us in, basically, that you have earlier in 3.5 gigahertz, the wavefront was actually planar. Now you have so many antennas, then the wavefront starts becoming spherical, and you can support lot many more number of users in the same spectrum. Okay, but so now if you are supporting these large number of users, you need to design your system accordingly. Okay, so what we are looking at basically is supporting minimum number of 128 antenna ports. That is one. Okay, then can we have a unified codebook for diverse mobility scenarios, wherein we see, if you are working on 5G, there are multiple code books which are defined for different kind of scenarios. Can we have a single code book which is simple, which can support diverse mobility scenarios? That's how we need to design this 6G RAN. Okay, can there be efficient beam management and channel state information reporting? So these are the problems what we are looking at when we are designing the 6G RAN. Okay. And then to support this like ubiquitous coverage, we are talking about, 6G will be the first standard which will inherently support terrestrial, non-terrestrial networks. So I've given you a broad like how this NTN and TN integration will pan out. So you look at different altitudes in which different kind of non-terrestrial networks will be supported. So you have HAPS, you have high altitude platform system, you have UAVs, and there are very low Earth orbit, LEOs, VLEOs constellation, then you have LEO constellation. Integration of, we are going to see integration of everything. You need to design a simple RAN which can basically, which can enable communication between this different kind of platforms. So you're going to see that, okay? And basically, if 6G can enable that, then users can basically, you can provide ubiquitous connectivity to different kind of users, and that will enhance the user's experience. So this is basically, we spoke about customer experience. Now the next one is how can we design 6G which is basically efficient, okay? So how can you reduce the cost? That's the topic I'm going to cover about now, and then the sustainability part. Okay, so how can we design RAN which is energy efficient? And I'm going to briefly discuss what role AI is going to play on it. So you look at this problem, basically, then I'm talking about designing this efficient 6G network with AI. Okay, so I'm on the left-hand side. I've shown you a 5G network, and if you talk about this mobility, if you talk about handover, okay, earlier till now it is basically this handover threshold. Okay, the receive signal drops below a certain threshold. You basically hand over from one base station to another base station. Now when we are talking about 6G, can we use AI to do this better handover transfer? We are talking about like 1024 antennas, 2408 48 antennas, and there will be multiple such beams. Can you use AI to do a better handover transfer, which will reduce the signaling? Okay, and if you reduce the signaling, you know you are doing a better system design. Okay, that's where we are looking at. That's how AI can play a role in designing a better, efficient system. Okay. Another use case. Okay, so that. So if you look at the way the classical channel state information is estimated in a 5G network, you have basically if you have 128 ports, you transmit 128 pilot signals. Okay. Now what we are talking about in 6G, I'm talking about an efficient 6G network design. Can you use AI basically by sending fewer number of pilots and doing a better channel estimation? Can we do that? Okay, if you are sending fewer number of pilots, you are basically increasing the data rate, you are reducing the overhead. Can we do that? Can AI help us in doing it? Okay, so that's another problem which we have to solve. Okay, so now another use case of AI so if you look at the way the 5G is designed, there are different modules. Okay, this is on the left-hand side. There's conventional 5G transceiver chain. So you have source coding, you have channel coding, you have modulation, then the whole of this data goes through a channel. Okay, on the right-hand side, what 3GPP is looking at and what we are also contributing, that like can you use AI to design a single block which is basically optimized for all these use cases. Currently, each of this block on the left-hand side is optimized separately. Can we have a single block which is optimized for everything put together? Can AI help us in doing that? Okay, this is how, and if AI can help us in doing it, we can have a better system design. Then this is another use case, and I'm talking about these conflicting objectives here, wherein like we are talking about can we design an energy efficient 6G system. Okay, so you look at, so I want you to focus on this, wherein this part, it's a little loaded slide, but how can AI help in reducing the energy? So what we are saying here is there are dynamic traffic scenarios in 6G. The network is going to be much more denser than what it was in 5G. Then there are diverse services which earlier speakers have spoken about. Now, can AI basically consume this data, can analyze this data, and can help us in designing an energy efficient system? Just for an example, you're talking about thousands of antennas. Okay, so based on user profile, can you switch off some of these antennas? That's an intelligent decision. If you simply switch off, if you randomly switch off or with a fixed threshold, you're going to lose some of these users. Okay, and their quality of service is going to degrade. Now, can we do that smartly? Can we basically design these algorithms? Can we design the system such that it is done intelligently and we can save the energy by switching off some of these antenna arrays? Okay, if that can happen, 6G will be much more energy efficient than what we have seen in 5G. Okay, so this is basically when we talk about AI, so as I said earlier, it's going to consume a lot of energy. But in this case, what we are talking about is can it help us in reducing the energy? Okay, by smartly switching off some of these antenna panels. Okay. So till now, I've covered these first 3 bullets. We spoke about customer experience, we spoke about efficiency, we spoke about sustainability. Okay, now the final bullet which I'm going to cover here is basically this revenue growth. Can we design this 6G such that operators are profitable? Okay, can we come up with diverse use cases? Can we come up with different use cases what 5G has served? Can we come up with a leaner system design? Okay, which is basically cheaper to design. And let me touch upon that. Okay, so 6G will be designed for to serve massive number of users. Okay, and that's the title of this slide. We're talking about massive communications. So 6G is envisioned to cater 10⁶ devices per kilometer square. Okay, these are IMT 2030 requirements. Now, what the day one importance or the day one feature, okay, of 6G, what we are thinking is basically to have a versatile native support for this diverse device types and traffic profiles. So 6G is being designed to serve different kind of UEs, different kind of fixed wireless access devices, non-terrestrial network. Okay, single network from day one is going to support large number of users and of diverse kind. That's one wherein it's profitable. We believe it will be profitable for the operators. Okay, and yeah, so then the 6G is going to support this unified framework with single scalable design. Okay, so I'll take how much time I have? 5 minutes. Okay, so this is basically this integrated ISAC use cases which we believe 5G could not serve. So there is a disaster, and then there's a very common use case and which is very pertinent that there's a disaster and the base station detects this disaster and then conveys this information to the neighboring base station such that the users can avoid this particular area. Okay? And this is a very practical use case of a ISAC base station. Okay? Another one which earlier speakers have also spoken about is basically this UAVs, okay, detecting UAVs. I'm saying that you could basically track the UAV trajectory and then can feed it, then give it to regulatory services, regulatory agencies who demand that. Okay, another use case. Okay, so then I'll skip this. So coming to this, okay, you have these diverse services, you have these diverse use cases, we basically want to bring AI to improve the network efficiency, we want to bring AI to simplify the network, and how is this RAN architecture going to look like? I'll just give you a brief overview of that. So these are broad 3 technologies, XL MIMO, I spoke about sensing, AI, ML. So if you put everything together, how is this going to look like? This is, look at this. So there'll be this RAN with 1024, minimum of 1024 antennas. Okay, and now the RAN is going to connect it to the baseband. When now we are talking about 1024 antennas, the ORAN interface, you'll have to enhance this ORAN interface, and the GPUs are going to come into AI. GPUs are going to come into the 6G RAN. You see this, there'll be this classical signal processing, there'll be this AI-based signal processing. The hardware will have to be designed for that. And this is what we believe when our 6G RAN network will look like. Okay, so I'll wrap up this by showing you the software architecture. You have AI sitting at different layers of this AI native RAN. So starting from layer 1 to different layers. So you can have AI replacing classical signal processing modules. You can have AI assisting classical signal processing modules. At the bottom of it, there's a computing platform, and there is at the top of it the model lifecycle management, which is going to manage these classical and the AI-based signal processing modules. So this is basically, I'll conclude it over here. So what we have discussed in this presentation is how 6G RAN will evolve to improve customer experience via high quality services and ubiquitous coverage. Then how is going to enhance efficiency with AI-driven automation, how is going to increase the energy efficiency, how is going to increase revenue growth and monetization. I also briefly touched upon what will be the potential 6G RAN architecture. So I'll stop with this, and thank you.
So thank you so much for this meaningful session. And now I request Shri Upendra Bakolia ji, DDG TX, to present mementos to the session chair and the speakers. Can we have the mementos, please? So memento to the Professor Prasanna Charpokar ji. Thank you. Memento to Mr. Nirant Amok ji. And the memento to Professor Rohit Buddhiraja. So once again, thank you so much everyone. And ladies and gentlemen, we will now break for the high tea. And all the delegates may proceed at Atrium Hall at ground floor, and all the dignitaries and speakers may proceed to the VIP lounge, and we will be assembled here within a 15 minutes of time. Thank you so much. International workshop on 6G standardization organized by Telecommunication Engineering Centre. And I hope you all enjoyed your tea. So let's move to session 3. Please take your seats. Okay. So let's move to session 3, 6G spectrum roadmap. This session will focus on global spectrum planning for 6G, covering World Radio Communication Conference 2027, that is WRC 27 agenda items, regional harmonization efforts, traffic growth projections and spectrum demand. It will also address migration strategies and approaches for efficient and sustainable spectrum utilization. So for that, let me have the privilege to request our first speaker for this session, Mr. Jitendra Singh, Senior Director and Head Government Affairs, Qualcomm India. Mr. Jitendra Singh. Can we have a round of applause for him? He has over 35 years of experience in telecom, including 20 years in the government, and actively participates in ITUR and World Radio Conference. I request Ms. Poonam Kumari ji, AD/AT QT, to kindly present the bouquet and welcome Mr. Jitendra Singh. Can we have the bouquet, please? Flowers. Please. Let's welcome Mr. Jitendra Singh. Thank you, sir. Now you can.
Good morning, Jai Hind. So early morning sessions were excellent sessions for people who understand technology and wanted to deep dive into technology. I think those sessions were extremely good sessions with focus on infra side, and I'm from Qualcomm, so I will now try to see what is there in the device side. So can I have a presentation on the screen? Yeah. So as Qualcomm, we are focused on helping and shaping the digital future, enabling intelligent compute everywhere. So that is the focus with which we are working, and that is the way we are moving forward in terms of ensuring adoption of various technologies from various generations which we have seen. When we talk of 6G, we have seen this multiple times. We understand these vision statements, and important here which we have noted is that AI is the major driver of 6G, that is a major driver of consumption of data, and that is how the entire thing will play, and that's why the three new elements which have come to 6G will make more sense, whether it is integrated sensing or AI and communication or ubiquitous connectivity. That is where the game will be. And because that is the thing which is different from what we know about 5G. So why I say so, that why AI will become important. It is one thing which we heard in the morning sessions was that AI and data centers and cloud and all those things. But there are other trends which we see as Qualcomm from the user side is that the usage of AI will be more on your edge devices. So whether you have smartphones, the current smartphones which you use are app-based. You click on an app, you take action based on that app, or you use those apps to get your work done. But as we move forward, we will find various agents sitting in your phone or in your devices, which will take control of the system for you, and they will work for you. So if today, if you want to check the status of, say for example, of some flight, you are checking it, you are going to app, you are trying to check that information by yourself, because app is then connecting to cloud and trying to give you information. But when it is a AI-centric or agent-centric item, that model will itself take care of it for you. Moment you try to give that command to it, it will automatically give all the information back to you. And based on your the training of your model, things will happen based on that. Similarly, 6G sensing and AI is another vertical which we see on the edge. That is something which is going to drive entire network architectures as we move forward. Models will become hybrid. They will not stay only on cloud or on your edge. They will be hybrid models. That's how the entire AI models will happen in future, and that's how 6G will be able to drive that best out of the technology. And edge data will become very relevant. Why it will become relevant is because if suppose I am using an edge device, which is say my glasses, these AI-enabled glasses, so whatever I see, those glasses are seeing same thing. It means that they are sending that data back to the cloud or back to your device and then to cloud. So that is the kind of data which is getting transferred. If I'm moving my head this side, glasses are also seeing same thing, what I am seeing. So that data is going, training my models, large models in cloud. So that is the process which will happen. That means that amount of data which will float or which will move between your edge and the main core will be humongous. So that kind of consumption of data will require different kind of adoption of technology. And I believe that was covered well in the first session where this part was also elaborated. Overall, what we see as Qualcomm is that AI is going to be your new UI as we move forward. And that is what will then drive the entire adoption of technology. So it is not only that it will be used by in the network level, it is primarily be used by you, all consumers, all users at the edge, whether it is your PCs, laptops, your automotives, your phones, your watches, your smart glasses, or hearables, wearables, everything will be having AI component. I assume that people in back cannot read it, which is okay. So what are the key AI trends which are driving this initial adoption? Are low latency, data privacy, democratizing AI, and AI safety and trust, and basically ensuring that, especially ensuring data privacy. That is something which all of us actually are quite worried about our data, that where is that data going, which is in your device. If it goes to cloud, then you don't know where it is going. And therefore, yesterday I was in a presentation, making a presentation in Ministry of Defense, and this was a concern from their side that if they have a data which is going to cloud, then they don't know where is the data going. So that's why Edge AI for users like them or any other user becomes very important. So because of this, AI will be driving the wireless demand. What we have envisaged is that WAN traffic projected growth by 2034 will be 7 times more than what it is now. And AI will be accounting more than 30% of that data. So that is the kind of data we are expecting by 2034. We assume that 6G will happen before that. But whether it happens and what time it happens is a different issue, but that is a kind of AI which will consume the data on these networks. As I said, that because we are going to use your edge more, it means you are transmitting more data. one point which was brought in the morning session was also by Nokia was that uplink becomes important. So this is why uplink becomes important, because that edge will be the one which is driving that data. So your uplink needs to be more capacity oriented, and it should be able to take more data. So capacity, in whether it is possible in whatever spectrum is possible, or whichever bands which are possible to drive it, not only within a limited area, but also to the areas which are not where there's a difficulty. For example, you're sitting right now inside this room. I'm not sure how many of you are actually getting your networks from outside to inside this building. So you need that kind of connectivity which ensures that, for example, lower frequency bands, sub-gigahertz frequency bands, those are the bands which will help you to connect from your user device or a edge device to back to the network. Yeah. So there are multiple bottlenecks which we see as of now with 5G, and that is something which we feel that 6G will remove it. One is uplink to scale, native intelligence, ubiquitous connectivity, low latency, and predictable jitter, increased security and resilience. So all those things will actually will happen as we remove these bottlenecks with 6G technology as we move forward on that. Sorry if slides are jumping a little bit, so maybe I will. Anyways, okay, so there are three key enablers for 6G. One is spectrum, other one is software and hardware. So especially for improved connectivity and computing, it is important to have greenfield spectrum to roll out 6G. You cannot just start rolling 6G on 5G networks. You cannot uproot those existing networks. You need to bring a new spectrum to get a new technology deployed, and that's why it is important to have some greenfield spectrum bands to handle this particular requirement. Some of the important points which we note is that because of Giga MIMO opportunity which we see, there will be solutions which will ensure that, again, I'm quoting the example from the morning session when it was told that 7 gigahertz will be giving almost like same coverage as what 3.5 gigahertz coverage experience you get. Because of Giga MIMO, because of compensation which is planned in this development. Because AI will actually take care of some of these issues and will ensure that experience is improved. That is also important to have increased sub-gigahertz capacity. So typical design goal is to have 50 to 70% performance gain in mid bands and low bands to help this kind of connectivity for as we go in 6G. Can we move to the next slide, please? Can we skip and go back few slides, because this has gone to little bit more. The next one after this, yes, thank you. So as we have seen that technology has grown from whatever G's from early days. We saw when 3G was there was a requirement of 5 megahertz of bandwidth, and that was for providing you the internet connectivity. As we moved into 4G, the bandwidth increased to 20 megahertz to give a good quality of service experience to the consumer for having broadband connectivity. And in 5G, we had 100 megahertz of bandwidth typically to give the experience of enhanced mobile broadband connectivity and also fixed wireless access connectivity. In 6G, the use cases have increased, and the different kind of use cases will come into play. One of the important one will be the sensing, and that will consume huge amount of spectrum bandwidth. So as in the morning we heard from Nokia, from Matthew, that 400 megahertz is something which is being seen as a downlink spectrum requirement, and 200 megahertz for the uplink requirement. So that is something which we also envisage, that 400 megahertz bandwidth is something which we need to focus on per operator, so that each operator can then roll out spectrum, roll out their 6G networks based on that amount of spectrum. Going to the next slide, there are typically 3 building blocks of 6G which we see. One is connectivity, other is computing, and third one is sensing. Okay, so what is the requirement for 6G in terms of what are the drivers? Drivers are basically your various kind of use cases which we spoke about, and spectrum requirements, as I just spoke about, the requirement which is about 200 megahertz for uplink and 400 downlink. The typical discussion which has happened, and then the industry associations like GSA have been speaking about 400 megahertz contiguous block per operator, and GSMA was of the view of 2 blocks of 200 megahertz per operator, again contiguous spectrum. So that is the requirement of spectrum. And as I mentioned earlier, that this is important, very important actually, to have greenfield spectrum bands for 6G. You cannot uproot existing deployments. You have to build on those existing networks. 600 megahertz band actually plays an important role because this gives you a greenfield sub-gigahertz band for supporting your edge AI requirements. So giving some background on 6G spectrum work which happened. This is a slide which shows what happened in 6G at global level. So there's a meeting known as APG, Asia Pacific Telecommunication Group meeting. So this is 23, shows that it was in 2023 cycle of WRC. This was the last meeting of that particular cycle, and India proposed a particular frequency range which is 7125 to 14 gigahertz for 15 gigahertz for doing to identify for IMT from this particular range. So that was pushed. We got support from Vietnam, Korea, and Laos in Asia Pacific. Then we were able to drive this during WRC. During WRC, certain bands were again out of that entire range. We came down as India to certain portions of that spectrum band, which you see in the center row. That was what India pushed in WRC itself. Out of that, we were able to get one portion on the bottom side, which is 7125 to 8.4 gigahertz, and then 15 gigahertz band, 14.8 to 15.35 gigahertz. So those were the bands which were agreed by the WRC for further studies, and those studies are being done in ITUR Working Party 5D. We are almost about to complete that study work. It is important to note that Dr. Puneet Rathod, one of my colleagues who is also present in the hall here, is the chairman of this work of studies in ITUR, Working Party 5D. So we are driving this, and we are trying to see how it best helps India's requirements. And we are hoping that this work will get over by October this year. So we have 2 meetings left, one in June and last one is in October. So we must be participating at the maximum strength from India side in these meetings. This is a timeline, and as you see that we are already on this work, which is agenda item 1.7 of WRC for this particular spectrum bands. That work is going on, and 2-3 minutes, okay. Thank you. So I will try to close it fast, as I've got directions that I have to close it in next 3-4 minutes. So I will move slightly quickly. But my slides are not moving that quickly. Can I go to the next slide, please? Yeah. So basically, these are various spectrum bands I had laid out here for information. The last chunk, which you see, larger chunk, that becomes an important thing for India. Maybe you can go to the next slide, please. Yeah. So this diagram actually shows, on the top one, actually shows that how we placed. The violet color shows that this is 6 gigahertz band which was opened up, and this was the one which was sent to TRI for consultation for auction, and the remaining one is under discussion. So this entire range becomes a very good band for India, because that gives you 4 chunks of almost 4 chunks of 400 megahertz for each operator. So you have 4 operators, each one can get equal type of spectrum band, 400 megahertz each. That is the kind of spectrum we have. So if we continuously push for this, we will be able to actually get this spectrum, and our operators will get benefited. India can actually take lead in that. Next slide, please. So these are various users in that band, and the studies are going on. I'll skip this one. Moving to the next one, please. So these are the studies which are being done. So I'll skip this again and maybe skip the next slide as well. Yeah, these are the current outcomes of some of the studies which are done. All of them are almost not blocking any of those things completely. So they are still under discussion, and probably WRC is the one which will then go and decide. Please go to the next one. Skip this one as well. Yeah, we can skip this one also. Yes, so coming to the global momentum of 6G, there are various groups. We see US has got one group which is working on 6G. There's China, Japan, Korea, European Union, and also India. We have Bharat 6G Alliance to actually take care of that. One important thing which I want to show you in the last few lines is that, because there was a question that is it going to get delayed? No. MWC Barcelona this year, which was 2 weeks back, it was decided to have various organizations, companies came together, including all the key telecom operators, all key infra vendors, including Indian telecom operators and infra vendors, to support 6G, and that is the with the aim of having it in 2029. So that is the timeline which we have. With this, I will close my presentation. Thank you very much.
So thank you so much, sir, and our Honorable Minister will be joining us in few minutes. नहीं वो तो ठीक है So he'll be here anytime. Okay, he has come. Okay. So ladies and gentlemen, may I request your kind attention, please. The moment we all have eagerly waiting for has finally arrived. I'm delighted to share that our esteemed dignitaries have now arrived and joined us in the hall. So we're deeply honored to have with us Shri Jyotiraditya M, Scindia ji, Honorable Minister of Communication and Honorable Minister of Development of Northern Eastern Region, Government of India. Can we have a big round of applause, please? So now, ladies and gentlemen, as a token of our warm welcome and respect to our esteemed dignitaries, I request Shri Syed Tausif Abbas ji, Senior DDG and Head TEC, to kindly present a bouquet to Shri Jyotiraditya M, Scindia ji, Honorable Minister of Communication and Honorable Minister for Development of North Eastern Region. Can we have the bouquet, please? Please put your hands together. Next, I would like to request Shri Amit Kumar Srivastav ji, DDG Mobile Technology TEC, to present a bouquet to Shri Amit Agrawal ji, Chairman Digital Communication Commission and Secretary. Actually, he's not here, I'm sorry. And now I request Shri Kamal Kumar Agrawal ji, DDG Fixed Access TEC, to kindly present a bouquet to Shri Manish Sinha ji, Member Finance DOT. And now may I request Shri Pawan Gupta ji, DDG Administration TEC, to kindly present a bouquet to Shri Rudra Narayan Pallai ji, Member Technology DOT. Ladies and gentlemen, please a big round of applause. And finally, I request Shri Ajay Kumar Nimaji, DDG Telecom Certification, TC, to kindly present a bouquet to Shri Dev Kumar Chakrabarti ji, Member Services. Okay. As we begin this workshop, we'll start the ceremony with the lighting of the lamp, which symbolizes knowledge, wisdom, and removal of darkness. So may I request all the dignitaries on the stage to kindly come forward for the lighting of the lamp ceremony. To formally welcome everyone present here, I would like to invite Shri Shubhendu Tiwari ji, Advisor Technology DOT, to kindly deliver the welcome address.
Honorable Minister of Communications and Minister of Development of Northeastern Region, Shri Jyotiraditya Scindia ji, respected Secretary Telecom and Chairman Digital Communication Commission, Shri Amit Agarwal ji, distinguished dignitaries on the dais, esteemed delegates, speakers, international experts, and representatives from media, industry, and academia, ladies and gentlemen, including those who are viewing this event online. It is my great privilege and honor to warmly welcome all of you to this international workshop on 6G standardization. On behalf of Telecommunication Engineering Centre, a technical arm of Department of Telecommunications responsible for telecom standards, testing and certification, and actively engaged with global standard forums such as International Telecommunication Union and Third Generation Partnership Project 3GPP, I would like to express our sincere gratitude to all distinguished participants for accepting our invitation and joining us today. We are meeting at an important moment in the evolution of global communications. The vision for IMT 2030 is already taking shape and will define the next generation of communication systems and digital infrastructure of the coming decade. The emerging 6G paradigm goes far beyond faster connectivity. It envisions ultra-low latency, extremely high data speeds, precise positioning capabilities, highly energy-efficient networks, and deep integration of artificial intelligence across network layers. These capabilities will enable transformative application across sectors such as healthcare, manufacturing, transportation, agriculture, disaster management, and immersive digital services. Globally, the journey towards IMT 2030 is advancing through coordinated research programs, experimental testbeds, spectrum planning initiatives, and active standardization efforts within the International Telecommunication Union and Third Generation Partnership Project. The foundation framework for IMT 2030 has already been established within ITUR, while parallel studies in 3GPP are progressing towards future release-based specifications. Key areas such as AI native networks, integration of terrestrial and non-terrestrial communications, advanced MIMO evaluation, and exploration of new spectrum bands are already under active study. This indicates that the global 6G standardization cycle is currently at a formative and highly influential stage where coordinated technical contributions can meaningfully shape the architecture of future networks. India has adopted a proactive and mission-oriented approach towards 6G, emphasizing indigenous research, intellectual property creation, active participation in international standard bodies, and development of advanced testbeds. We recognize that 6G will be a key enabler for digital inclusion, industrial transformation, smart infrastructure, and resilient connectivity. Workshops such as these play an important role in fostering dialogue among policymakers, researchers, industry leaders, and standard experts, helping build shared understanding and enabling coordinated engagement in global standardization process. I am confident that today's deliberation will strengthen collaboration, provide clarity on the evolving IMT 2030 framework, and contribute meaningfully to India's participation in shaping the future of global communication. As we collectively shape the vision of IMT 2030, let us ensure that the technologies we build do not merely connect devices, but empower societies, bridge digital divides, and create opportunities for every citizen. Keeping my address brief, I conclude by once again warmly welcoming all distinguished participants, and we keenly look forward to the valuable insights and guidance of our Honorable Minister present here today. Thank you.
Thank you so much, sir. And I would like to request Shri Amit Kumar Srivastav ji, DDG Mobile Technology TEC, to present a bouquet to Shri Amit Agarwal ji, Chairman Digital Communication Commission and Secretary, Department of Telecommunication. Please give a big round of applause, everyone. And now time has come for which we were eagerly waiting. It is now my great honor to invite Shri Jyotiraditya M, Scindia ji, Honorable Minister of Communication and Honorable Minister for Development of North Eastern Region, Government of India, to deliver the inaugural address.
Seated on the dais with me, Secretary Telecom, Amit Agarwal ji, Member Finance, Manish Sinha ji, Member Telecom, Palai Sahab, Member Service, Chakravarti ji, Advisor Subhendu Tiwari ji, members of the Telecom fraternity, international speakers, delegates, and most importantly, all members of our Telecom family. It indeed is a honor and a privilege for me to be present here at the international workshop on standardization for 6G. I really believe that the world is today at the threshold of a new technological epoch, an era of 6G that will not only merely represent exponential jumps in speed and latency, but I really believe it's the next jump or the next leap for human civilization from a digital and a technology perspective. This new exponential leap goes beyond connectivity. It relates to the concepts of intelligence, the concept of immersiveness, and the concept of limitless possibilities. And as India approaches this inflection point, if you will, it is also important to look back at the decade of progress that India has made over the last 10 years. One of the world's most vibrant digital ecosystems today has been established in India. An unseemingly digital highway constructed with the vision of Prime Minister Narendra Modi today is the one that conveys not only commerce, not only connectivity, but the ability to connect 140 crore Indians with the world. And a testament to that is the derivatives of telecom technology that are riding high on this digital highway today. Take the United Payments Interface, the UPI, as an example. Today, India does close to about 20 billion transactions per month. Close to $3.4 trillion worth of transactions in a year. India has become the leader in digital transactions across the world. Over 50% of the world's digital transactions take place on India. And this is on this invisible or adrishya highway that has been constructed. Similar is the case with our Aadhaar payments. With enrollment of close to 1.3 billion people, it's created the foundation for the world's largest digital public infrastructure today. And this shows the world, and India is the only test case for that, how technology can transform billions of lives across the world. On the other hand, you have, with growing economies of scale, cost of data and tariffs falling exponentially. 1 GB of data today costs less than 10 cents, whereas the world average is close to $2.49. Over the last decade, data costs have fallen by close to 97% under the leadership of Prime Minister Narendra Modi. And at the same time, you have an exponential rise in connectivity, where we had 60 million broadband connections in 2014. You have over 1 billion broadband connections today. So if you take the concept of exponential scale, combine with it the capability of driving down costs exponentially, then what comes on the horizon is the capability of empowering billions of people across India. And whilst we talk about this, these have formed the bedrock for innovation to sprout green shoots across the length and breadth of our country. And 6G talks about that possibility of innovation. Think about a case study where a farmer in a remote area can access the moisture quality of soil, can look at weather patterns through AR tools. Or for example, I was recently in my constituency where we are trying to hold one of the largest health camps in the country. And one of the components of that is robotic surgery. But think of what 6G can do to power robotic surgery. The surgeon who's today in Shivpuri doing the robotic surgery can be sitting in Mumbai or in New York City, and through the 6G technology, do remote robotic surgery in every single village across our country. That is the power of 6G. Think about the concept where a student sits in a classroom in a village and looks at a holographic image of one of the world's most profound professors teaching a class, except it's no longer on the grounds of Stanford or Harvard University, but in her village environment. And it is these possibilities that get empowered by the technology of 6G. Subhenduji allured to that, where data speeds are potentially reaching up to 1 terabyte per second, where latency can be measured in microseconds, and there's seamless integration of artificial intelligence with networks. And when you put these three elements together, speed, latency, and integration of AI, then what you get in return is the intelligent internet of everything. And when you have this IIE, then what you have is people's, machines, infrastructure, and environments interacting at the same time together. Now, realizing this opportunity, India, that was not at the table with regard to the advent of 3G technology or 4G technology or even 5G technology, under the leadership of Prime Minister Narendra Modi in 2022, put together the B6GA, the Bharat 6G Alliance, which came out with its own Bharat 6G vision, where our aim is to contribute 10% of global standards and global patents as 6G evolves. And it is in this future, the future where we see holographic communication replacing flat screens, autonomous mobility, which will operate with great precision, digital twins replacing data across cities and townships and industries in real time, assisting in planning, in resilience and sustainability. The promise of this 6G technology not only lies in the power of technological sophistication, but also lies in the democratization of opportunity. And here is where India's story comes to the fore on the global stage. The rapid spread of smartphone technology. India at one time could manufacture only 20% of its cell phone requirements. Today, not only does she manufacture 100% of her cell phone requirements, but cell phone exports have become the #1 export from our country, crossing almost $30 billion per annum. At the same time, across the board, when you look at this capability, where India has almost 1/3 of global data consumption, the average user today consumes close to about 32 gigs of data per month, probably the highest in the world. Affordable handsets become a very powerful equalizer. And through our productivity linked incentive scheme, our PLI scheme, close to about 100,000 crores worth of extra manufacturing, 25,000 crores of exports, creating almost 30,000 jobs. We are looking at a new environment where a $1 trillion digital economy outlook today is an opportunity for India tomorrow with close to 200,000 startups. Now, in this journey, our decisive role has to be based, I believe, on 4 key pillars. The first is to ensure global interoperability. Interoperability between devices, between networks, and between services. And this is not the case only for India. This has to be the case across the world so that the world communicates seamlessly across a unified global communication ecosystem. The second pillar is to be able to create a common technical framework. And here, working both with 3GPP and ITU to ensure that we develop shared technical standards across radio interfaces, core networks, spectrum use, and service architecture is the call of the hour. The third pillar is to accelerate innovation and research. And here, clear global standards will guide our researchers, our startups, and industries, allowing them to align investments, transforming laboratory breakthroughs into real-world applicable solutions. The fourth pillar, and I believe in this order probably the most important, is to ensure inclusive growth and indigenous innovation. And open standards create that level playing field. 4, ensuring that nations contribute to technology, build intellectual property, and ensure that all their benefits reach every single marginal citizen across the length and breadth of the globe. Now, in order for these 4 pillars to activate, international cooperation, global dialogue, and sustained conversations are extremely important. And to that end, I believe the New Delhi Declaration on 6G Collaboration, which was signed during IMC 25, reflects exactly that approach. And as we accelerate towards defining a pathway for 6G standardization globally, it is extremely important to ensure that global wisdom and cooperation come together in a unified whole towards that purpose. I do believe that this conference and this workshop will lead to sustainable and clear outcomes on the path ahead. We must build intelligent, inclusive, and transformative networks that empower societies, accelerate innovation, and bridge the digital divide. So let us pledge that together today, we will continue to build a secure, resilient, and a truly global 6G ecosystem, one that connects not only devices, but one that connects people, one that connects opportunities, and one that connects possibilities, people, opportunities, and possibilities across the length and breadth of our world. Thank you very much.
So thank you so much, sir, for your visionary and inspiring address. And now it is the time to express our gratitude. I would like to invite Shri Syed Tausef Abbas ji, Senior DDG and Head Telecommunication Engineering Centre, to kindly deliver the vote of thanks.
Honorable Minister of Communication and Minister of Development of Northeast Region, Shri Jyotiraditya Scindia ji, Secretary Telecom and Chairman Digital Communications Commission Shri Amit Agarwal sir, Member Finance Shri Manish Sinha sir, Member Technology Shri R.N. Palai sir, Member Services Shri Dev Kumar Chakravarti sir, other dignitaries, distinguished speakers, delegates from academia, industry, research institutions, ladies and gentlemen. On behalf of Telecommunication Engineering Centre, Department of Telecom, it is my privilege to propose a vote of thanks at the conclusion of the inaugural session of this international workshop on 6G standardization. I am deeply honored by the gracious presence and inspiring address of Hon'ble Minister of Communication. His vision for India's leadership in next generation telecommunication, including 6G, and his emphasis on innovation, collaboration, and telecommunication in participation in global standardization process have provided invaluable guidance for all of us who are working in this domain. I express my sincerest gratitude to you, sir. I would also like to thank Secretary, sir, Member Finance, Member Technology, and Member Services for gracing the occasion and for their continued guidance and supports towards formulation of standards for telecom products and equipments. I would also like to place on record our sincere gratitude to Advisor Technology, sir, Shri Shivendu Tiwari ji, whose constant guidance, motivation, and encouragement have been instrumental in conceptualizing and organizing this workshop. In the morning also, we have 3 sessions already completed, so I would like to extend my appreciation to all the distinguished speakers and session chairs who have shared valuable insights during the morning sessions. I further place on record our sincere appreciation to participants and organizing team of TEC DOT Media team for their efforts in making this workshop possible. As we move forward, we are having remaining sessions also in the workshop, including discussion on spectrum for 6G, radio access network development, AI-powered network, security architecture, emerging applications, and integration with non-terrestrial network using satellites. Once again, I thank all the dignitaries and participants for their presence and contributions, and I request everyone to continue engaging actively in the technical sessions which are scheduled after this inaugural session. Thank you so much.
Thank you so much. And before we conclude this segment, we once again express our sincere gratitude to our Honorable Minister for gracing this occasion with his presence. Thank you once again. करूँ शुरू? एक मिनट, मैंने कहा वो डोर एक मिनट खाली हो जाए, बिठा दूँ? Okay, please sit everyone. Thank you. Please take your seats. Session करवा दो. So we are going to start our sessions. So moving ahead, it is my pleasure to invite our next speaker, Mr. Ashwini Kumarji, Head of Standards and Spectrum Strategy at Nokia India. Mr. Ashwini Kumar. Shri Ashwini ji is a veteran telecom leader with 33 years of experience, currently leading standards and spectrum engagement at Nokia India. He holds BTech and MTech degree from IIT Roorkee. I request sir to kindly, okay. So I request Ms. Poonam Kumari ji, AD, ET, QT, to present the bouquet to Shri Ashwini ji. A big round of applause, everyone. So you can kindly start your session. We'll start. Start from there. Okay.
Which one has to be used for this top one?
So that's central. इस साइड करिए. हाँ.
चलो क्या? इसमें कुछ है?
हाँ कुछ तो है सर. ये सेल डाउन हो रहा है सर. बैक करें.
हाँ बैक कर. साइड पे प्रॉब्लम है. आई डोंट थिंक कि मतलब मैं पढ़ सकता हूँ.
नेक्स्ट तो जा रहा है, प्रीवियस नहीं जा रहा है.
हाँ
फर्स्ट स्लाइड सर. मैं फर्स्ट स्लाइड लगाता हूँ, उसको नेक्स्ट आ जाएगा यहाँ पे.
Shall we start? Am I audible? So good afternoon to you all, and my session is about providing some projections or some assessment about how much spectrum will be required and what kind of applications will be involved in 6G. So I will start first from the AI. So everybody is talking about artificial intelligence in devices, in network, or in the clouds. So at the top, I would like to draw the attention that number of AI sessions have reached 1.3 trillion and tokens per day. 100 trillion tokens are passing through the networks. And AI traffic is consuming 77 exabyte a month traffic, and good news is half of it is on the mobile. And the current hotspot is generative AI, ChatGPT or Gemini. So at the bottom we provide from Bell Labs, Nokia Bell Labs, we did some assessment of the traffic growth. We did some assessment of traffic growth. So our assessment says that by 2023, AI traffic will become 50% of the total WAN traffic, and that will be a huge proportion compared to the today. Like today, the direct AI traffic is 77 exabyte a month. So that's how the AI traffic is going to grow. Then I come to the second thing that all the vendors are talking about AI RAN. That what this AI RAN is about, why you are talking about artificial intelligence and RAN, and people have explained before me. So the hotspot till now has been generative AI. Started with 2020, where the focus was developing LLMs, large language models. 2022, ChatGPT launched it publicly. The major activities was creating text or the graphical content. 25-27 will start the customer video generation, and that will take a next growth for data consumption. Therefore, modest data consumption, while I've shown that trillions of tokens are being processed, but data consumption is not that high because it was a Gen AI and it was the text and AI. But the next hotspot as per Nokia vision is physical AI. Physical AI, when I say that is no more the content generation or asking some questions to ChatGPT, it is about the representation of the 3D spatial world, do some sensing, make some analysis, create some actions. And some examples I'm giving: traffic management. You can create twin, you can have your predictions, you can streamline your traffic lights, their counters, metro route planning, healthcare, industrial robotics. So wherever you interact with the 3D world, make some sensing, actuate something back, this is physical AI. This will be the prolific way AI will pan out. And this is the next way forward that will be the next way in AI, physical AI. 2025, it is picking up now. 27th will be the growth phase. And in our understanding, 2033 will be the peak of it. And the bottom line is that in Gen AI, we were working with the core cloud because latency or response time was not a constraint. But physical AI will be specific to some area, like we are sitting in the Vigyan Bhavan, we need the traffic scenario of this area. Local in context, this is one thing, real time. Third thing is, instead of developing large language model, efficient small language models will be sufficient. And what it means that instead of central clouds, somebody has to create a digital AI infrastructure, which will be compute at the edges and network APIs and mobility and location insights. In my understanding, these three elements can be easily given by only one agency, which is telecom service provider, who are in the every nook and corner of the country. Otherwise, nobody can create edge compute everywhere and distributed processing will not be possible. This is a great opportunity for telecom operators in my understanding. And from here comes the, take near, yeah.
Slide change नहीं हो रहा है, change slide.
अच्छा,
मैं करता हूँ.
हाँ. Next one. So I think I'm missing between this and that. Yeah. Therefore comes the vision of Nokia that we need not create different silos. Three things, this trica: connectivity, compute, and intelligence. They have to be fused together. Where we fuse it, we can fuse it at an edge location, distributed, localized, where you can have local map, local knowledge map, which you can federate, orchestrate, and develop a bigger picture. That's the way forward on which Nokia is working, and most of the vendors subscribe to this view, that there will be three legs of AI. AI on RAN, means AI is working on the RAN, and AI for RAN. For the RAN protocols, you can optimize using the AI. Then AI and RAN workload can work on a single infrastructure. Therefore, this synergy or this integration is important to come by. And that's the basic genesis of AI RAN. Now we take a look on the data, since it is a spectrum session, data outlook, how it looks. So 2024, 4G connections 54%. They may fall by 2030 to 18%. 5G connections in 24 were 23%. We believe it will shoot up to 75%. And some numbers, we have already crossed 500K mobile data sites. Number of 5G users have already about to touch 400 million. 5G device penetration is 42%. And fact of the matter is that 5G data has become 40% of the 4G data, 40% of the total data, and it may cross in 2026. That's what is the expectation. Now, using this analysis, we did an evaluation of the data growth, 16 to 20% CAGR kind of growth we are expecting. So on the left-hand side, I plotted the data growth pan-India, and then on the right-hand side, I have projected the equipped capacity, just to see face-to-face that how much is the demand and how much is the capacity to deliver. Say, for example, in 2027, now we have 500K base stations where 5G is rolled out. The capacity that we can deliver is 568, while the demand in the network at a modest rate is 632 exabyte a year. On aggressive level, it is 676. So my point is, in 2026, somehow you can manage the situation. After that, the growth to 732, 849, 985, some serious action has to be taken. Either more spectrum will be done, or means some more spectrum has to be deployed before 2030, or deploy additional sectors or something. But that also you can do by 2028 or something. After that, it will be a sharp jump, which will be beyond to deliver for 100 megahertz, 3.5 gigahertz kind of 5G. Even if you deploy 100% everywhere, some action has to come. Now, this is another interesting thing we did. GSMA did a study that we all hear that GSA says that more than 2 gigahertz mid-band spectrum will be required for a country like India to deliver true 100 Mbps everywhere. Our NDCP 2018 also had this vision that we will deliver true 100 Mbps everywhere. Even Bharat 6G vision also has this 100 megabit delivery everywhere in true sense. So in India, based on the GSMA study, we did this detailed analysis of all the spectrum that we have listed in the first column, making a rigorous analysis of the total capacity which is demanded and what can be delivered. Based on that, our assessment says, and it is captured in the release report by Minister last year in IMC, that additional 1600 megahertz spectrum will be required if you have to truly deliver 100 Mbps everywhere. Truly means truly. It cannot be best effort, whether you get it or not. So this is just to give an idea. IMT 2030 has bigger targets. They are giving 500 Mbps instead of 100. But just to give 100 in true sense, 100 Mbps, 1600 will be required. Now, some flavor on the 6G. How we calculate the requirements for 6G. So I have done only for two things. One is for immersive. For immersive, to deliver a 16 by 16 pixel XR, data rate of 450 is required. For a conservative value of cell edge efficiency for immersive communication to deliver this, we need minimum 750 megahertz indoor and 1 gigahertz outdoor. I am not saying that this kind of services we will be delivering, just to give an idea that if by 16 by 16 XR, yeah, that is another problem. Yeah. 16 by 16, this much spectrum will be required. And if you go for the sensing on the right hand side, for 50 centimeter accuracy for sensing, you need contiguous bandwidth of 300 megahertz. And for 20 centimeter, it will be increased to 750. So put together, we have made a modest request or modest advocacy that 400 megahertz per network should be planned. Not necessarily to be given on day one. 200 can be planned for day one. 200 can be planned for day two when sensing and other services come. But planning has to be done for that, and accordingly, like we have done this listing that all major countries, what kind of plans they have, Brazil, India. So in this graph, we see that most of the country have only two bands on which they are working, upper 6 and 7 to 8. The first two bars are for the US. And you are able to see the kind of decisions they have taken. Upper 6, completely delicensed, and then they're doing the patchwork. 4 or 5 bands comprising multiple radios on the same tower and all. Instead, other people have taken a balanced decision. India and Brazil, these are the two countries in our assessment who have 1300 megahertz provision, and they stand to gain. We have seen the results, benefits in 3.5. We did hard work, make it clean, available timely, and we have deployed fastest manner. So again coming, WRC 27, there are 3 ranges. One is the 44 to 48. Another is 7125 to 8400. Third one is 1485 to 1535. For 15 gigahertz operators are showing that we want to use it for backhaul. So for macro deployment, in my understanding, the continuous range from 6425 to 8400 is the most efficient range we have, where regulator, licensor, operator, and product developer and phone makers, they have to work together that what best use we can do when we auction. But we should treat this as a common range. Regarding 44 to 48, we all know that, like Madam, you told that retrofit may be accelerated by 2700 or something, but still, I doubt this band can come without restrictions. So, in my understanding, not suitable for macro, but let us see for upper 6 and 8, 6 to 8 is very important band. And because we guys from Nokia and our other competitors, we are planning our radios. Should we keep the integrated bandwidth 700 or 400? It depends on how we are planning. The good decision that India is taking, that we are positive for 7 to 8. So we have a contiguous range, and this is the raw material, and that will be the winning strategy for us in 6G. Now coming a little bit on like 6 to 8. In 6 to 8, my previous speakers from Ericsson and my colleague from Nokia, he also told that our vision is to match the grid of 3.5 gigahertz using 6 to 8. In 6 to 8, we want to match or reuse the same sites which we are using in 3.5. And for that, the reason is that we are packing 192 elements in 77 centimeter enclosure. But when you double the frequency, your number of elements in both direction X and Y become double. So 4 times 768 elements can be packed. So, because I have this eyesight problem, I can't see there. So our first thing is that with the 4x number of elements, we get 6 dB antenna gain, and then uplink coverage enhancements that we are planning, we can have 4 dB gain. The total 10 dB coverage gain we can have by using antenna and the beamforming techniques that we plan. And then on capacity side, 4x more spectrum and 5 times more spectral efficiency. That means 20x cell capacity. So if we look to the bottom box, in LTE time, 4T4R with 20 megahertz channel, we delivered 40 Mbps. Then we moved to 64 port, 100 megahertz in C band, 800 megabits, and now in 6G, twice the number of TRXs or transceivers with 400 megahertz. Our vision is to deliver 60 Gbps cell capacity from the same carrier. So 6 to 8, this is 20 plus trials have been conducted by Nokia with global operators, and very strong learnings we have got that 6G can be deployed in 6 and 7 to 8 gigahertz maximum using the 3.5 gigahertz site maximally. At least 85% sites can be used. And second learning has been that 200 megahertz channel bandwidth compared to 100 gives you 3 times better performance, both in outdoor and outdoor to indoor. These are the 2 things, and thankfully they are accepted in ITU. So now this is the stack, how it looks like. This is a spectrum stack. The green one is, we already have this spectrum, and the blue ones will be the new blocks that will come. So 600 spectrum is important in the sense that our experience in 5G says that minimum 20 megahertz spectrum should be there in the low band if you have to deliver good experience. If you have 10 megahertz, that get easily congested. So first of all, target, we have 40 megahertz. Try to have at least 10 or 20 megahertz in the 600. Low band is very important. And then naturally, operators will start refarming their LTE to 5G, and some of the 5G to be dynamically shared, as my colleague Matthew told, MRSS, that will be shared 5G spectrum with the 6G along with carrier aggregation. So MRSS is the technique. I think this reminds you the same diagram which Matthew showed, that some of the coverage or the capacity bands from 5G we will dynamically share with 6G, and then from day one we will have uplink and downlink carrier aggregation. So without dual connectivity, carrier aggregation and MRSS, in Nokia view, this is sufficient kit for a seamless migration from 5G to 6G. Little bit on WRC 27. So we know very well we are standing now in March. We are just beyond the FEP meeting, 51st meeting of Work Party 5G. Only 2 meetings are left. Next one will be in May, then in October. One more will be there in Feb of 2027. But next big milestone is CPM text. And we have not yet developed very properly articulated regulatory methods or CPM methods for 7 to 8. So developing or articulating the methods, and then another important thing is that more than 100 studies, more than 100 studies have been conducted in Work Party 5D. And I have also been engaged with WRC since WRC 15. Despite standardizing everything, you write thousands of pages, this is the model, this is the thing, this is the loading, it's still people will follow their own way. somebody will fall RA parameter is so much. So the net result is wide divergence is there. Unless you systematize or sanitize the studies, and we are able to compare that how many studies are positive and how many negative, and then only we can get into the thing why it is negative. So that effort has not been done, and time is less. And our expert from India, Puneet Rathod, is doing a good job. So hopefully in next 2 meeting, we systematize this and then we progress to the CPM. Because summary of share study is a significant decision maker in finally whether the band goes off or not. The summaries have to be, supportive or, constructive. Finally, my message is that we should provision 400 megahertz per network, which we already have done, thanks to Government of India for that. And that is important for affordable, accessible, and sustainable 6G access. ITU 5D, most important thing for us is to weed out the divergence in studies, put them in some classes or do the classification, identify why they are diverging. This will be the focus on next 2 meetings. Develop appropriate CPM methods for various bands so that we have a structural view to which bands we can make our selection nationally, and then drive widest possible harmonization of 7 to 8 gigahertz range in our region APT3. Thank you very much.
So thank you so much, sir, for the informative presentation. And now I request Shri Vinod Kumar ji, DDG QT, to present the memento as a token of appreciation to Mr. Ashwini ji and Mr. Jitendra Singh. Can we have on stage, please? A memento to Shri Ashwini ji. And a memento to Mr. Jitendra Singh. Also, ladies and gentlemen, due to the limited time available, we are unable to proceed with this session by Dr. Sendil Kumar. We deeply value his presence, and as a token of appreciation, we would like to present him with a memento. So can we have on stage Dr. Sendil Kumar? He's the Director, Standards and Spectrum in the Ericsson's Group Function Technology, Standards and Industry Initiatives, and at Ericsson's as a member of the company CT organization. Thank you so much, sir. We really apologize. And now we will take a break for lunch. And again, all the delegates proceed to Atrium Hall at ground floor, and all the dignitaries and speakers proceed to the VIP lounge, and we will be here at 2 o'clock sharp. Thank you so much and enjoy your lunch. So, ladies and gentlemen, welcome back. I hope you had a refreshing lunch break. Yes or no? Yes. Okay, great. Okay, we now continue with the post-lunch technical sessions, which promise to bring more insightful discussion on the future of 6G technology. And before that, may I request to all our esteemed speakers to kindly keep your presentation within allotted time and conclude their sessions accordingly so that we can maintain the schedule smoothly. Thank you so much. So moving to our next session, session 4, India's roadmap to 2030 scaling pre-6G pilots to commercial deployment. This session highlights India's journey towards pre-6G trials and commercial deployment strategies and how research, standardization and innovation ecosystems are being aligned for the future. So it is my privilege to invite our distinguished speaker, Professor Kiran Kumar Kuchiji from IIT Hyderabad. Can we have a big round of applause for him? Professor Kiran Kumar leads research and standardization efforts for 5G advanced and 6G technologies on behalf of India in International Standard Organization. He holds over 200 international patents, several of which are recognized as essential to global 5G standards. We welcome you, sir. For that, may I request Shri Dhanesh Koyalji, Director MT, to kindly present the bouquet to Professor Kiran Kumar. Thank you so much, sir. You can kindly come forward and deliver your presentation, please.
Thank you. Thank you. Good afternoon. Welcome dignitaries from government and academia, industry, and those who came from other countries all the way to India to participate in this session. Welcome to you all. So I would like to share some experiences, very early experiences related to 6G. And you'll see that in this talk, we'll really focus on something that really affects the connectivity needs of people, especially the bottom 20-30% of the population, because I've been spending a lot of time deploying systems and studying connectivity. So I used to give talks on using equations and standards and theoretical concepts, but I would like to offer different insights today, share some experiences for the past 3-4 years of, I would call experiments that we have done leading up to some pre-commercial products, and also hopefully they'll be integrated into 6G standards in some form or the other. So IIT Hyderabad is located in located outside Hyderabad, about 25 kilometers, and it's a very unique place. We have a big urban canyon where we do experiments. Then we have a whole lot of villages surrounding our university. So we designed and deployed advanced 5G systems. We'll share our experience of those pre-commercial installations carrying live traffic, and the journey towards 6G through some experiments we are doing. What I understood, especially driving around, testing our systems, and actually installing them in homes, schools, and hospitals, we have done that. When we do that, you get a different, whole different experience compared to living in the city in Hyderabad or in Delhi. I'll show you some pictures of the connectivity that we offered that made a large difference in a school. Children are aged between 3 and 10 years old. And our system was installed for the last 12 months. And we could see the difference that it made with digital education. So things like that we'll touch upon, in addition to the scientific aspects of 6G and so on and so forth. There is a new discovery. The market has discovered something called fixed wireless access. Very interestingly, 5G was not really, when 5G was discussed at length a few years ago, I mean, we had workshops like this. I don't think there is a word called FWA ever mentioned by anybody at the time. But today, air fiber and FWA is increasingly becoming a common knowledge. And I think millions of homes are already getting connected through air fiber and FWA. So what's its relation to 6G is something we should really think long and hard about with respect to 6G. Education and healthcare are two things I think will be profoundly impacted by both advanced 5G as well as 6G. At least based on what I have experienced doing few experiments, these two segments are going to be the first two segments that will see a profound impact, at least in the next 5 to 10 years. And device level AI, I think needless to say, the new classes of devices, I mean, there are some devices that we have not seen yet. I think there will be new devices in the next 5 to 10 years. And all those devices have to be supported with the existing 5G networks as well as 6G networks. Then India needs connectivity anywhere, anytime, throughout the geography. I think it's fair to say that we are very far from that. Even in urban areas, it's far from truth that we have anytime, anywhere connectivity, at least not anytime. You know, I think that gap can easily be bridged through network densification. That's not very hard. It just put more money and more cells. But that's not necessarily true when you move away from urban centers to suburban and rural areas. There is no broadband connectivity in all places. Although there is a massive program to fiberize the whole country, it's just not there in every house. So that's where 5G and 6G and FWA will play a very, very large role. And satellite is coming. I think the remotest areas of the country will see at least LEO orbits serving dark spots, and narrowband IoT through NTN is going to be a reality very, very soon. I think we are probably less than a year away from low bitrate communication served by geosynchronous orbits. So then there is this new thing called sensing. I think a lot of people must be wondering what it is, because sensing is not something that any of us ever thought about. I'll touch upon that. That's something new, but we'll reflect on what the sensing means from a radio access network and 5G and 6G point of view. Okay, so needless to say, I would like to repeat again, the killer application of 5G as we experience today is still broadband access where money is made. And let's have no doubt about it, okay? You ask TSPs, they'll tell you mobile broadband access is not giving them the money needed. And let's also make it, let's understand that there's no universal 5G experience. Maybe coverage is there. There's no universal 5G broadband experience. That takes maybe years before the network gets rolled out and the densification done. But that's a matter of, rolling out and giving the experience. But having said that, in the interim, it has become a profitable exercise to divert the 5G bit pipe, redirect it to homes. That's called air fiber. Where there is no fiber, the service is being offered. But this is very unique for India. It's not true for South Korea, it's not true for Japan, it's not true for United States, well, maybe some parts of the United States. But India is a very, very unique country in this respect. A large country that doesn't have fiber to the home. So the gigabit pipe that's coming to the cell tower is getting almost fully utilized by diverting the connection to homes through something called fixed wireless access. And I'll talk more about that through the experiments we have done. So this fixed wireless access is a happy accident. It's an afterthought. Okay, 5G is there, what to do with it? Well, somebody figured out this is how we use it. But when it comes to 6G, I don't think fixed wireless access will be an afterthought. It's going to be an integral part of the 6G story. And the reason is come back to the physics, the propagation abilities of the signals, so on and so forth, the upper mid-band, 6.425 to 7.125 gigahertz, at least I think it looks like it's a frequency that's almost available on the plate as we speak today. So we'll talk about that. We'll reflect on the propagation characteristics of this upper mid-band. And it seems inevitable that, at least for this region, for some time to come, till fiber gets into every house, fixed wireless access is going to be an integral part of 6G, and we'll discuss more about that in the next minute or so. Then one thing I think most of you must have wondered about when you get into a building. I think this building might have, I don't know, distributed antenna system. I see full bars on my phone. But that's not true for all the buildings. This might be a blessed building, it's one of the unique buildings. Distributed antenna systems, DAS, is really a thing that makes a huge difference whether the signal is 6 gigahertz, 5 gigahertz, 3 gigahertz. It really doesn't matter when you have a leaky cable radiating the signal. But the same signal cannot be brought into the building, placing a cell tower outside, the signal gets blocked by the building. So DAS is going to be a very big role. I think that's going to take maybe a decade or so before we get the full benefits of that. So this is going to have a significant impact if you want to have enhanced mobile broadband, AI applications running on devices. Maybe DAS is something, it's probably inevitable at some point or the other. Okay, so I'll take a step back. We built 5G technology grounds up. When I say grounds up, starting contributions to 3GPP in 2016, time frame contributing to the study phase, then work phase, then starting at that level, starting with 2 people, 1 person in 2016-17. I mean, reading the books about 5G, we started there. It's been a long journey, but it is live, operational, serving people. Let's look at the picture on the left-hand side. This is a 5G, an advanced version of 5G, offering enhanced mobile broadband and fixed wireless access services. The leftmost item in the picture is a 32TR massive MIMO radio, and there is a DU somewhere in that building connected by fiber, and there is a core which we call FWA core, and the state is offering the backhaul connectivity in this case. This tower located on a hospital rooftop, the hospital did not have adequate connectivity for visitors and people for last maybe 5 years. You can ask why and how. It's in the middle of an urban Hyderabad city region. It's a huge hospital, kind of like our AIMS here. The buildings are large, the walls are as thick as you can imagine. TSP signals don't penetrate, they don't have DAS. The hospital is fully occupied. You can't run fiber here and there. So we put this 5G on one of the building's rooftop. Then the third picture, that's called fixed wireless access. There's a little box that connects to this other cell tower. It's in a kilometer range. The hospital buildings are distributed. And the middle is a Wi-Fi access point that's wired through a cable to the FWA. And many such access points are lit up. And people coming, walking around there, you can see, they connect, they take a phone, they connect through a QR code, they get secure access, and they start browsing. These are people who can't afford internet. This is a public hospital. If you start charging them 10 cents to $1, they won't pay for it because they just don't have the money. They would rather use it for coffee or tea. So this is offered. Of course, this is an experimental system, a service that's being tested with funding from the ministry, with the state involved. We are running 50 GB per day traffic in the first 3 months of installation, and the traffic is growing day by day, month by month, as people discover the service. So, and this is a hospital, the staff, the doctors, the labs, they ask, and then we just lit up an FWA point and a relevant Wi-Fi access point, and you just cover the nook and corner of this hospital. So it's just an experience. and the beneficiaries are not people that have a whole lot of money or who can even pay for such a service. The right side is, you see the cell tower, that's about 1 mile from IIT Hyderabad campus. We have a village just adjacent to the campus, and we connected the entire village through fixed wireless access. The households, the school, there is something called Anganwadi, that's a pre-KG, I don't know what you call in English, but pre-KG nursery. The children there, they have been experiencing this network for the last 12 months, starting with outages to begin with, and the last few months, the connectivity did not drop even 1 second out of how many ever seconds are there in a day. And these children, they go through the state educational content that was available, but there was no network for the last 2-3 years. They're sitting there, they have 1 hour of entertainment along with the pre-KG children, and the elementary school kids, they go through state educational content, and there are 3 teachers that deal with like, first to 5th grade. It's just one service that is of this kind, and then the homes are connected, and we use the street furniture, we put the fixed wireless access points, and there's no wire in this village. The base station is connected to our university campus through backhaul. There's no fiber in the cell tower. It connects to fixed wireless access points on the street furniture, and then we use 2.4 gig Wi-Fi inside the homes, and then they can do whatever they want inside the home. There's no wire in this whole, except for power supply, there's no wire in this network. There are 4 such villages now getting blanket coverage, and these are all, there are tribal areas, there are rural hotspots, and you can see that when you go and spend some time, you'll see a whole new world out there. Okay, so now let's just switch gears. What did we learn from this? We want to build 6G. What do you learn from this? The customer premises equipment height, it makes a big difference. Even 5-meter height makes a large difference. Not line of sight. It's not line of sight. It could be completely blocked by trees, buildings, whatever it is. The height is the magical factor here. With this height, you can make a fundamental trade-off between base station transmission power, the number of antennas you have in the base station, finally the cost of the base station as such, the capacity offered in bits per second per hertz, as well as the transmission power available at the CPE. And of course, in this case, by and large, we used omnidirectional antennas at the CPE. There is no gain as such. And the height found to be a deciding factor. You think that 5G would give you, 500 meters coverage, 400 meters. Most places we got in our rural areas, 2 kilometers we got coverage with no problem whatsoever, with 5-meter height. Even you go to 3 or 4 kilometers, as long as you play with the height of the CPE, it's not a line of sight system. So this teaches us fundamentally, when you go to higher frequencies, you go to 6 gigahertz, 7 gigahertz, the game is to play with the height of the CPE and trade it off at a fundamental level to get the required capacity and performance. I'm talking about fixed wireless access. This is not just enhanced mobile broadband. Okay, that's one lesson. So this is something we would leverage going forward. The second is, don't ignore unlicensed spectrum. I mean, if you're ignoring it, then you're at your own peril. The licensed spectrum is used to give fixed wireless access service, then the unlicensed spectrum is used from the street furniture to get connectivity inside the home. If there are any issues, we cable it, but by and large, you avoid that. And inside the home, we use Wi-Fi 5 gigahertz or 6 gigahertz, and outside we use 2 gigahertz. This fundamental integration of unlicensed spectrum and licensed spectrum will be the way forward, for the next 5 to 10 years. I think you'll see evidence of that by some TSPs already embracing unlicensed spectrum. So it will have its own fundamental role to play. You have to do a clever network design. Okay, so we'll go a little bit deeper into technology. So we'll talk about 6G a little bit now. We did some very early experiment. This goes back to almost 10 years. You see this picture where we call it 6G. It has a huge, massive antenna array. I mean, the equipment is like 100 times more than what a 32TR radio that we built occupies. This system, we call it extreme MIMO. We had distributed MIMO, co-located MIMO, Cloud RAN, all sorts of different architectures were developed, tested in the campus. The learning is one thing. There is a lot of capacity that you can unlock using antennas as long as you have real estate. That you see the antenna, it's occupying a lot of space. So on a tower, you put more antennas, more bits per second per hertz you can get. So the limitation is not going to be bits per second per hertz limit. You can get a lot of bits per, let me rephrase it. You can get a lot of bits per second per hertz, throwing more hardware, more antennas, more software, more real estate space on the tower. But what you cannot get is, as you move toward higher frequencies, I think it's evident now going from 4G mid band 40, 2.3 gigahertz to 3.5 now, the electromagnetics will not be very benign to you. The obstructions are the one that we have to fight with. Okay? So it's really the propagation environment that we have to pay a lot of attention in the, I think going to 6 to 7 gigahertz or even higher, every gigahertz will make life a lot more difficult. So that's something we have to pay a lot of attention if you want to unlock the full potential of 6G, because we have seen what happened with millimeter wave. I don't see a millimeter wave transmission point here. So that speaks for it. So let's pay a lot of attention to that in the next few years. So with that in mind, we made the first experiment. We built a system, we can call it pre-6G. This is done like last 3 years. This is a project that we concluded. The conclusion is summarized here. 200 megahertz operational bandwidth. A link is established over a kilometer. 6 to 7 gigahertz frequency band. 1.2 Gbps per MIMO layer. Of course, we're not truly interested in MIMO in this particular experiment. We are more interested in what this system can offer. 8.93 microseconds, that the fundamental unit of time slot here, but we can stagger them to make a longer time slot. So you can make the system as much low latency as you desire. So, thank you. So this system has achieved some fundamental goals that we wanted to set. Low latency is possible, low PAPR range is achievable. We developed a new waveform to achieve these goals. And this sets the foundation for next level. I'll summarize what we want to do. The phase 0, we studied the propagation characteristics. We'll publish these results. It will be available for the general public very soon. 2026 to 2028, we'll build a so-called pre-6G 3GPP study item aligned system. That's what we're building now. And then this will be deployed, and you will learn what works, what doesn't work. And by 2030, we'll have an upgrade of the system to address IMT 2030 compliant 6G solution. Just to summarize, the lessons from 5G has to be taken. You have to experiment, deploy, test to learn what works, what doesn't work. Creating a standard and putting it to test is not going to help a whole lot. So these tests and lessons and learnings are going to a long way in shaping the 6G ecosystem. Thank you.
Thank you. So thank you so much, sir, for sharing your valuable insights with us. And now, as a token of appreciation, I request Shri Sanjeev Kumar Arya ji, Director CA, to kindly present a memento. A big round of applause, please. Thank you so much, sir. Thank you. And now we move to our next session, session 5, titled Discussion on RAN Development. This session focuses on key development in radio access network, research initiatives, early standardization efforts, and commercial deployments. Speaker will share insights on emerging RAN, vRAN, O-RAN concepts, practical learning from experimental, existing deployment, and their role in 6G standards. To chair this session, it is my privilege to invite Mr. Jishnu A, Head of Standardization, Tejas Networks, India. Mr. Jishnu has over 22 years of experience in telecommunication and leads 60 standardization initiatives at Tejas Network. Please, sir, take your seats on the dais. He has contributed to ITU-T, TSDSI, and 3GPP standards, hold over 20 patents, and previously served as founding chairman of TSDSI Study Group 3. And now I invite our first speaker of this session, Mr. Amit Mananji, Vice President, Network R&D, Samsung Research, India. Please take your seat, sir. Mr. Manan has over 30 years of experience in telecom systems, specializing in RAN, core networks, cloud architectures, and AI-enabled networks. We welcome you, sir. Our next speaker is Mr. Yane Pesa, Head of Connectivity Network Standard, Ericsson. Big round of applause for Mr. Yane. Please take your seat, sir. Mr. Yane has been working at Ericsson in the research and development of 3G, 4G, 5G, and 6G systems since 1998. Previously, he has coordinated Ericsson's radio access network standardization activities in 3GPP and led Ericsson research program for 5G and beyond. We welcome you, sir. And now I invite our next speaker, Mr. Subramanya Chandra Sekhar ji, Principal Architect, RAN Business Unit. We welcome you, sir. He has over 23 years of experience in wireless communication and is among the top 50 investors of India with over 250 patents across 3G, 4G, 5G, and 6G technologies. We welcome you all, sir. And may I request Ms. Pritika Singh, Director TS, to kindly present a bouquet. Can we have the bouquet, please? So kindly present the bouquet to Mr. Jishnu A. Thank you. And a bouquet to Mr. Amit Menon. A bouquet to Mr. Yane. And now the bouquet to Mr. Subramanya Chandra Sekhar ji. So Mr. Jishnu, the stage is yours now.
Can I have my slides? Thank you. First of all, thank you, Abbas sir, Amit sir, and the TEC team for inviting me as the session chair. I'm also happy to welcome Amit Mannan from Samsung Research, Umang Jindal from Ericsson, Subramanyam Chandrasekhar from Rakuten Symphony for this part of the session. So I will give a small talk, around 6 to 8 minutes. I will request other 3 members also to do the same for 6 to 8 minutes. After that, we'll open up for maybe one question each to each of us or few questions. So we have 40 minutes time, so I'll try to close it at 3. Next slide. So I'll just cover what Tejas has been doing in the, starting with 5G advanced 6G research. So we recently implemented and displayed the reconfigurable intelligent surface, which we think is an important part for 5G and 6G FWA. So we actually implemented it in 3.5 gigahertz, paired it with a 64TR MIMO, and then we could see significant 8 to 9 dB improvement in signal quality. So as Professor Kiran also mentioned, propagation characteristics is the key. So we think FWA, and all of us know how India new structure comes up in a very, very short time. So hopefully with this, we would be able to get quite a significant coverage in FWA. So actually Tejas started with FWA in 4G. So our first deployment of was in Malaysia, again to a school connectivity in a remote island in Malaysia with FWA. So we have been working on this FWA for quite some 10 to 15 years on this. The second part of this is we are very happy to have Honorable Minister of Communication and on here actually inaugurating this in the IMC. The second thing which we did was 1600D3. So this is slightly away from the wireless. So this is an optical domain. This again was launched by Union Minister of Communication in Barcelona, Spain. So here we are able to do close to 1.2 terabits per second per wavelength communication. This is basically because we are seeing, as I think in the morning Ashwini from Ericsson was mentioning, we are seeing a big shift happening from human to human communication towards agent to agent communication. So if you see roughly the timeline when AI became so popular after President Trump basically had some of those discussions. And if you just see the last 5 months, the growth in internet traffic has been 20%. This is as per Cloudflare data. So we are seeing that similar thing in the data center interconnectivity part. So all of a sudden the north-south connectivity, which is basically between the user to the data center, is more or less static. But between data center to the data center, it's called east-west traffic. That has been seeing a significant growth. And we are seeing that there is a need for some connectivity between these two. The additional thing which has come up is the requirement of reducing the latency. So there has been some research to use hollow core fiber. I think this has been part of the AOC testbed, which Indian government has been funding in IIT Madras as well. So some of the initial research on hollow core fiber has been happening. So this is right now between the data center, which is being used. From a transponder perspective, there are minor changes, but not a big change from the transponder. So this is another big change, which basically allows you, so the hollow core fiber is basically instead of, we will not be having the core, so it will be an inert gas, which will be instead of the glass, there will be an inert gas. See, I don't know how it will be spliced and all that in a real scenario if it goes out there, but inside in a data center, it's always easy to sort of work with that hollow core fiber. So that would allow, because the speed of light in air is higher than on fiber, this would allow to get significant improvement in the latency. So this is one of the things which we launched as part of Mobile World Congress in Barcelona. We also did a small recorded video of ISAC channel modeling along with our partners from testing things. So this seems to be another big use case, especially with war happening in Ukraine or Middle East now. The drone detection is becoming a major problem, which has to be done not just at the border, but very much inside this. The other commercial use case is all of us have been doing this quick delivery, 10 minutes delivery. Hopefully we will get a 1 minute masala dosha delivery soon. So that is where the commercial industry is moving towards. So hopefully this ISAC would help towards driving towards drone-based delivery. Sadly, that may lose some jobs, but let's see what happens. Okay, so this is the other thing which we showed in MWC 2026. We will be doing further demos on ISAC because this seems to be a very good use case going forward. Next slide. Yeah, coming to the standards, Tejas has built up a slightly, we started with 1%, now we have a 20% team contributing to 3GPP. Last year we did around 185 plus contributions, and which to meet the Bharat 6G vision of contributing 10% of the standard essential patents. We are working with IIT Hyderabad, Kiran, Radhakrishna Ganti from IIT Madras, CIVIT, HFCL. We have been able to do quite a significant amount of contribution on to both the framework, TPR and the eval document. So that's in the ITU. In the 3GPP, we just last week, we completed contributing to what is called a SCLC, single cell large coverage, which has become part of 38914. It's 4.14 deployment architecture, which is part of the 3GPP. So along with SCLC and the link distance, which got finalized in ITU, I think we are covered, the LMLC was already covered in 5GI, we will get a much tighter LMLC requirement. So we'll be covering the deployment scenario, which we see, at least in all of us in the Indian community, has been working on this for quite some time, for the last 2 years at ITUR, as well as at 3GPP. We have been able to get this significant achievement in getting this, both at ITU, where we introduced a link distance. This would potentially allow us to, we wanted it to be a completely quantitative TPR, but at least it's now a qualitative TPR, and hopefully over the next generation, we could make it a quantitative TPR. Energy efficiency was another thing we contributed. We have contributed, I think, from India point of view to positioning, sensing. All these numbers have also been finalized. The single cell large coverage is basically for terrestrial network. It will be basically avoiding interference because it's like, this is something which we see in left-wing extremist areas sort of thing. And this was majorly supported by DOT, especially TEC and WPC. TEC sort of helped during the framework time, and in the TPR and the eval time, both WPC and TEC supported this initiative. Next slide. So I'll just cover what are the other standardization body which are involved. So ITU and 3GPP we discussed in the earlier slide. So we contribute to both of that. In addition, TSDSI has been doing a significant work in standardizing the reconfigurable intelligent surface. The version 1 was done I think a year back. We did our product based on version 1, and we have found some issues which we will be fixing in version 2 of the TSDSI standard. RIS is not being taken up by 3GPP, so hopefully it will be completely owned and managed by TSDSI. The other thing which we are working on is about AI observability. So this is something which we see, especially from an Indian point of view, especially we have a large number of deployment which has happened, at least from Tejas point of view, 100,000 sites which are in 4G, which we are sort of migrating it to 5G. So just to observe it and make sure many of the network operations are automated, we are sort of starting, it's called the Tejas Observability Platform, and we are now trying to standardize that as part of TSDSA work. AI RAN, I think in the morning Nokia had some slide on this. There is some effort called AI for RAN, AI on RAN, and AI in RAN. So this is not a standard in that sense. It's mostly like a deployment standard. So how do we do the deployment architecture? So that AI RAN is another body where Tejas is as part of Tata Group along with Tata Elxsi. ORAN is another activity which is happening. So hopefully we will have a much better front haul, unlike in 5G, where it was completely a moving target. We started with 7.1, moved to 7.2, and then 7.3. So hopefully we will get some standardized interface. This at least still not very clear where it's heading towards. There is now a serious effort in something called TIP. This was started by Facebook, but I think now the operators have taken over and has been putting together test cases which most likely would be applicable both for ORAN and ARAN scenario. That should hopefully allow all the interoperability, which was another concern which many of us had during the 5G days, to be sorted out. So we are working with few of those operators as part of the TIP. Bharat 6G Alliance, as Kiran also mentioned, so there is some timelines which are published. There is a Gantt chart which Hon'ble Minister itself is tracking for eventual deployment from India. So with this, I'm basically closing my thing. So few of these ARAN and ORAN, I think two of the the subsequent session will discuss it in detail. So I now basically call Amit Mannan from Samsung Research, maybe followed by Umang Jindal and Subramanian Chandra Sekhar to just address the floor. Thank you. So you have 6 to 8 minutes.
So good afternoon, friends from the Telecom fraternity. It's indeed a privilege to be here, and it's quite unique that I share the dais with my co-panelists where I see both competition and customer. So it's really a unique kind of gathering. I have a few messages towards RAN developments, as we move towards 6G. Honestly, we are extremely busy at the moment serving our 4G, 5G network operators. There are so many problems to solve. Yet, from those experiences, we'd like to share what we feel the characteristics of a 6G network should ideally be. And I apologize in advance because some of these messages are going to be repetitive and it's post-lunch as well, so kindly bear with me. Next slide, please. So a look at the key technology trends towards 6G. Of course, softwareization and virtualization we believe is the key. Flexible, scalable network functions based on cloud technologies and open interfaces. This should lay the foundation towards 6G. AI native and ubiquitous coverage, I think, has been mentioned n number of times in the discussions before. But I think the key message is not to add AI as an afterthought, like we are trying to do in 4G, 5G networks, but to build it into the architecture from day one. So that's the key. And as far as ubiquitous coverage is concerned, the key is how to make the terrestrial and non-terrestrial networks work well together. So I think these are the two very base elements of 6G. Everybody knows this. Use cases like immersive extended reality are very important, especially for companies like us. As you know, we have interests in network and in device ecosystems. And we know that the VR AR market is expected to exceed $1 trillion in the next 5 years. I think 6G will give it the necessary boost. I'd also like to speak about digital twins. Maybe it wasn't mentioned that much today. Honorable Minister did mention it, of course. I think creating these virtual replicas to allow remote monitoring and interaction without spatial constraints is going to create some real path-breaking use cases. Actually, digital twin works very well with AI as well, specifically for our telecom networks. Imagine we create a KPI twin of a network where we can validate our AI models before we deploy it into networks. So I think one key suspicion the operators are going to have while deploying AI is what's it going to do, right? So to validate that, a digital twin concept will be hugely important. And of course, massive communication we all spoke about. We're looking at millions of devices going ahead. IoT has been around for a while, but that's going to multiply big time with the arrival of 6G. Next slide, please. Yeah. So we expect AI-friendly and data-driven networks in the future. Data center-like architecture is optimal to add AI capabilities and networks that are easy to maintain. Now, one key area is autonomous or zero-touch networks. I think here what we are looking increasingly at, and I think was mentioned by a speaker before as well, is agentic AI. Basically transforming the network operation centers to completely remove manual intervention. Some of the top 3 use cases as far as autonomous operation we are looking at is 1, RAN speed optimization, 2, energy savings management, and finally antenna tilt for higher coverage. So these are the starting point, but I think the potential is endless. Then we obviously have the concepts of dynamic network slicing, where AI can engineer creating specific slices for critical operations. We expect that to be key as well. Predictive maintenance is of course a very important concept as well. Self-healing networks are definitely something we have experienced making a huge impact among our customers. And I think going forward, the telco-specific LLMs hold the key. Now, it's not just about using ChatGPT, but designing LLMs specifically for the telecom use case. They would be based not only on network KPIs and logs, but also RAG-driven, where they would utilize the operation manuals and the history data of trouble tickets in the network. So this concept, we believe, would definitely fuel the path towards 6G. Next slide, please. For the success of 6G, it is important to pursue future-proof and sustainable user experience. Few words still about AI native. What does AI native mean? I mean, some of our initiatives have gone in the direction of creating an AI ML framework that could reside within a network element and could facilitate a kind of infrastructure for various pods in the network. This could be even done at a DU level. It could also, of course, be done at a higher layer for network management functions. Sustainable networks, I think we have discussed a lot. I think one obvious way, I mean, if we deploy a vRAN network with a truly microservices-based architecture, it is ideal to upgrade to 6G at a later point. And such a network would naturally be energy efficient because of the scale-in, scale-out capabilities that come to you with vRAN. Security and resilience have to be there, unfortunately, but the key is whether they are able to impact our throughput or not. Ubiquitous coverage we have discussed already, and spectrum utilization is obviously important. We believe that there is a lot of potential in the 7 to 15 gigahertz band, and we continue to focus on those areas. Next slide, please. So in conclusion, I'd like to summarize. I think my 6 to 8 minutes are nearly done. The lines between telecom, cloud computing, and AI have permanently blurred, so convergence is the key. Future telecom breakthroughs will rely on software engineering, data science, and AI models as much as they do on hardware physics. And finally, building 6G isn't just about making things faster, not just about speed and latency, but making the network intelligent, autonomous, and energy efficient. Thank you.
I'm sorry, I think it's not Umang, Yani Pisa who will be doing the next talk. Thank you.
So as many of you may have noticed, Umang was not able to attend this one, so I had to step in on his behalf. At the same time, that is a great opportunity for me to talk about not only about ITU, but also about 3GPP, and it's sort of will be some reflections on where we are on 6G standardization. What is the current status? Where do we go next? So if you take the next slide, please. So if you look at the current situation in 3GPP, this is pretty much fresh off the press. This is exactly where we are today. And I've tried to group this a bit based on the different run working groups. So we have physical layer, we have the protocols, but then we have some that didn't really fit into any other groups like non-terrestrial networks. But starting with the physical layer status, basically where we are is that we have the fundamentals of the physical layer pretty well covered. We have the basic waveform in place. It is well aligned with the 5G waveform. We have the numerology well aligned with 5G, so that will make it easy for us to coexist with 5G. We are basically compatible with 5G, but of course we are better. We have initial decisions on how do we look at the basic properties of physical layer. So we will look at if you look at the modulation channel coding, we are trying to build on the 5G legacy. So we take what we have 5G, and of course we try to make it better. So for example, we are looking at how can we improve the modulation by introducing some of the more modern concepts like stochastic or probabilistic shaping. And for channel coding, we are looking at what are the latest academic advances into that. But the fundamental tone of the physical layer is that it very much is 5G inspired physical layer. It will not be identical, it will not be backwards compatible, but it will be compatible in a way of coexisting together with 5G. I also note that coverage, which is very important, not only for India, but for all of the world, but especially for India as well. We have an agreement of targeting the same coverage that we have for 3.5 gigahertz spectrum, also for the 7 to 8 gigahertz spectrum. So that, I think, is the physical layer, very much derived from the 5G physical layer. On the higher layers, there I think we have more opportunities. It's less critical for us to be completely compatible with the protocols that we have for the link layer or even higher layers with 5G. That will not make it easier for us to coexist with 5G. It will not make it easier for us to build the system. So there is studies ongoing on all aspects of the higher layer protocols, control plane, user plane, looking at can we do better security. And these studies are fundamentally looking at all the possible solutions, not really ones that are based or inspired by 5G, but also looking at more radical approaches. Then I have to mention already on protocol level that one of the key things, things that was really brought up for 6G is the AI. And for AI to be successful, we need data. So 3GPP is working on creating a common data collection framework that will enable us to collect data not only from the network nodes, but also from the UE. And that can be used then for whatever purposes, for AI, for machine learning, for sensing, for positioning, or whatever. Then as a final note on this slide, for the satellite communications, like was already mentioned this morning, 6G will be the first 3GPP system that will have satellite communication built in from day one. So that is one of the requirements. We will support both high and low orbit satellites. We will harmonize the design that we do satellites with terrestrial networks. So they will be same design, but of course there may be some optimizations that are different from the satellites. And we will support the interworking between satellite and the terrestrial networks. Next slide, please. So then we move on to the network architecture. Here I think maybe the most entertaining fact about recent 3GPP status is that we have a name for the base station in 6G context. It's not called E0B, it's not called H0B, it's called A0B. And I honestly do not have to know, I do not know what kind of an inside joke this A0B is, but this is what 3GPP will end up calling a 6G base station. There's an ongoing discussion on the overall architecture for the 6G. So we are looking at what kind of functional speed we want to have between RAN and core network. Is it pretty much same what we have today? Is it a service-based interface? There's an ongoing discussion on the different functional splits possible in a RAN. That's something we have to discuss and decide. There is no decisions on that yet. But there is a decision that like I mentioned this morning, 3GPP will acknowledge the O-RAN open front haul specifications, and it will be possible to build 6G base stations, 6G networks based on the O-RAN architecture. On the spectrum side, I think we have fairly limited number of actual decisions. We do know that 6G bands will have the prefix of S, so they will be S bands. Then I think what Matthew was highlighting was that we have fresh off the press, so basically from last week, an agreement on the channel bandwidth. We have decided that we support a minimum of 3 megahertz, but now as of last week, we already know that we are able to support 400 megahertz bandwidth in the base station side, both in uplink and downlink, and optional for the UE to support that in a downlink as well. So we have basically support for 400 megahertz already agreed to be included in 5G specs. Then on migration, so the reason why we have created the physical layer to be compatible with 5G is to make it easy for us to migrate the network from 5G to 6G. So the assumption is that we will aim for the standalone 6G operation and try to rely on multi-radio spectrum sharing, so operating 6G mobiles on the same band as we have a live 5G network. So it is a possibility that we can mix and match these freely, simply because these properties of the 6G physical layer are expected to be so similar to 5G that we can do this. There may be additional scenarios to preserve the throughput for the US, but this is something that's being still studied in 3GPP, and we don't know that. Then final slide on where are we in O-RAN. So if you take the next slide, please. In O-RAN, the work is much earlier than in any other forum. So in ITU, we are done with requirements. We will now start looking at consolidated input that we get. In 3GPP, we are very much at the peak of the study phase. We are getting in ideas from all over the world and trying to find the best solutions. In O-RAN, we are starting the work. So what we have done so far is that there has been an agreement in O-RAN to work with 6G. There is a first meeting, January this year, where the study items have been agreed. So there is a plan on how the work will progress. There's quite a lot of them in place. But the high-level principle remains. O-RAN and 3GPP together will create one 6G system, and O-RAN will complement 3GPP by doing some of the business specifications, like mentioned this morning. The time plan is aligned, so the ambition is that we will have the specifications from the 3GPP and O-RAN available at commercial deployment at the same point of time. And then some of the topics that we expect that O-RAN will actually discuss. They are basically the evolution of the RAN intelligent controllers. Currently there is a near real time and non-real time. Taking the Ericsson hat on, I think I can honestly say that this non-real time rig is the one that has really taken the market completely. The near real time rig is much less commercially successful, but we will need to find a way of either evolving both frameworks, dropping one of them, or combining them together. So something that O-RAN will study on how do we handle these two different independent RAN intelligent controllers. Then there was quite some discussion in O-RAN on now the O-RAN is only focusing on management of the radio networks, but fundamentally the same concepts of having these third-party applications, R apps for radio, but we could have C apps for core, for managing or obtaining core network data or running AI models in core network. So how do we align the management of RAN and core networks is one of the potential topics for 6G work in O-RAN. And then finally, the AI, of course, is a very significant part of the O-RAN as well. So there is an ongoing discussion on how do we handle AI in O-RAN, especially on what kind of implications will we get from agentic AI in O-RAN architecture? What kind of an agent support we will end up having? Do we specify some kind of an AI fabric that will make it possible for us to discover, secure, and introduce new agent into the network? And that, I think, is the status that I was hoping to give today. And I think it shows that the work is really ongoing, not only in 3GPP, but in other forums, and that we are very much at the point of this is when the ideas are happening, and this is where the ideas should be brought into 3GPP, O-RAN, and any other forum discussing 6G at this point of time. Thank you.
Now, let me call Subramaniam Chandra Sekhar.
Hello and good evening to all. So our session today is a discussion on 6G RAN, and what better to start with learnings from 5G. Next slide, please. On agenda, I have some practical learnings from 5G, followed by some of the key developments from 6G RAN, where I will also share views, some of our views from Rakuten Symphony. Then we have the emerging concepts in RAN, vRAN, and O-RAN, or the relevance of that. And finally, I will present or share some research initiatives for 6G, maybe or beyond, and some later releases of 6G as well. Next slide, please. So here, when we start with the practical learnings, this has already been deliberated much in 6G scope in 3GPP. So to start with, there was a very slow adoption of standalone 5G, which is very well known. We pushed for NSA or dual connectivity in scope of 5G to begin with, and therefore ended up almost not having standalone everywhere in different parts of the world. So pushing for a standalone first approach with a clear migration path and avoid specifying multiple options of MRDC or NSA migration paths as we had in or transition from 4G to 5G is very important. Then in 5G scope, we had many solution space where more than one solutions were specified for the same problem. Example, MRDC again, mobility also. We had LTM, CHO, then DAC. Almost a lot of them were specifying the solution for the same problem. This also should be avoided in 6G scope. There is a high cost and complexity associated with FR2 deployments, which meant that it's not a low-hanging fruit and not available or viable for commercial deployments. So the nature or the characteristics, radio characteristics of FR2, like path loss, and then also the sensitivity to blockages, etc., meant that the network had to be a lot denser than an operator would prefer, which meant site acquisition, power, and backhaul, front haul expenses were very high and also complex. So simplified initial access and mobility in terms of, say, SSB beam search or beam management, then adopting a balanced spectrum strategy like prioritizing the mid-band, the one that has been currently envisaged for 6G as FR3 for coverage and capacity, and involving the high frequency spectrum for direct line of sight deployments would probably make FR2 more viable. Then lack of prioritization of some of the most important features of 5G, like AML standardization largely was left to proprietary implementation in the big initial releases and got specified only in the later releases, which never saw the light of the day. Then we have network energy saving features, which were again standardized very late. Then we also had one of the very important mobility solutions, namely LTM, L1, L2 triggered mobility, which arrived again in release 18 and not implementable or very late. Then one very important issue that I would like to point out here is the backward compatibility, which is not the general backward compatibility that everyone knows. So for example, let me take a feature, asymmetric uplink downlink, which was introduced in release 18, introduced 5 megahertz bandwidth in downlink and 3 megahertz bandwidth in uplink. But this is usable only by release 18 features. Pre-release 18 features cannot even attach, therefore hindering commercialization. Similar was the case with another network energy savings feature from release 18, ODSIP1, which was inaccessible or which is inaccessible to pre-release 18 UEs. So these kind of features, which are possibly completely opaque to previous release users, should be thought about. Let's go to the next slide, please. Now, I'll talk about key developments that are ongoing in 6G RAN. I think Yanne already touched base on that in quite detail. Migration and spectrum, we have MRSS, which is multi-radio spectrum sharing, as an important day one migration solution, and we are not banking on other NSA features. Interoperability of MRSS, at least in low band FDD and mid band TDD, is desired. When we say AI native RAN, the previous speaker talked about what is AI native, which is very important. So AI native air interface and integrated AI driven RAN use cases are very important, or are seen as very important in scope of 6G, making AI ML very integral to network cognitive capabilities. And in NTN integration, we almost have heard it multiple times, coverage and ubiquitous coverage and connectivity. Seamless NTN harmonization for mobility and ubiquitous coverage is very essential. And the way we see to integrate or provide a seamless integration is to minimize NTN specific aspects, and we therefore have to include NTN as part of the base release along with the TN and not make NTN as a separate or a parallel branch. Then come to mobility enhancements. We need a unified mobility framework that is enhanced by multi-TRP, which is one of the, again, important features of 5G. So a toolbox approach where some of these features like pre-configuration, pre-processing, early uplink, downlink sync, all of these could be used as tools that are developed in scope of 5G, which were greatly useful to reduce user plane interruption or user interruption during mobility. Lastly, with respect to energy efficiency, we have to see energy efficiency in 6G as a core design principle for both network and UEs. NES features like ODSIP1, CellDTX, DRX, ODSSB, which couldn't see the light of the day in 5G, have to be day one features, therefore benefiting both network and the UE. UL WOOS or uplink wake up signal for UE power savings is seen as very important as well. Next slide, please. When we talk about emerging concepts in RAN, a flexible and scalable architecture is very fundamental to that. So we think that a disaggregated architecture enabling virtualization, pooling, multi-vendor sourcing, where the vendor could pick up each logical entity or hardware from different vendors, and cloud native design is very important. A standardized front haul, including both higher layer split and lower layer split, will promote open RAN and accelerate 6G productization. Reuse of 5G hardware is another very important thing that we think is essential. Enables cost-effective 6G and continuity from 5G. Again, a 5G split RAN architecture as baseline will support hardware reuse because we think that it is easier to continue. With vRAN, hardware agnostic 6G RAN, where software-based RAN functions are on cloud infrastructure, defines vRAN. Distributed cloud computing across edge and central clouds. Split RAN architecture is again the primary focus or central to NFV, SDN, such concepts, and cloud native deployments. And when talking about ORAN, we can't just emphasize how important it is. ORAN remains highly relevant in scope of 6G also because it is completely complementary to 3GPP. I give you two examples. One is DU-RU separation, which is recognized by 3GPP, but has to be specified outside 3GPP. This was also touched base by Yane today morning. And another thing, very important thing, is that often, even though we don't want, as I mentioned earlier, we will have multiple solutions for the same problem. And ORAN narrows down the solution space, forging multi-vendor interoperability. So ORAN is very relevant in 6G space. Next slide, please. So in this last slide, I talk about research initiatives that could be applicable to later releases of 6G and beyond. AI native wireless networks. AI is expected to be deeply ingrained and integrated into future wireless networks. So the research will be ongoing for a long time in field of predictive mobility management, traffic prediction, network automation, AI-driven beamforming, etc. Then another topic that we see as important is post-quantum cryptography, which delivers quantum resilient wireless networks, but it comes with its own challenges. PQC uses much larger keys and signatures, larger authentication messages, higher control plane overhead, which means features or users of massive IoT, URLLC, and high mobility are very much impacted, and this has to be addressed. There is additional delay, memory, processing overhead, and other challenges that are also associated with PQC. PQC may be very powerful, but it doesn't come for free. UE-centric cell-less RAN architecture for massive MIMO is another space where research is heading. It means there are no fixed cells or a single base station serving the UE as we have had from 2G, 3G, 4G, and 5G in 5G. Multiple antennas serve users on the same time frequency resources using beams coordinated by access points. But surely, maybe this is not for 6G. It could be for another technology coming down the line. There are challenges associated with this as well, like access point synchronization, mobility, pilot contamination, and interference. Lastly, I list TN-NTN integration as one of the research topics, though there is already a lot of work ongoing in this domain because of the disparity between TN and NTN, like satellite link latency can be up to 250 milliseconds, while it could be less than 1 millisecond in terrestrial networks. Similarly, LEO, MEO satellites introduce mobility and Doppler effects. Mobility, not just, I'm not talking about the UE mobility, it is the satellite mobility. So therefore, HARC, timing advance, and frame structure differ significantly at physical layer, and then coverage, mobility, beamforming, and power control are also fundamentally different. This radio characteristic divergence makes TN-NTN integration a long-term research topic. So I would want to conclude at this. Thank you very much for providing me this opportunity.
Sorry, I think we have run out of time, so we can't take. Okay, we can take one or two questions. Yeah. You have a mic there, or? Can you introduce yourself and then? Yeah, we can hear you.
My additional question to this is that basically we are discussing about ROI, means how return up on investment will come. That is the basic question. Like 5G, we have seen that return on investment, operator side view.
I think well, let him answer the first question and then you can ask the second question. So the first question is, I think India and one of the largest operator actually rolled out SA, and still ORAN was never tried in a big way. So why do you think that SA, if it is done in 6G, for example, ORAN can kick off as part of? How is SA and ORAN interconnected? The NSA versus.
I mean, the connect that I was trying to bring out was between NSA and SA in terms of specification and also deployment. Because of the delay in specifying SA, where we prioritized NSA and introduced something like 7-8 options, SA was one among them. That delayed SA deployment through or commercialization throughout the world. So I did not get the point of connecting SA and ORAN. Could you say that again or explain what you meant?
I mean, it's one of the learnings from 5G was that ORAN could not be adopted in India in case of 5G because we were too slow for SA kind of adoption, which was there in case in India, in case of the
I don't know why ORAN delayed SA, but all I was trying to point out as a flip side was that we ended up spending a lot of time specifying NSA options which were never deployed For example, you see NRDC, NGDC, all of these options where 4G was connected to 5G core, 5G base station was connected to 4G core. Only one of the options, 3X, is realized predominantly as a commercial deployment. Otherwise, people ended up deploying SA, which got late because of the specifications or the time involved in specifying MRDC options.
Okay, hopefully that answered it. So basically it was also, in ORAN also similarly multiple options were given, 7.2a, b and all that. And eventually there was something with ULPA which came later. So fundamentally the issue is too many options, it always creates a problem. So it's like, it's better to have a single option, standardize it and move forward. So that's what I think as all of us. The second question?
Second, it was related to return on investment, operator side's view. Suppose someone is investing, how, like 5G, we have seen that number of things were initially thought of, but it was used for very less use cases in advanced things. Like we were discussing about remote operation, and that was discussed in 5G also. So question is that how someone will invest in the technology-wise, it's okay, we are going to say that it will happen like this, and development will be like this, but how it will affect, what is the operator side and investor side's view on this?
Okay, so can each of you tell what is the ROI for 6G? One sentence maybe on what is the ROI for 6G? Because all the use cases as per him is similar to what was there in 5G.
Yeah, I think, okay, on the a little bit informal side, it's a lucky G. So, 4G was a hit and 6G should be a hit. But I think 5G essentially, I think the founding principle was latency and speed. But as we see 6G, there's much more to 6G. There is clear focus on ubiquitous coverage, on sustainability, right? Therefore, one can expect a larger and wider impact. Second is the advent and ascendancy of AI. So I think with AI coming in and being a key factor of 6G, and we're seeing the impact AI is having on all industries now, that we can really hope that with a network designed from the beginning for AI, the impact can be bigger.
No, but spectrum, we are going from 20 megahertz to 400 megahertz. The spectrum charges will also adapt.
I think that was a great answer. I would fully agree with that as well. But I want to bring in another aspect. I think the return on investment will really depend on the operator scenarios. So what we are trying with the 6G is to build a generation that has something for everyone. So we have tools for making a generation that is cheaper to operate, so reducing total cost of ownership, something that is easy to manage, that consumes less energy. In general, brings a savings in network operations. We want to make a generation that enables new services, AI-based services, AR-based services, sensing. It brings in something for the operators that actually want to invest in the new features. And then finally, of course, we bring in a generation that makes it possible for operators to handle data growth. So it will bring you new spectrum, it will bring you better spectrum efficiency, basically bring you everything that you want. So it's something for everyone, and hopefully there's a return of investment for all operators to invest in 6G.
Yeah, I totally agree with Amit and Yane. So I also touched base on this in my slides, where some of the important features of 5G were actually specified very late in the day in release or post release 17, where you see AI and network energy savings and LTM, which I highlighted as three of the important features, and MTRP for MIMO. All of them came very late. So unless they are brought to the base release or unless they are made mandatory, it's very hard to see commercialization, because it is a challenge for vendors and operators to invest more and more after the first release. So that is one. And along with AI, NTN is one of the very important takeaways from 5G. That would be a very good ROI, which is planned to be smoothly integrated with TN.
Okay, thank you all of you. So just to conclude this session, so basically there is a good, many of those things which we actually envisage to be done in 5G is hopefully to be done in 6G, because some of these things actually got into the standard only in release 18, 19 or later. By that time all the devices which were in the market was already 15, 16. So effectively we couldn't get all those features like low latency or different IoT, and so the initial use cases was not built in the first two releases. Hopefully in 6G we are not having much options. The first release itself have 3 device type, FWA, IoT and MBB. All of this actually is indicating that whatever we couldn't do in 5G, hopefully we'll do it here. Coverage and energy efficiency were 2 things which we never did it properly in 5G. Hopefully that will also be done in 6G. With this, I will conclude my session because we are run out of time, and I'll leave it. Thank you.
So thank you so much for this informative session. And now I request Shri Arvind Kumar Tripathi ji, DDG FN, to kindly present mementos to the session chairs and the speaker. So memento to Mr. Jishnu A. A big round of applause, please. Thank you so much, sir. Memento to Mr. Amit Manan. A memento to Mr. Subramanya Chandra Sekhar ji. Thank you. And as for Mr. Yane has already been presented with the memento, so once again extend our thank you for your presence today. Thank you very much. Thank you so much. Thank you. So we now move to the session 6, titled Intelligence in Future Networks. This session explores the role of AI/ML as a foundational element of 6G networks, enabling intelligent, adaptive, and autonomous operation. It discusses AI-native telecommunication network architectures, key design principles, and representatives use cases that go beyond optimization to native intelligence. To chair this session, it is my pleasure to invite our session chair, Mr. Raja Gopalan, Chief Technology Officer, Communication Technologies and Platform, Tata Elxsi. Big round of applause for Mr. Raja Gopalan. He is currently serves as the CTO of Communication Technologies and Platforms at Tata Elxsi. He leads solution for telco and automotive industries in softwareization, digital twin, connected vehicle, and edge solution using open system and open platform. We welcome you, sir. And now I invite our first speaker for this session, Mr. Ratnakar Rayabarapu, Vice President Mobile Communication R&D, Samsung Research. Welcome, sir. With over 25 years in mobile communication, he specializes in wireless and internet protocols and played a key role in Samsung's early 5G device launches globally. A senior member of IEEE with 30 plus international patents, his current interests including AI in wireless and next generation networks. We welcome you, sir. I also invite our second speaker on stage, Professor Ganesh Ramakrishnan, IIT Bombay. We welcome you, sir. Professor Ganesh is the Bank of Baroda Chair Professor in Digital Entrepreneurship at IIT Bombay, where he also earned his BTech and PhD. His research focuses on large language models, generative AI, AI/ML in resource-constrained environments, and NLP. We welcome you, sir. And I request our third speaker on stage, Mr. Vishnu Ram Ovi, independent researcher and ITU expert. Mr. Vishnu has hands-on experience in the field of telecom industry for more than 2 decades, developing and implementing standards in the area of wireless communication and holds many international granted patents. We welcome you, sir. So now I request Shri Arpit Shukla ji, Director Radio, to present the bouquet to our session chairs and speakers. So bouquet to Mr. Raja Gopalan. A big round of applause, everyone. And now the bouquet to Mr. Ratnakar. We present the bouquet to Professor Ganesh Ramakrishnan. And now we present the bouquet to Mr. Vishnu Ramovi. Thank you so much. And Raja Gopalan sir, please come forward and chair the session.
Good afternoon all. Happy to be here in talking about intelligence and future networks. So this is a session where we are going to talk 6G and beyond for a change. This has a much larger context in terms of AI. When we are discussing about AI, the safe and ethical and also explainable AI needs to be brought into place, which is something we need to discuss as we are going forward. And when AI comes in, when we are discussing about energy efficiency in the network, it is kind of an ambiguous part. It brings in the ambiguity of large energy consumption in terms of the GPUs, in terms of the number of parameters which are discussed in the LLM and so on and so forth. So we need to discuss about some of the concept called telco LLMs, tiny LLMs, and then the transformer architectures which are pertaining to the specific telemetry of the telco networks rather than what is being formulated and designed for language models. I think those are the things I would presume that would be covered. Can we go to the next slide, please? So in the future of networks in the 6G, definitely we would see the AI native design across the multiple domains, be it RAN domain, how the RAN elements are being built in terms of, let's say, the channel modeling, channel estimation, channel equalization, even to the extent of channel coding, there are potential and possibilities of bringing in the AI into the system. Similarly, on the core, already from Nokia, Nirant had discussed about what are the options which are possible, and onto the transport architecture. And most important here is this: in the 6G, the focus has to be on the data-centric paradigm. Typically, up until 5G, a lot of importance is given to the functional, modular kind of a design, structural design. The AI coming into place, Gen AI coming into the place, language model coming into place. In order to have a newer AI plane beyond control plane, management plane, we need to have AI plane. To have an AI plane, the whole design has to have a data-centric processing, and the most important emphasis going forward has to be also along with the air interface, interoperability testing, air interface, interfacing, etc. How much of importance has to be given for O&M interface, or the FM, PM, KPI? They need to be not only standardized, they need to be also certified and tested. the deployment testing by the telcos and service providers needs to have a lot of emphasis on even the testing of the O&M now, because then only you can have a standardized AI layer, standardized data semantics, which will make the autonomous network a cost-effective solution. Right now, going from autonomy level 1 to, let's say, autonomous level 2, 3, 4, it's a very, very cost-effective, cumbersome process, because the multi-vendor systems, multi-domain systems do not follow a standardized way of data exchanges in KPIs and parameters, etc. That is where the importance of the open interface, open standard, open data format comes into a bigger emphasis here. So these 4 pillars of AI native, autonomous, safe, data-driven, even to the extent of having an agile CI/CD into the RAN domain, so that some of the speakers talked about the AI is getting into the next phases of consideration in the standardization. So when the AI modules and models are available, having a platform approach of CI/CD getting onto the RAN will make the update and evolution of 6G and adoption of 6G in a larger scale will make it easier. Can you make the next slide, please? So this is the just an expansion of the openness and how the openness can bring in the new innovation ecosystem players beyond the existing players into the mobile technology. The mobile technology, in the last session also, when we are discussing about return of investment, that is also from the cost of building the network, cost of managing the network, cost of testing the network was huge. So when the platform, the 6G as a digital infrastructure, as a digital platform, when it is built as an open platform with open machine learning models being brought into this, it has a potential to bring in innovation, new innovation ecosystem, new players of academia, industry, and then AI native players into the 6G telco ecosystems. That is the potential of the openness bring to this. And again, the emphasis on the testing and certification for the intelligent telemetry, so that the data plane, AI plane can come into existence. So can you move on to the next slide, please? So this is the how the agentic and multi-domain agentic orchestration can come into place if we have a standardized AI plane beyond the control plane. This is an architectural blueprint, and you can see one of the key takeaway from this slide is when we are discussing about telco, the mobile network, that is of a digital infrastructure of national importance, and the autonomy cannot be fully autonomy. So the high risk critical operations, for example, an update of an software, update of a security patch, update of any major bug fixes, can it be done at one single shot to all, or does it need a governance, does it need an approval? So the autonomy has to have a governance, autonomy has to have a guardrail, and even the decisions has to be validated by means of some of the principles being put across by the International Association of Safety and Ethical AI. So they try to bring in a contrary view of how the autonomy can be guardrailed in terms of critical actions, because the agents always have a goal in picture. The goal can be accomplished by very many means. It could be through benevolent means, or it could be through a malevolent means also. So you need to have a counterintelligence, and those kind of options needs to be brought in when the network infrastructure is going to be autonomously managed. It needs to have those kind of a guardrail which has an validation against the decisions. Can you move on to the next slide, please? So the role of digital twin when the data-driven and AI is coming in is of phenomenal importance in terms of modeling and in terms of validation and verification also. Any kind of a planning and estimation can be done using digital twin. The digital twin here could be purely data-driven, or it could be even a hybrid. It could be a combination of scientific, physics-based, as well as a data-driven digital twin. The data which is coming from the real network could be used for enhance and augment the accuracy and precision of the digital twin. Those are the opportunities which are there. The other key digital twin application, there are almost all the elements in the network can be modeled using a digital twin. It's about the cyber security. When the systems are going to be open, there are a lot of vulnerable and threat interfaces are going to be exposed. Those can be modeled in the digital twin and can be done. Can we move on to the next slide, please? So again, on the RAN, this is the significant, most expensive part of the mobile technology. How the digital twin can potentially bring down the cost significantly. For that, there are certain use cases. I think the fellow esteemed panel speakers will talk about it. Can you move on to the next slide? A lot of use cases from the single standalone RAN to the multiple neighborhood cells and topological way, the digital twin can be brought in for a lot of what-if experiments, the channel mitigation, interference reductions, interference mitigations, etc. So again, the power of data-driven digital twin is being amplified here. Can you move on to the next slide, please? So the AI native network is just the AI native architecture can span across an entire network. That's what is being shown. Can you move on to the next slide? So this is the last slide. So when we are discussing about 6G as a technology, the service providers know every technology update and upgrade has millions and millions of dollars without ROI, I would say guarantees. So how the technology update has to be built in a cost-effective way. That's where how the data itself can be used as a leverage here. The data can be made democratized by the government regulatory bodies and compliance agencies when the data are being deployed. So it will make the innovation cycle to be much more accelerated. The technology deployment can be done in much more cost-effective way, considering that CI/CD and platform-based approach is going to accelerate the innovation cycle and accelerate the deployment. Then the new commercial models, when the cloud nativeness, service-oriented architectures are taken from IT, the business model of the cloud providers can be taken into the telco? Can RAN as a service as a model, spectrum as a service as a model, data as a service as a model, business model, can they be brought into this? And shared infrastructure is another model. So in this way, the open platform standardized approach as well as the innovative business model can potentially pay ways for a cost-effective and green deployment. And that's why the AI nativeness and the autonomy can drive the 6G and further beyond it. And now I call upon the remaining esteemed speakers to speak about the AI-powered networks for 6G era by Mr. Ratnakar Rao, Vice President, Communication R&D from Samsung Research India, to further dwell on this topic. And thank you. Over to you.
So I guess the slide change control is not here. As I'm getting a feel as if I'm already speaking to my virtual assistant, right? We're already in the AI era. So to avoid sounding like a reinforcement learning model, I mean, from the morning we have been hearing why 6G is needed, I mean, what are the use cases it will enable and all. But off late in the last session, and now Rajas has started mentioning the most relevant questions. Okay, where is the ROI, right? Because I'm sure, fine, we'll build a great standard. So finally, who is going to pay up for the deployment? So that's why, I mean, as Samsung, of course, I mean, we have great interest in our networks. We are probably the largest or sell hundreds of millions of smartphones. We contribute to the standards, 3GPP, TSDSI, you name it. We have consumer electronics. I mean, we have all the ecosystem in place. So rightfully, this question, we should ask ourselves and answer it and pass on that feedback not only to our standardization guys, but also to the ecosystem here as well. Right? So let me ask you that question, or let me begin with that question. Why do you need 6G? Right? Nobody asked before, because if you buy any of the latest flagship smartphone, for example, right? Maybe our latest S26, for example, it already has a GPU on board. It already has a NPU on board. It has an octa-core CPU, each with 2.1 gigahertz, processing capacity on the device. So anything you can imagine an AI use case today, probably you can realize it on your device already. Your device is the mobile edge. I mean, you don't need a mobile edge on the network, isn't it? Because already the 1 billion parameters LLMs are already embedded on our devices. And probably very soon you will have a 3 billion parameter LLM on device. So why do we need 6G for? Right? And yeah. Yeah, I'll come there. So thank you for precluding. Yeah, that's what I'll bring up actually. So the next question also is, after say the midway through 5G, the best use case we could bring up, at least on a smartphone, is a UHD streaming. I mean, if you do a streaming of some Netflix UHD or whatever, some 4K streaming, at best you will need some 25 megabits per second of data rate. That's the best possible use case we have today. So then again the question, is it just capacity? No, just multiply this with the number of users. Is that what we need 6G for? So these are the kind of questions probably, I mean, we are asking ourselves so that we create 6G differently than replicating, it as an extension of 5G. Right? Yeah, so next slide please on that note. Yeah. So as we are talking, I mean, the future is the AI era, right? So these are some of the sample use cases. We are just trying to see what is possible today and extrapolate it. I mean, what is likely to happen, say, after 5 years or after 10 years, right? So today you have all these functions, say, on our smartphone, for example. So you have a gallery search, right? You can give some semantic search and you can, get the desired photos from your gallery. But probably your photos are located, some are on device, some are on your home drive, and some are on your Google Drive, whatever, they might be lying elsewhere. So who is going to do this, a multi-entity search and going to bring it all at one shot to the user, right? So likewise, for example, so today you already have real-time translations on device basically. You can just go and show the camera, point to a text of any language, you can actually translate it into any language of your choice, right? But this needs probably the kind of capabilities I mentioned. I mean, you need a very huge processing power and you need a very large memory, which is probably possible only on high-end devices. So what about the devices which are, say, in the 10,000 rupees price bracket or 20,000 rupees price bracket? So can't they enjoy the benefits of AI? They should, definitely in a demography like India, they should. So that's where there will have to be a trade-off, right? What is your on-device compute? What is not possible on your device, where you should go to the cloud and get it done? And that could be your edge cloud, or that could be your actual cloud data center. And now all this should happen, this mix and match of device capabilities and the communication. So they should happen seamlessly, right? So that's why there is a need for a new kind of capability or a new kind of network to empower the AI era, right? Not all devices will be able to have such kind of a compute or a memory. Next, please. So likewise, the other big use case being talked about, right? In fact, if you see the good old 5G triangle, I mean, some of this AR, XR are already there. I mean, maybe the communication technology is ready, but the use cases are not ready. But they're getting ready now. I mean, you would have seen at least 2 commercial devices got launched. I mean, one from our side as well, right? Which are extended reality devices, right? So again, in extended reality, I mean, you need that tactileness, like if you're wearing that XR headset, for example, right? And I'm sure the moment I tilt my head, the information related to my, vision should appear in front of my eyes. I mean, it cannot take hundreds of milliseconds or even seconds, actually. It should appear instantaneously, right? And also now, by bringing the mixed reality devices, now suddenly you don't have a limitation of a single screen. It's no longer just only one smartphone screen which you need to cater to. You can actually have multi-display experience, right? Where maybe one might be for your office work, one might be for your personal work, one might be for your gaming, you're juggling all this, all at one shot, right? So that's where again, I mean, in a way, indirectly, the capacity requirement is appearing there for this mixed reality era, where you have multiple types of content which should appear instantaneously, right? That's where the latency and the capacity angles comes into the picture. Next slide, please. So, but there again, I mean, maybe again, you should be thinking already by now, right? If it's going to be an XR device, that bulky headset which you would have seen in some promos and all, definitely, I mean, none of you will be wearing it and roaming on the roads, right? I mean, impossible. I mean, it's an indoor use case. And I'm sure all of you indoors might be using a Wi-Fi broadband most likely. It's not your cellular broadband, right? So now begs the next question basically. So then again, why 6G, right? Why 6G for mixed reality? So unless you have newer form factors of device which can free you up, which can bring the mobility into picture. Remember the job of mobile networks is to offer mobile services. Anything that is stationary, probably there are cheaper alternatives available, right? So that's where we see the augmented reality glasses as a 6G form factor rather than a mixed reality devices. All mixed reality use cases are likely to be indoor use cases. Maybe it will still be a fixed wireless access kind of use case. I don't know if you're using the mobile hotspot functions on your devices. I mean, it will do a pretty good job and probably sometimes a better job than your home Wi-Fi, right? Yeah, next please. Yeah, next. Yeah. So now this is where we need to start characterizing, okay, what were the kind of requirements which an AR glass throws to a mobile network, which is not possible with today's 5G network, and you will need a 6G network to do it, right? So these questions we should be asking right now, right? Before we go too late and define some standards. So these are again findings. So it's not a capacity need. Once you bring in the AR glasses, whatever our experiments so far found that AR glass will generate much lesser traffic than a smartphone, right? Because the same application, I'm sure, for example, if it's your YouTube or Netflix or Google, if it's running instead of smartphone on your glass, we actually found that it's needing much lower throughput than a smartphone. So that means it's again not a throughput use case. It's going to be a latency / tactileness use case, right? This again we have to be very, very cognizant of this fact, right? But of course, I mean, very soon these displays will evolve. I mean, you will need probably a 4K display on your glasses, right? I mean, there will be probably in the years to come, you'll be seeing a lot more exciting announcements actually, right? There are a lot more exciting pipeline of products which will lead us to the 6G era. So by the time we hit the 6G with the AR glass kind of a form factor, we can definitely expect there will be richer display, richer content and richer applications which will need 6G, not only for tactileness but for throughput also, right? Next please. Yeah, I think these facts, maybe I'll just leave it in the interest of time. We can go to the next slide, please. Yeah. So in that sense, even though I have several more slides, maybe in the interest of time, this is the most important one. So where I want to define what should be the blueprint for a future network that can cater to the AI era, right? So because today you have one common public network, but we are saying, okay, oh, no, network slicing can actually make it happen. It can actually slice the network into various services and you can have differentiated experience. But today it is still a category-based slicing. All streaming applications take one slice. All autonomous solar applications, they take another slice. So it is still a category-based slicing. There is no concept of a personalized slice experience because now each user's context for the same application is going to be different. Because we're all talking about, there are different types of applications. Forget different types of applications. Only WhatsApp, let's take WhatsApp. You could be using it for texting, you could be using it for file transfer, you could be using it for video call, voice call. So depending on your context, one application itself will be generating different types of traffic with different types of QoS needs and QoE needs. So it's not just app awareness. No, it has to be user awareness. User's context needs to be known to the network to enable a personalized experience, right? And of course, some of those users will not be humans actually. They can be your agents or machines or whatever, all those things. But though I'm sure, at the end of the day, the subscription will still be paid by a human. So in that sense, it's important to remember whether you're buying a network for yourself or for your agents. So these are some of the principles which I think we should take into consideration in the standardization process, that we should leave room for all these things. There has to be two-sided adaptations because there has to be a role for the devices. Every adaptation cannot happen only on the network because the user context is available only on the device. Right? So there has to be a two-sided adaptation. And there has to be a joint optimization. As I mentioned, there is some compute on your device, some on your edge, some on your data center, backhaul, right? Behind the backhaul. And also different applications. Maybe ChatGPT might deploy in one way, Gemini might deploy it in another way. So you will need actually a continuous adaptation of the compute communication architectures. Right? And also, like, the network has to be dynamically reconfigurable. Today, if you see all networks actually, they are at best semi-static. And if not static actually, they take some golden configuration and apply it all over the network. Right? Or at best, there will be some semi-static golden configurations. But now, it has to be dynamically reconfigurable based on the user context and a predicted user context. Right? Next slide, please. So on that note, maybe I'll quickly jump on because other topics, all the other speakers also mentioned. I don't want to. So like as I mentioned there, the RAN has to be service aware because whether it's serving, I told you even same application can have different content types. So RAN has to be having service level awareness. Next slide, please. Yeah, and of course, we are doing AI at all the AI natives, so-called AI natives, right? Which means for us, it's actually embedding AI in every layer of the stack. Right? It can be air interface, spectrum efficiency, and up to the core network management. Next slide, please. Yeah, so we believe a vRAN, a softwareized or virtualized RAN is the best place to have both AI for network and network for AI. Right? Next slide, please. There's a standardization timeline. I think we're aligned with the rest of the industry. And lastly, yes, so we have several people who are part of this exercise. So let's all get together and co-create 6G for a successful deployment in India. Thank you very much for your time.
Thank you, Mr. Ratan Kumar, for that enlightening session on right from the compelling need and then application, person, contextual awareness, reconfigurable network. So now we'll call upon Mr. Professor Ganesh Ramakrishnan on the role of sovereign AI/ML ecosystem in 6G networks. What is that?
very enriching ecosystem here, indeed, and I'm grateful to be here. I'm also accompanied by Professor Priyesh Shukla from IIIT Hyderabad. We are Bharat Jan, a consortium of 9 academic institutions, and delighted to join this larger ecosystem here. We function basically, if you can have the slide, next slide. We had a bunch of models launched during the India AI Impact Summit, some of the larger models. And what I'm going to run you through is an AI view distilled into 6G. Okay, so I'm going to take a slightly different perspective. Can you go to the next slide? So I think it's been excellent understanding the stack. So there is a genotypical notion of the stack. I will also talk about the phenotype of the stack, because as we look at a more seamless 6G, you're going to also look at the phenotype and how does it manifest at different layers of the specification as well as its implementation. So the idea behind having such a stack is it enables scaling out rather than only scaling up, right? That's one side. At the other side, you see the elements of trust. Provenance is very key here, right? I mean, databases, people have studied databases, we love provenance. We love observability. How do you bring that into 6G from AI is going to be very critical. Also, the other important bunch of parallels, for example, if you look at the terahertz propagation, can we take lessons from self-supervision? So large language models are built on the principle of self-supervision. You have a lot of unlabeled data, and you mask out some part of the data, right? It could be tokens, it could be sentences, it could be speech utterances, and you're trying to reconstruct. So can that benefit the propagation? Again, another aspect of the phenotype is the dissolution of the network boundaries, right? So multimodal fusion at scale, right? The ability in these models, large language models, to have speech, text, vision, all integrated, and have their representations come as close as possible. That's what multimodality in these multimodal large language models is about. A third aspect is the intractable use case envelope, again from 6G perspective. So this, as the Honorable Minister also talked about, this latency and this fidelity, and there's a perennial trade-off between the two. Can that be stochastically modeled the way it is often done in the case of many of the agentic models? So that brings me to the fourth point, right? If you want real-time control at scale, and one way people exercise this is through retrieval augmented generation, is the simplest manifestation of agentic behavior. How many here have used RAGs? Most here, right? Retrieval augmented generation, everyone has heard of it. But the retrieval function is often a very naive cosine similarity measure. Can it be more nuanced? And can it be very contextualized, right? So that's where I get into this notion of sovereignty. Sovereignty means transparency. Sovereignty would mean control. Sovereignty means you have a glass box view of this model, right? Otherwise, it's actually not going to be affordable at the scale at which some of the frontier models operate. So if you look at this differentiation part, right, the actual algorithms like channel estimation, equalization, some of them will need to be brought in the form of knowledge and not just data. You could also have a lot of ML-driven optimization on the data. And now, one very important point I want to highlight in this slide is the parallels. What we learned from, for example, compilers. GNU created that ecosystem for compilers. In the case of operating systems, Linux created that ecosystem. UPI, our favorite example, again has created that for fintech. So the openness, the point here is openness drives scaling, and that's where sovereign ecosystem matters. We'll go to the next slide, please. So again, I'm going to draw parallels and draw lessons from text, speech, and vision model building, which we have thankfully got very good hold of for the last 1.5 years. So if you look at the SOC operations copilot, right? Can that leverage the power of self-supervision and text large language models? So that the mean time to detect there's predictability around it, right? And there's control. As I said, there's no free lunch in computer science. There's no free lunch. So are you able to govern the trade-off to your satisfaction? The second is example of natural language to network policy. It's an example again of unstructured to structured. Now, some of the experiences we've had in building LLM-enabled speech models, when you project from speech to text, you obviously need to do the due diligence on the speech and the text. But the way you project, the way you design a mixture of experts for the projection, and the way the expert components are having semantic interpretability is going to be very important, right? So the moment you look at this natural language to network policy, the projection becomes very important. And again, having provenance in that process is going to be very vital to the success of this, because ultimately this a model which doesn't give you provenance, doesn't give you observability, after a point will be abandoned. The third is 3GPP standards navigation. Now again, from our experiences with building document vision models, grounding becomes very important. The ability to search through large repositories and translate the textual descriptions in these 3GPP standards and navigating through them with multi-page, multi-document grounding can be another exercise where we distill from learnings in vision document models to 6G. And finally, agentic network management. So the agentic behavior, for my favorite keyword, provenance, but also doing good task semantic decomposition. There was a lot of mention of digital twins, but digital twins have both a complementary and an adversarial possibility, right? So can we use that for robust agentic behavior? As has been told several times, right? 5G today is AI assisted, 5G advanced is AI augmented, and we desire that 6G is AI native, but that's not possible without this glass box view of AI. Next slide, please. So that's where I also bring in a lot of my experience with building this ecosystem. You need data, you need model recipes, right? You see the bottom, the root of this tree, ecosystem tree, is the recipes. Because we don't want to just build solutions, we want to build products, right? So how do you generate IP? And this is an advantage. I mean, this is an opportunity for India to also play a critical role in IP generation here. But you need to be able to build these from the first byte. That's our experience, building these models from the first byte. But that's not possible without research. That's where, a consortium of 9 strong academic institutions has been very helpful. I would encourage that, we co-create, right? That brings me to the last point, which is co-creation. You can't have engineers and researchers sit in silo anymore. And you need to make sure that there is co-creation by design. Now, co-design also requires empathy for each other. So the way I am educating myself about 6G, I've spent quite some time trying to understand, thanks to my colleague Priyesh. I think it's also important it's our job to also help educate people on the other side of what the recipes are behind these models, right? So, I mean, as an example, we've been working closely with PK Semiconductors. Parag Naik unfortunately couldn't make here. He had to travel to the US. But it's been an exciting journey learning together. Next slide, please. And this is a short video. Our journey in building these models from small to large one in a very co-creation, co-design ecosystem that we were very happy to be part of. Yeah, play the slide, play the video. The audio. Can the audio come up?
Our data, our knowledge systems, and our incomes. Early Bharat releases showed the potential of sovereign AI. Powering this AI ecosystem is Bharat Data Sagar, a vast initiative unifying India's data and knowledge from public and private sources. And now, Bharat marks a significant milestone. Introducing Param 2, 17 billion parameter foundational model. trained on 22 trillion tokens of diverse data in 22 Indian languages. Skilled in code, mathematics, logical reasoning, and various domains. Engineered for scale, security, and real-world complexity. Introducing Shrutam 2, India's first LLM-based multilingual speech recognition model. Robust to noise, supports 12 Indian languages, and Shrutam 2, our text-to-speech model suite.
ভারতীয় ভাষা ছাড়া ডিজিটাল দুনিয়ায় সবাইকে সত্যিকারের অংশীদার করা সম্ভব নয়।
Together, they enable natural interaction across 12 languages. AI that listens to माझी पॉलिसी कधी मॅच्युअर होणार and speaks India's voices. तुमची पॉलिसी 26 डिसेंबर 2040 रोजी मॅच्युअर होईल. To see the world through an Indian lens, Patram, our 7 billion parameter vision language model, trained on 40 million diverse Indian documents. It transforms paper into intelligence, powering faster, smarter decisions. From agriculture to governance, education to finance, law to public services. Apni bhasha mein, AI for every sector, for every citizen, for a nation on the rise. Built by India's leading academic institutions with the support of the Government of India. India built, future ready, globally relevant. Join us to unlock solutions for your challenges, and let's build for a Viksit Bharat together. Bharat Gen, sovereign AI for 1.4 billion voices.
Now, this is a joint effort between the Department of Science and Technology, the Ministry of IT through the India mission, and if you go to the next slide, and just an experience building. We've been always trying to build small models, started with 10 billion, 17 billion, though our North Star is 1 trillion, that's what we are funded for. Our experience also translates into model architecture. This is an example of mixture expert for 22 Indian languages, handling code, reasoning, math, and each language. Now, if you overdo the tokenization is a process of breaking the text into tokens, right? Smaller units. If you overdo it based on languages, you might find that math and code suffer, right? Finding the right balance is very critical. The speech model that I presented, we've actually used phonetic units which are similar to all Indian languages, and the text-to-speech models we have are the best in the league. You can try it out yourself. All these models are open source, right? I mean, having 64 mixture components for 22 Indian languages with two shared experts, one representing code mixing, right, mixture of multiple languages, and the other shared expert representing domain mixing. I mean, there is design required at every step. Next slide, please. So, how do we leverage this? I think that's a call for action, right? And here you have the research part, the foundational model recipes, the data. As I said, we worked a lot with data. When we collected the first 13,000 hours of speech data, we had to build an agentic framework to ensure that there was data curation, data duplication, metadata preservation, and so on. So provenance, even in the data, becomes very important. And then deployments, of course, give you your feet on the ground. Next slide. Now, this is going to be the most important takeaway slide. As we build our large models to 1 trillion parameters, here's a call for action, a call for participation, right? For example, if you're looking at something like radio resource management, AI can replace rule-based scheduling with learned policies, right? That I alluded to this earlier as well. And India has unique demographics. Can it be tuned to those demographics? The second, which you see, is the multimodal, right? For example, I talked about projection from speech to text, have LLM-enabled speech. Can we have multilingual voice AI at the 6G edge? Can we have channel estimation? Can we have one ML model that combines estimation, equalization, and demapping all together under one umbrella? Again, a learning from our document vision foundational model, the third column, the CSI feedback, the compression, right? The AI encoders, decoders, the auto encoders. Can we actually reduce overhead for massive MIMO, which was also again mentioned in one of the earlier talks. And finally, inference, which is super critical for mass scale adoption, right? I mean, beam management, again, there's so much to learn from the 6G community here, right? ML predicts optimal beams and eliminates exhaustive beam sweeping, but at the same time, there could be a lot of domain knowledge which could also reduce the search space and create more tangible horizons of search. So, I mean, the other very last point I want to make is broadcast, right? Can broadcast be used as a strategic capability, especially in India? The terrestrial positioning, navigating and timing, right? The PNT, can it leverage? I mean, there's a precedent, for example, to India generating IP in the broadcast space. So can we leverage broadcast in 6G as a fallback also possibly to satellite communication? For example, if you had to handle new age scenarios such as UAVs, etc. So delighted presenting our thoughts to you. I think this is an opportunity for India to also become an IP producer by leveraging sovereignty as a first principle. Thank you.
Thank you, Professor Ganesh, for that sovereign and then glass box approach for Indian telco UPI moment. And now I will call upon Mr. Vishnuram to talk about AI native networks. Over to you.
Thank you very much, Rajaji, and thank you organizers for the invite. I will take a very quick presentation on focus group, that is on AI native networks. I use the background of the work which is done in the focus group. I will give you a quick update on what happened and what we are doing, what are the opportunities to collaborate and contribute to the group as well. This is the ITU focus group. And ITU you have heard quite a number of times, but this group is from ITU-T, that is for the network part of and the telecom part of ITU. Next slide, please. This is what I will cover today. What is AI native? Some examples of use cases. These are not 6G use cases, but these are AI native use cases. And then we look at some key architectural concepts which we derived from the work of the focus group. Then there are some definitions, some terms which you must have seen today. You saw what is AI native networks, what is the different concepts which we develop in the networks AI native part. So we look at some of those, and I will also explain how to contribute. And so what we have done so far. Next slide, please. Okay, so just to give you an example, here is, you can see the shark, which is basically native to the ocean, but at the same time, we can also go down with some extra fittings on your body, right? But that does not make us native to the water or the ocean. That's how we look at it when it comes to AI native. AI native refers to an integration method. It looks at how fundamentally AI can be integrated in the different use cases and the networks so that you are able to exploit, you are able to take advantage of AI natively from the design process itself, from the thought process itself while designing solutions. So that brings us to a certain set of advantages such as network autonomy, efficiency, and adaptability. This is already documented. When we formed the group itself, this was discussed, and this was the founding principle behind the AI native networks focus group of ITU. Next slide, please. Okay, let's look at some practical use cases, right? So for example, disaster resilience. I mean, this is a very typical use case in networks. It already exists in many forms in the network so far, where there are design principles, architectures which looks at it. But when you look at AI native networks, then I think it was Nirant who mentioned in the morning, that is distributed AI in different parts of the network so that you are able to have intelligence distributed in the network. So this is one form of how to distribute the AI models, trainings, and inference in different parts of the networks, along with energy resilience also. So you need to have not only intelligence but to power the intelligence. So you need to have that, and flexibility, ensuring that you have very little downtime between emergency and normal operations. That means if you have a failover, you make sure that the design is such that the failover happens very quickly. So that is the way you distribute AI, the way you integrate AI in the network, such that it becomes resilient in a much more efficient and energy sustainable fashion. Next slide, please. I think some of the presenters already touched upon the data part of it. I think the creation of data, there is generation of data, simulation of data such that you are able to create experiments within the network. So this picture shows you on the right side AI data creators. For each of the scenarios, the network is able to create scenarios, experiment, generate the data, use it for model training in the network. So that is what is shown here, which looks at data creation, model training, experimentation and validation in the network. There is this concept of knowledge base, which is looking at feature specific states and deriving the knowledge from the data which is generated in the network. That is something which I will touch upon later as well. Some of the technologies that we use in this use case is generative AI, distillation of knowledge. I think again our colleagues talked about data formats, knowledge graphs and so on, you saw in the morning. Some of these we are already using in the focus group. Next slide, please. Okay, I will very quickly look at some of the architectural concepts derived from the use cases, but you see there are two parts here. One is the AI ML part, producer part, and the consumer part. So from the network, you look at applications in the network which is producing the data, and you're using that for providing AI machine learning models as providers. This is the interaction which is shown, and this, as I told you previously, it is to be distributed across the network through this native AI native network concept. Next slide, please. There is also task distribution, which you can see on the right side. There is task creation execution models, AI agent control models, and also the layered architecture that you see there, that is a resource network and service layer. This layered architecture, each of them is built so that AI services can be provided, as well as the models can be hosted and inference can be provided right in the network. Task orchestration and AI agent orchestration we saw in the morning, that also is built into the architecture now. This is the capability framework which is getting developed in the focus group. Next slide, please. Okay, so for us, for ITU, it's very important to look at definitions of terms, because this becomes standards. There are two potential definitions we are looking at right now for what is exactly AI native networks. So there are two components that we have shown here. One is, of course, the integrating AI as a core component, enabling value-added services, enhancing performance, etc. Second one is all the steps in the life cycle of the network services, applications, functions, and AI pipelines are managed by AI, using AI with a specific aim to make the AI integration easier. So these are two definitions which we have. And I think we looked at intent and intent-based declarative technologies, etc. in the morning. Some of these are applied now right in the context of AI itself. Next slide, please. Okay, so here is a definition of AI agent itself. We look at entity able to interact with AI native telecom networks environment, using AI's task-specific capabilities. This is the way we define AI agents. Next slide, please. I talked about knowledge base in the beginning. In this picture, what you see is an autonomous network architecture. You see this knowledge base there. There is also this concept of sandbox, which provides experimentation in the network itself. There is orchestration, which is looking at managing the agent and the task controls that I discussed in the beginning. So this is a very comprehensive architecture which looks at giving you three main components: knowledge base, sandbox, and orchestration. Next slide, please. Okay, so let me introduce the group itself which is doing it and how to contribute. This is a focus group under ITUT. It looks at AI integration in the network architecture that you already saw. We are close collaboration with other SDOs such as 3GPP, IEEE, HC, and so on. The next meeting of the focus group is coming up, 7th meeting. Focus group is open to everybody, including academia, industry, startups, everybody here. We don't need any membership to be part of the focus group at all. Next slide, please. This was formed in July 2024 with, we produced technical reports and specifications. We have the leaders right here. Sujit ji is here, Amit ji is here. They are all leading this focus group as working group chairs and vice chairs of the focus group. Next slide, please. Okay, this shows the structure. You can see familiar names there. You see Amit Kumar Srivastava and Sujit ji there as part of the vice chairs and the working group chairs. Next slide, please. Another thing which I want to highlight is that we not only do paperwork, we also do proof of concept. The build-a-thons, that is the hackathons that we conduct, we provide open data and mentoring sessions so that students, academia, startups, industry are able to solve these problems, AI native problems, right in this room. We conducted in June 2025, we conducted focus group in this room as well as the build-a-thon for 2 days in this very venue. So build-a-thon gives us the ability to convert standards into working code. That's why you see code is king. Next slide, please. This is one example. We looked at network slicing, marketplace, and so on. Yeah, we have network slicing use case which looks at agent-based slicing architecture. I think it uses agent-based architecture to interface with slice vendors, select the best slice based on the use case. Next slide, please. 4 build-a-thons we have conducted so far. June 2025, I already told you. July in Geneva, build-a-thon 3.0 along with IMC here in Delhi, IIT Delhi, and build-a-thon 4.0 in Chennai. Next slide, please. So yeah, so we convert the papers, the standards into working code. That's what we do as part of the build-a-thon. Right now we are looking at AI native solutions. Next slide, please. Okay, so this was part of the AI Impact Summit. We were here in February to do this. 6th of February we did this as part of the AI Impact Summit. So this is an open platform. I mean, the Rajaji already mentioned the importance of openness. This is ITU provides you with an open platform for innovation and standards development. And we are now already conducted one meeting here, right in this venue. Last year, it would be good to look at hosting such open groups, especially looking at 6G technologies in the network and AI native technologies in the network. We are now, this group will be open till end of this year. I think it is a great idea to host such meetings again in Delhi itself. With that, next slide please. This is our photo from our last build-a-thon. You can see very energetic faces. These are students and startups. We conducted this in India. Next slide please. Okay, this is the next meeting is coming up. It's fully virtual, no charges, no membership fees. You can work on these technologies that I talked to you just now. Registrations are open. You are all welcome to contribute. Amit ji is here for any questions. Thank you very much.
So thank you so much for the insightful session, and now I invite Shri Jyotiraditya M, Director IT, to present the mementos to our session chair and speakers. A big round of applause for Mr. Jyotiraditya. The memento to Mr. Raja Gopalanji. Thank you. And now memento to Mr. Ratnakar Raoji. Memento to Professor Ganesh Ramakrishnan-ji. And the memento to Mr. Vishnu Ramji. So thank you so much, and thank you once again, everyone. Thank you. So now we move to the session 7 titled Secure and Trust Architecture for 6G. This session will examine emerging security and trust architecture required to support resilient, trustworthy and future-ready 6G systems. So to chair this session, it is my privilege to invite Professor Sandeep Kumar Shukla ji, Director, IIT, Hyderabad. Can we have a big round of applause for Professor Sandeep Kumar Shukla? Professor Sandeep Kumar Shukla ji is a professor and director of IIT Hyderabad. He has previously headed the Computer Science and Engineering Department at IIT Kanpur and held the Poonam and Prabhu Goel Chair Professorship. He's founded and co-coordinated the C3I Center for Cybersecurity and Cyber Defense of Critical Infrastructures and co-coordinated the National Blockchain Project. We welcome you, sir. And also I request our speaker for this session, Mr. Badri Narayanan Srinivasanji, District Solutions Engineering Manager, NAS Keysights Technology. We welcome you, sir. He is a District Solution Engineering Manager at Keysight Technology, India, Bangalore, with over 25 years of experience in telecom, data networking and product testing. We welcome you, sir. So I request now Ms. Jyoti Rote, Director MT, to kindly present the bouquet. Kindly present the bouquet to Professor Sandeep Kumar Shukla, sir. Thank you. And now the bouquet to Mr. Badri Narayanan Srinivasan, sir. Thank you so much. Professor Sandeep, stage is yours now.
You have the slides, sir?
You have the slides now? So they will play the slides for you.
Okay. I don't know if they have my slides. So, do you have my slides? Yes. Okay. All right. So, we are already about 45 minutes late. So, we'll try to do a quick job. So, as I was listening to all this very wonderful visions about 6G, including open open source RAN implementation, segregated implementation. We were thinking of AI native network functions, virtualization, cloud based network, and also we were thinking about having multi-vendor approach. And as a security professional, I was getting scared because unless we actually think about security from the from the very get-go, this can really backfire. Many of you might have read in the news that about OpenCloud or CloudBot. Have you heard of CloudBot? So CloudBot is an agentic AI system which was supposed to be, it was open source. It was supposed to help you connect your WhatsApp, your SMS, your email, your calendaring system through conversational interface. Everybody was very happy that such a thing is coming up. Unfortunately, it was completely open for cyber attack. It had so many different interfaces, attack surface, that eventually it became a big problem. A lot of people got burnt by that. The other problem that, as I was listening to this about this data, so we were talking about using AI native optimization, AI native decision on various functions. And for that you need data that is not manipulated. Now, a very recent paper by Anthropic showed that for a 7 billion parameter model, in order to corrupt the model to be triggered by a few keywords, you need only 25 documents which are corrupt in a very large corpus of data on which you are training the model. So unless you can protect the data on which you are training these models, again, AI native may actually be having backdoors where a few triggering words may actually be used to completely make your network go haywire. But in any case, I think that is what my main message is. So I have a lot of slides, but I will just go through them very, very quickly, because most of the thing that I prepared, and this slide set was based on my prompts, but actually the slide set was created by Claude, right? So you can see that AI, we are already going AI native, right? So let's go to the next slide. So we can skip this. This is the agenda. So this also we can skip because we already spoke from the morning that we have all this different things. We have the physical layer, we have the RAN, we have the network core, which is supposed to be maybe cloud-based, virtualized and AI native and so on and so forth. Then you have the service and management, and then you have the application. And go, next slide. We can skip this one also. So there are use cases. Some of the use cases, all the use cases that I have are already discussed. So you have digital twins. That seems to be a good one that has been mentioned many times. We have use of 6G in transportation. We talked about remote medical procedures, remote medical services. We talked about holographic imaging for remote presence. Of course, smart city, industry 5.0, and various other things where you can actually use immersive AR, VR people talked about also today. So all these applications are very good, compelling applications. Many of these can be also done with or without 6G, I think, but these are the applications that people are thinking about. Now, next slide. Now that basically means that, as I said, that it has a lot of attack surfaces. So starting from the RAN implementation that you are saying that you will have multi-vendor approach, you will have multiple components and all that, and multiple interfaces between these components, APIs and all that stuff. Whenever somebody does anything like that, unless they start from the beginning, from the very onset, bringing security considerations, do a DevSecOps, in developing such things. Now, when you have multi-vendor, you have other problems. You have the problems of supply chain compromise, supply chain security, because you have to then trust all the vendors on which you are dependent, and trust their supply chain. They may not be themselves malicious, but their supply chain, like what happened in case of solar wind and many other supply chain attacks. Now, AI ML has all these various things like prompt injection and various other things. So you have to worry about that. Of course, we talked about data poisoning, reversing the model to get sensitive data out, this kind of information. Now, somebody also mentioned about quantum threats. So post-quantum cryptography at the higher layers, not at the physical layer, but you will need that. And somebody also mentioned that in case of billions of IoT devices that people talk about in the context of 6G, this post-quantum cryptography might be too heavy. So we have to figure things out there. Of course, the network, since this network is at a much higher frequency band, so therefore jamming and other things are quite easy to do. So those kind of things you have to worry about, especially for critical applications. Like if you're doing it for medical, like remote surgery or something, you have to worry about such things. Then, of course, you have to worry about these, physical layer, possibilities of compromising the physical layer. And as I said, that there are many, IoT and embedded systems that people are talking about in very, very large numbers. There will be supply chain security issues. Right now, most of the phones that we use, if it is not an expensive phone, it is actually quite easy to compromise. So therefore, we'll see much more of that as applications are more and more distributed, because the applications are very compelling. But when you have such a large scale penetration, already you saw that Iran's supreme leader was found by actually compromising the traffic cameras through which they could see where his guards were sitting, parking their cars, right? In Venezuela, they attacked the PLC and SCADA systems before they actually did the kinetic attack. So you make your system so dependent on AI and billions of devices, your attack surface will obviously increase. Now, does that mean that we should not be doing this kind of technology? No, that is not what I'm saying. I'm not trying to, be a party pooper, but what I'm trying to say is that, bring AI in your standardization, bring security in your standardization effort as a first-class concern, not as an afterthought like we have been doing forever, right? So for previous systems, security has been rather an afterthought, but here, starting from the application level, AI, ML level, cloud level, network, reconfigurable, intelligent surface level, everywhere there are possibilities of attacks. And these possibilities of attacks require understanding, thinking about these possibilities of attacks requires a mind that is can think like a hacker, right? So involve security native people who think like hackers into your standardization and implementation efforts. Otherwise, it will be a problem. Like I was talking to a biomedical engineer who has a product through which they have sensors that they put on the patient and remotely monitor the patient, right? So I was asking him about the security of the movement of the data from the sensor to the cloud. They use AWS cloud, and they said, what is the big deal? I mean, this is just patient's data. And I'm like, if you have the high worth individual or very important individual, and you are looking at their cardiac data through being moved from their sensor, let's say it's a sleep study or something, and you are sending it to the cloud, and there is no security, the data can be manipulated while it is going there, and the diagnosis will be completely different, and he can be treated, with the wrong process or wrong medicine. So you have to think about this kind of threat scenarios in order to come up with the countermeasures. If you don't think about the threats, then you don't think about the countermeasures. So that's what the limited point I want to make. So I have other slides, but I don't want to take this time. And I think we are going to kind of give you a very similar messaging that make security as a first-class concern in your standardization, design, implementation. Don't try to think about security after you have done all this. Thank you.
Good afternoon. Yeah, do you have my slides? Okay, I deal with a lot of data center customers, especially on the higher speeds. So now if you see the time it took moving from 1 gig, 10 gig to 100 gig was almost 10 years, right? So now we are in the data center world, hyperscalers world. Here we are talking about 100 to 400, 400 to 800. The time gap is shrinking. Now it is less than 2 years. But in this room, it is happening in a more complex way, where we have a time difference of 15 minutes from one session to other session, and the topic is the same. Okay, so we are doing better than hyperscalers in this room today. So that's what I feel. If there is a TEC mandate today that all of us has to write an exam on 6G certification, I'm sure everyone will score 100%. So with that, I would like to quickly take 5-10 minutes, or maybe 6 minutes, being a 6G session. Secure and trust architecture. I would like to provide a kind of an architect view of this ecosystem. So if you think as regulators, architects, and the researchers in this room, it is not only about faster connectivity, right? So 6G is programmable, AI-driven, and it also combines the multi-domain, especially the terrestrial and non-terrestrial networks, right? The system. So now, when we talk about security, if there is compromise in the security, it is going to definitely create safety risk and also the regulatory exposure. Of course, the service disruption. Next slide. I think these are some of the why we are here, why we are moving from 5G to 6G. I'm not going into details. We all know the need in terms of the latency requirements and the throughput. But here, as I said, the security matters a lot. Next slide. Okay, this use cases, again, we discussed a lot from the morning. I think our Honorable Minister also talked about the tactical internet. So there are a lot of newer terminologies and keywords, right, which are coming into this ecosystem. I think these are something we need to carefully understand because we are talking about heterogeneous systems, right, terrestrial and non-terrestrial. We are bringing in different environments together, so that way, so we have a lot of use case which will come in the coming days, and in all this, the trust and security matters a lot. Next slide. From 5G to 6G, I think there were a lot of work done on the 5G in terms of the cloud native, technology implementation, but 6G is beyond that. We all know, we talked about that, AI native. And also a lot of efforts are being done by the 3GPP as well as the ITU in terms of bringing this within the timeline, that is 2030 is what we are looking at. Next slide. So now if you look at the technology pillars, again, I'm just giving you a visual representation of various components. Of course, we are talking about the terahertz spectrums and a lot of devices which are going to be connected. Sensing use cases, AI native networking, and non-terrestrial integrations, and of course digital twins. Right? So these are going to be the technology pillars which are being focused on the 6G. Next slide. So this is just for a reference of a 5G architecture. Here, as I mentioned, there were a lot of cloud native implementation, SB architectures. So that way, the security, the API security, software-based security, those are all implemented. But in case of 6G, this is going to the next level. right? So this is where we have to do a lot of work in terms of defining how the 6G architecture will be, which we will take some look in the coming slides. Next slide. So in terms of the vision, as we already discussed for the whole day, we are talking about end-to-end edge integration with a lot of devices, and the cloud services, of course, which is driven by the AI. So these are the block diagrams. I'm not going into details of each of them. We had enough discussions from morning in this area. This is kind of the vision for the 6G architecture. Next slide. Okay, so this is a visual representation of like what was 5G and what is changing in 6G in terms of data privacy, spectrum, security, coverage, intelligence. So these are the different buckets. But if you see on the right side, zero trust and post-quantum crypto, I think Professor Sandeep also mentioned about that, and AI native. These are the two key things which needs a lot of focus, and we need to start the work as early as possible. Next slide. So if you define what are the security challenges, since we are more focused on the security aspect in this particular session, of course the trust and privacy, again it has been divided into different segments of the 5G architecture. It can be device, IoT, RAN, edge side, or core SBA side, and the cloud and AI. So if you look at the trust and privacy, zero trust, quantum threat, AI/ML risk, new attack surfaces, this can be physical or cyber, and the massive scale, we are talking about billions of devices. Again, I think we touch-based so many aspects in most of the session. In my opinion, zero trust and the PQC needs to be focused a lot from the architecture standpoint. Next slide. Okay, so if you rethink the architecture, right, for a 6G, now we are moving from 5G to 6G, this is how the picture looks. Again, it needs to be improvised in the coming months. So we are talking about device and platform trust, right, so which is paramount, and access and transport. Then you have the core networks, data and AI governance, the privacy and trust comes into picture, and security operations and the cross-domain supply chain. I think this is also a lot of people have talked about in terms of what goes into the 6G ecosystem, right, which is important. Next slide. And zero trust. When we zoom in zero trust, we are talking about not only the UE device, but this AI system or the 6G system itself is the infrastructure needs to be, whether it should be trusted, right? The zero trust need to come into not only at the device level, but at the system level or at the fabric level, right? So it has to be on the network function, it has to be on the AI models which are being used, and we need to have a policy decision point and enforcement point. And the main thing, as you see in the bottom, it should be a continuous posture assessment and telemetry, right? It's not like do once and then leave it. It has to be real time, it has to be continuous. So that's where we'll be able to achieve whatever the security goals which we want to set up or the benchmark in case of 6G ecosystem. And 5 more slides, next slide. Post-quantum cryptography, right? So as I mentioned, this is one of the focus area when we talk about 6G, right? So we all know store today and decrypt later, right? So that thing is happening. So one aspect we can look at as part of the 6G ecosystem is some kind of hybrid cryptography, right? Because we are in the migration path from 5G to 6G. We cannot change things on the day one, right? So that's where we need to have a middle ground where we use a combination of our classic encryption models combined with the PQC. That's where on the right side you can see an example. If you are exchanging messages with, or you are defining the encrypted standard, we can look at the hybrid model initially, and then we all know the migration roadmap till the 6G comes into picture. So we can move from hybrid to native PQC model as and when technology develops. So this is one area we can look at. And then comes the AI-driven security. Again, everyone talked about AI-driven. AI has a lot of advantages, right? So the decision making in terms of handling the data which is going within the system, but it also poses a lot of threats, right? Some of the things which we all know, like model poisoning, or there could be some malicious activities which can cause a lot of problems, right? So we need to look at more from the, we need to use the same AI in terms of mitigation as well, right? So to come out of this, what are the advantages the AI is giving to us? Next slide. And when we move to the trust framework and privacy design, so again, when we talk about trust, what kind of data we are collecting, right? So today in the network, everything is being monitored, right? So we share a lot of things in our mobile apps, or we are being monitored by a lot of agencies, right? So that way, what information we are collecting from the users or from the system, right? So there should be a consent management and data minimization. So we don't want to collect unwanted data. And there should be a privacy enhancement engine, which is again part of the AI ecosystem, because we are talking about scale. It cannot be done manually. So now we need to capitalize on our AI related features, right? So that way we need to come up with privacy enhancement tools, federated learning, that is local learning, and then encryption, end-to-end encryption, or zero knowledge, like get minimal information to identify a particular user, right? And when we are doing that using the AI model, we also need to find a way from the regulatory standpoint. We need to make sure these are done at the right level, right? There is a monitoring in place from the regulatory standpoint in terms of data collection, auditing, etc. Next slide. And this is one of the important message which I want to communicate from my side. I'm part of Keysight Technologies. We are part of the T&M, that is test and measurement. So the test validation and standard roadmaps, we take it very seriously in whatever solution we are talking about. So that way it is applicable to 6G in terms of when we are looking at the test bed. So now we know the roadmap, right? When things are going to happen. So I think this is the right time we need to start. We need to create test beds, and these test beds should have a combination of digital twin systems, which are the replica of actual systems, and AI orchestration. We need to have bring in all the tools within our test bed to test various scenarios. And we need to connect the NTN systems also. We need to find ways to bring those ecosystem. And lastly, we need to do a lot of PQC pilots, because the encryption security is a very important thing on the overall test objectives, right? And of course, we need to have collaboration with regulatory bodies and the global agencies who are working on that. Next slide. So this is our my last slide in terms of conclusion. There are three things which I wanted to say on a very high level. We need to build end-to-end trust, and we need to build privacy from the design. And lastly, we need to validate first before we roll out our service, or we make the first 6G call, maybe in 2028. Thank you.
So thank you so much for the wonderful session, and it's a time for the felicitation. So I request Shri Kamal Kumar Agrawal ji, DDG, FA, to kindly present the memento. Can we have the mementos, please? So kindly present the memento to Professor Sandeep Kumar Shukla, sir. Thank you so much, and the memento to Badri Narayanan Srinivasan, sir. Thank you. Thank you so much, sir. Thank you for the wonderful session. And now, ladies and gentlemen, we will take a short tea break. And you please all are requested to kindly reassemble in 10 minutes of time. And again, delegates proceed to Atrium Hall, ground floor, and the dignitaries and speakers proceed to VIP lounge. Please enjoy your tea. please. So welcome back, everyone. So we now move ahead with session 8 of this workshop and look forward to another engaging and insightful discussions. So our next session is about emerging 6G application. This session highlights emerging applications beyond immersive communications. And our distinguished speaker for this session is Dr. Magnus Everbring, Head of Advanced Technology and CTO, APEC Ericsson. Can we have a round of applause for Mr. Magnus? So please take your seats on the dais. As the Chief Technology Officer for Asia Pacific, Dr. Magnus is responsible for driving technology alignment as well as long-term technology strategic Ericsson in Asia Pacific. He has been with Ericsson for more than 30 years and held several senior executive positions with Ericsson Research, Development, business units as well as customer accounts. We welcome you, sir. So, for welcome, Mr. Magnus, I would like to invite Ms. Namrata Singh, Director IoT. Ms. Namrata Singh. Kindly felicitate, sir, with a bouquet. So now you can conduct the session. You can change the slide. You can tell them to change the slides. Yeah.
Okay. So, good afternoon, everyone. Great pleasure to be here now for this session. And I was asked to talk about 6G applications. That can be short, because I don't know what will be the killer applications on 6G. And even better, I don't think I should know yet. It's still to be explored. And I'd like to tell you on how we can do so. There are three important parts, I argue. We in the industry will need and are qualifying the best technology that can be mature and scale massively by 2030. Thank you. And we in the industry are working hard to set a standard that should be ready by 2930. And that we've seen evidence of here today earlier. And then the third component, even more so important, we need to groom and drive the business on 5G based on its full merits and qualifications. And here it's still more to do. And why is that so important? The mobile operators that by 2930 are the most advanced on 5G, having a mature business on 5G, they are the ones who will lead into 6G business, I argue. And I also argue India is well positioned to be in that spot by the end of this decade. We started with mobile telephony in second and third generations and fourth as well. Rapid expansion. It changed societies. And it changed business. Mobile operators were having heydays. Business was expanding. But as we introduced the mobile internet third and fourth generation, bringing big changes to the normal user, revenues flattened out for the mobile operators. In 5G, we did a very big step. We loaded it with new technology, massive MIMO and carrier aggregation and so on. But 5G standalone is a very important thing in 5G and still to be explored by many operators. With 5G standalone, we get 5G slicing, and we thereby get a powerful tool to differentiate traffic and drive new business. And we also have network exposure. Those two together are the cornerstones to drive the business further and leverage into new areas, differentiate traffic, deliver services depending on the needs of users. Users being consumers, being enterprises, government sectors. And largely, this is still to be done, but it is going on in some parts of the world. Here are some examples, and to a large extent, we so far see it in the enterprise domain. Take the upper left-hand part, the policeman on Manhattan, he wears a body cam. That body cam live records the conversation the policeman has with a citizen. It is immediately upstreamed to the home server and becomes a public record right away. How is that done? How is it ensured that that record is available on a public site? Thanks to 5G slicing. A slice makes sure the policeman on Manhattan has a required service that's needed to stream uplink from the policeman to the server. That's in live operation now. On the right-hand side, you can see Sony engaging more and more. At Mobile World Congress, they used the 5G slice with journalists to take still photos and to do video coverage. You see car manufacturing plant, there are a number of them now having deployed 5G, such as the Jaguar Land Rover in Midlands, UK, such as Hyundai factory in Singapore. In Hyundai factory, they use the public network provided by Singtel, and they use the latest in terms of slicing, and they can have the desired performance need for their operations. So yes, it's happening, but it needs to be groomed and explored even more, and it should go into consumers. And then we are there. What will happen in 5G? What will over the journey happen more and more in 6G? So let's have a look at XR then. Left-hand side, you see a surgeon, Professor Gao of the National University Hospital in Singapore. Prior to surgery, they make a digital twin of the patient. They make an X-ray scan. In 8 surgery wards, 5 days a week, since 3 years back now, they do surgery using an XR hologram. Dr. Gao do cancer tumor removal on livers. As he cuts the patient open, looks at the tumor, the XR hologram will access the database and then superimpose the image of the tumor as it looks into the patient. Thereby he's guided to make a precision cut. He cuts the minimum out of the liver and he removes the entire tumor. The results are staggering. Mortality rate is down, efficiency is up. Surgery time is down by 30%. Apply that to any factory, and that enterprise would like to have 5G connectivity and use the latest with XR and cloud applications. Well, that's today, and it's in full operation, and it can be used anywhere. We heard Minister earlier talk about robotic surgery. Yes, that's the next step on this journey, I tell you, for sure. On the right-hand side, you have a peek view of what's happening on, or will happen on the consumer side. Meta and many other providers of XR glasses are working hard to make them slick and lean to wear for you as a private person. And they're soon to come on the market. How will they be used? Exactly, we'll see. But I know some providers that wants to have them always on. Let's set aside privacy issues. But let's just look from a network point of view. if all of a sudden, a part of the population wears these glasses, and wherever they look, it's being streamed upwards into the network. Of course, it will require of the mobile operators to deliver a very much more demanding service. That will not happen overnight, but it will happen in the next 10 years to come in many forms and shape, with 5G and being excelled further in 6G. And then we're into that journey from now 10 years into the future, leveraging 5G and extending it further with 6G. In terms of technologies, we've heard it a lot today, AI cloud is there for sure. But the paradigm of AI and cloud will not work unless you're connected, and you connect them with your mobile network. The importance of the mobile network just increases. And to do so, with all the traffic coming along, the different kinds of services, you need to differentiate the traffic flows. Different kinds of services to different groups of users and groups of applications. In the middle, you see the today a bit tailored example, high-end surgeon, which is a reality. In the middle, you see first responders more and more using 5G networks, like the policeman on Manhattan. And at the bottom, a bit more futuristic, a youngster at an arena, and he can upload information and superimpose that as he's looking on the game. That will happen. Not very long. Is it 5G? Is it 6G? Probably both, but different variants of it. 6G will be more potent, and for sure, once we have it fully there, that's where we want to go. With it comes new demands on the networks, and that we will need to manage. On the right-hand side, you see an indication of the traffic. Here, a little bit larger. This is an assumption we made. If you take the upper curve there, 40% device penetration of AI heavy applications and or XR glasses. And you can say then, with that in mind, in a 10-year period, 10 to 15 times more uplink traffic. And that needs attention to deliver. It's considerably more cumbersome to do. And we work with that. We work with it for several years, making sure we have the software support, making sure we have the hardware support. But over these 10 years, a lot will have to be done by us and by mobile operators and by device makers. AI plays a fundamental role in that. All our staff are upskilled in AI. In every step we include it, and already we see the benefits coming along. Here are some examples. In some of the most optimized part of the system, we applied AI and gained 10% higher spectrum efficiency. The cost of spectrum is very high in India. I can assure you that any user of that spectrum would like to get 10% more of it if possible. And now it's possible applying AI in certain parts of the system. You see 33% energy savings in some parts of the system. In all parts of it, AI goes in there today. AI goes in there to make sure it's easier to operate, to make sure that it delivers better performance, and that it delivers better energy consumption. So with 6G, we evolve the standard considerably, and we want to manage an even wider range of devices, from ambient IoT up to very large IoT devices, be it drones, be it autonomous vehicles, having vastly different demands, but making sure that the standard is written from the start so that we can manage it. So here's another dimension where we then look at how devices can be supported from very new kinds of devices. No longer is it a phone-centric device. They may even be in minority. And this is one example of that, where taking again a 10-year period, before 35, IoT devices will likely overtake smartphones. And many of these IoT devices will not be simple low-bit meter readers. They will be very advanced devices which have high demands on the latency, high demands on the data in the uplink as well in the downlink. And one kind of application we've seen mentioned a few times today, but I can't resist, I'll do it as well, and that's the joint sensing. Here you can see field trials. We're having it in the field, we're doing measurements, we have it on commercial sites, and we can track drones. We can track vehicles on roads, etc., moving objects. This is in the field evaluation, and it's based on 5G. And perhaps we'll see it in commercial service as well on 5G. Without a doubt, we will see it in 6G. Already now in the standard, we're making sure we have the right provisions to expand this area even more. So sensing is coming over the next 10-year period in different forms and shape. So slicing is a fundamental thing. Network exposure I mentioned as well. I'm happy to say some 3 years ago, we pushed for the really introduction of this in the industry, and now it's coming in there. Having a 6-year view, it's in there in our thinking on what should go into the standard to make sure we have exposure capabilities that are more advanced in 6G. But that assumes that the industry is mature on making business on exposure 29 and onwards. And therefore, it's important for mobile operators to be in there now and groom this industry. Late last year, we had a great milestone when all the carriers in USA launched a few APIs. And they make them available through an aggregation company, Aduna. So Aduna can expose them in their northbound marketplace. Vonage, a developer aggregator, is buying from Aduna and in turn then supporting applications from financial industry. SIM-swap and other APIs are now being used to reduce the likelihood of fraud for financial transactions. The hit ratio for a secure transition is up by a number of percentile units, representing a huge value for credit takers, or credit givers, I should say. So very quickly, we see network APIs coming into a segment where they, from day one, offer great value with the additional information traded from the mobile operators. And again, taking this journey from now till the end of this decade will prepare for doing exposure business with 6G. So I see 3 fundamental steps on the journey to having a successful launch of 6G, and not only technology launch, but launch of the business. That is to drive and scale the mobile platform, to make sure the business scales with that. I put up UPI here. I think it's a fantastic example how a digital platform can be used and be in the palm of the hands of ordinary citizens. Next thing is to evolve the network by software upgrades. The core network shall evolve, this business support systems shall evolve to support the new services that are being launched now with 5G. And then having done so, we can take a software upgrade to 6G, and then, depending on local conditions, do a rollout of an additional radio layer when that's required. But this way, we have a smoother way to introduce 6G based on 5G. And we have a great way to drive the 6G business given that the 5G business is mature. And with that, we have then what we in Ericsson call the intelligent fabric. We have a mobile system at the core of it that supports AI and cloud applications, that leverages AI inside of the network, that connects with more and more important devices, being IoT-based, being phone-based, that are data heavy, that have different constraints and needs in terms of service delivery. But at the core of it, the network supports to it, and together it's an intelligent fabric with new kinds of applications, humanoids, robots, etc., things we haven't thought of today. But we leverage the knowledge we're building now on 5G and then excelling further with introduction of 6G. Thank you.
Thank you so much, sir. And now I request Shri Ram Sajeevan Singh, sir, DDG IoT, kindly felicitate Dr. Magnus with the memento. Thank you very much. Thank you. So now we move to the final technical session of today's workshop, titled Discussion on NTN Integration. This session examines the architectural integration of TN-NTN as a foundation for ubiquitous 6G connectivity. It addresses key technical and deployment challenges alongside the future evolution roadmap for integrated networks. To chair this session, it is my privilege to invite Dr. Dilip Krishna Swamiji, Executive Vice President at CDOT. Please take your seats on the dais, sir. Dr. Dilip is Executive Vice President at CDOT Bangalore, leading advanced 5G engineering and 6G innovation. He has previously led platform and product development at Intel, Qualcomm, IBM Research and Geo Platform. We welcome you, sir. And our first speaker for this session is Mr. Abhay Kumar Tripathi ji, Vice President Radio Planning, Strategies and Standards, VIL India. We welcome you, sir. Please take your seats on dais. Mr. Tripathi brings over 31 years of rich experience in the telecommunication sector with deep expertise in network planning, optimization, and deployment of mobile technologies, including 4G and 5G network. We welcome you, sir. And our next speaker is Mr. Ruben George Stephen, Technical Manager at MediaTek Singapore. Please take your seats. He's an active 3GPP Grand 1 delegate and has been contributing to the development of future wireless technologies, including 6G and AI-driven communication system. We also welcome you, sir. And it is my now privilege to invite our third speaker of this session, Mr. Prasad Petkar, Wireless SEO Manager at Keysight Technology, India. Take your seat, sir. Mr. Petkar has extensive experience in wireless communication system device testing and network performance optimization and have been actively involved in enabling next generation telecom technologies. We welcome you all. So now may I request Sri Sujit Kumarji, Director MT, to kindly come forward and present a bouquet to session chair and speaker. So kindly present the bouquet to Dilip, to Dr. Dilip Krishna Swamiji. Now present the bouquet to Mr. Abhay Kumar Tripathi ji. Bouquet to Mr. Ruben George Stephen. And the bouquet to Mr. Prasad Petkar. Thank you, everyone, and thank you, sir. Dr. Dilip, now the stage is yours. Kindly conduct the session. And this is the remote. You can change the slides.
I can change this.
Yeah, you can change.
Welcome to the session, and thanks for hanging around with us and actually maybe walking up the stairs back for the session. Hopefully it'll be beneficial to you. We'll try to do it very quickly. We have, I'll cover some aspects of what CDOT is thinking about, and believe Vodafone Ideal and MediaTek have short position statements, and Keysight may have some detailed results, right? Prasad is like, it always has graphs and stuff, so okay, we'll get started here. And then we'll open up for any questions, if any. If you have to run off, we'll run off. So what are the objectives for NTN integration? And we'll talk about that, and then satellite constellations, deployment variations that are possible, highly elliptic options as well that we should consider. How do you configure a satellites? What network performance aspects should we consider? And some interesting aspects, with space computing and AI in space and things like that. But I'll talk about those things, and then, but still reset the overall expectations for NTN integration. The key thing that we are looking at from CDOT's perspective is to address the ubiquitous coverage goal, where terrestrial networks may struggle to reach hilly regions, villages that are unconnected, oceans, all of that, and truly try to connect the unconnected. And even both strategic and civilian use cases, whether it's the people or armed forces, we still want to reach a signal to them. And as we take 6G vertically upwards, you're taking 6G into space and you get dynamic 3D coverage. And that is a new perspective that we should think about. So far we've been trying our best to optimize terrestrially. Now let's look up, all the way up, and see what all we can do. So NTN deployments, typically we see GEO, MEO, LEO, HAPS. I want to show you the orbits. Typically GEO orbits are equatorial, okay? And you'll always find the satellite there once it's placed, geostationary. MEO orbits try to complement that. They are inclined, medium Earth orbits. So, they will disappear after some time. The dwell times are there, but longer than LEO. LEO is a few minutes. MEO could have several minutes or hours, but depending on where they're placed. And but they are at inclined positions trying to serve a better part of the globe at other latitudes. Now, LEO satellites could be in different types of constellations, Walker Delta or Walker Star. Walker Star tries to hit the polar regions, further latitudes up there. Delta tries to reach, say, closer to the equator and stuff. Lower inclinations, actually. And high altitude platform systems also there. So these are all, you can say, these are all sort of circular orbits. Once they're placed, they're somewhat circular around the globe. And the latencies increase. And one rule of thumb, if we, to think about speed of light instead of saying 3 into 10 raised to 8 meters per second, that's a lot of zeros. When we come to NTN, it's good to say, how many milliseconds is it? And so we say 1 millisecond for every 300 kilometers, okay, because it's 3 into 10 raised to 5 kilometers per second or 300 kilometers per millisecond. And that is easier to try to understand. On the Earth, you could have said 300 meters per microsecond. But, so this is a good phrase to remember to start calculating distances and time. For example, HAPS, 50 kilometers is like 0.16 of a millisecond. 600 kilometers, and say, hey, 2 milliseconds, 2 times 300. 9,000, 30 milliseconds. 1 second you can say it, what's the latency of a MEO satellite. And GEO is 36,000 kilometers, 120 milliseconds. So, it's easier to think that way. But now these these are not the actual latencies. You have additional latencies for task buffering and task processing. If you put a G0B in space, you're saying, okay, to a Leo it's 2 milliseconds, but really the processing may take you 30 milliseconds. So you have to worry about those costs as well. Now, one other thing, most of the satellite configurations that global operators have provided are trying to provide global coverage. Now, once you take this orbit and you start stretching it elliptically, make it highly elliptic, then it starts serving a particular region longer. The dwell times become longer. Once they become longer, you need fewer satellites to serve a country. So when you want to reduce and optimize cost for India, for example, if you want a satellite configuration to serve India, we should think more elliptic orbits if possible, and then stretch them out in space. So Earth becomes one of the foci of the ellipse, but the circle is like this. But when you stretch the ellipse, Earth stays there, but it goes up here, and so it's serving longer. And as the Earth rotates, one satellite comes up, another one comes up, another one comes up. So you keep getting coverage, but and they start complementing each other. But you need fewer of them, and so we would encourage standardization bodies to think about highly elliptic orbit options as well. And we have made 3GPP contributions in this regard. One example here is multi-level highly elliptic. So you can have 3 levels, but these are elliptic levels. So elliptic low, elliptic medium, and elliptic high. And you have 4 at the topmost, 8 at the medium, the blue ones, the 4 red ones on the top, and then the green, you have 16 of them. So a total of 28 satellites. That'll give you pretty good coverage and performance. So you may not need thousands of satellites if you're focusing on a single nation, right? So that's something that we should think about. Are we looking for global business? Are we looking for national business? And we've rotated these configurations. It can serve Germany. It can serve UK. It can serve Australia. So, so this is something that we should think about. I'll skip this slide, the performance numbers that you can look at later. So skip this. But also one thing, the satellites, as you extend the time that it spends, then you may have less handovers, and so systems may be a little more stable. Now, where do you deploy this? Typically you have a service link to the device from the satellite and a feeder link to the ground. Now, one thing that we should do besides, while we say NTN integration with 3GPP and cellular and all that, the first thing that we should look at is just use it as a data pipe. As long as you can get a signal, maybe it becomes a Wi-Fi hotspot, that should be fine. At a Gram Panchayat, if I can just get a satellite link out there, that should itself start providing data services. So satellite as a pure data pipe that has existed before can still be part of like a heterogeneous networking framework, combining Wi-Fi and cellular, and serve us. But then now we can say, hey, let's put a G0B in space or a G0B in ground. Now in an ORAN perspective, you'll say RU, CU, DU are all in space or all in ground. These are called transparent or fully regenerative payloads. Now you can have split architectures, but signaling impacts those architectures. You really don't want to split. So, if people have worked on a G0B, it's fully integrated even without any ORAN kind of split, they could just move in here and try to deploy. It's also called an A node B for 6G. A stands for advanced / AI node B. But I would encourage the programmability that ORAN supports, with the observability, controllability, and all of that. I think that is a rich architecture that will help manage systems well. And these are some of these aspects to consider, the high speeds, dwell times, Doppler, compensation, mobility, weather, terminal alignment, congestion, beam switching, all of that. A lot of service KPIs, but typical KPIs, but you should also think about service availability. Is it available or not? And What happens if you enable hybrid ARQ or disable hybrid ARQ because the latencies are high? How does that impact the system? And then look at end-to-end flows because the latencies are high. Look at the delay-tolerant networking aspects of that and see how to deliver end-to-end flows in that manner with buffering. And think about impact windows with rain fade and solar flares and stuff. But some interesting R&D opportunities are there besides just connectivity. We can look at non-terrestrial routing. Speed of light runs at 67% the speed on ground compared to space. So if you said 300 kilometers in 1 millisecond, on the ground it's 200 kilometers in 1 millisecond. So maybe a signal, you want to avert a nuclear war, you might want to send a signal through space for that. And then, with these multiple constellations that may be there, we would want to have coordination between them through inter-satellite links. Those are typically terahertz links. Spectrum sharing between terrestrial and non-terrestrial is interesting if they're actually trying to transmit the same frequency. But you could say, hey, as non-terrestrial kicks in as the signal fades from the terrestrial, and then you can pick it up. And maybe the signal is so weak that it's literally noise in the actual terrestrial deployment. So hopefully it may work out. There's a case to make there. But besides this, from an economics perspective, if you look at it, Starlink said it's going to charge 3,000 rupees for a data connection in India. Which farmer in India would be able to afford that? So we have to think about, what technologies are we deploying? What is the cost of that service? And whom are we reaching to? Maybe very high-paying subscribers will get such a service, and that's fine. That was the world in which, say, Apple lived and still lives. People who are willing to spend a lot of money. But if you really want ubiquitous coverage, you want to connect the unconnected, you have to think about economics also. So maybe we also enhance these systems with computing and storage and AI inferencing. So, yeah. So as we do computing in space, it would be good to look at what kind of tasks can you put? And maybe we don't want to trust that environment as an actual data center, but maybe we could do opportunistic AI inferencing tasks in space. And then, we talk about integrating sensing and communications, but, as these systems move, you might have to steer the beam. So it's not only sensing and communications, it's sensing and motion communications. So on a spacecraft bus, you would have not only a communication subsystem and a sensing system, but also a motion subsystem. And there are multiple subsystems on a spacecraft bus, including for thermal management, electrical management, guidance, navigation, control. But from a 3GPP aspect, this is an additional vector that might be interesting for R&D. But overall expectations, one thing I would say is it would be good to think differently when it comes to satellite connectivity. We should not think too much about high speeds and low latency, but it should be more about providing ubiquitous coverage to reach the unconnected. And if we set that as an expectation, then we'll be happy pursuing such integration. And then, this opportunistic connectivity mechanism can be a blessing when it's available. And, and when it's available, but, any other benefits is just a plus, whether it's space computing or AI inferencing and so on. So that's all I wanted to say. And at CDOT, we're working on all of this. So if you wish to collaborate, please reach out. Thank you.
Hi guys, I'm going to talk of operators' viewpoint on NTN, on 6G NTN. Can I have my slides, please? Okay, next slide, please. So we have been talking of ubiquitous coverage since morning. It's good to note that in 6G, we are thinking of satellite communication right from the start. But just to understand it a little bit more, in terrestrial network with a new band, like 6G, we are talking 7.1 to 8.4. New bands means new radio. New radio means new rollout. So there is a new rollout which has to happen on terrestrial network. Similarly, on the satellite side also, Not all bands may be supported on the current satellites which may be there. So there needs to be satellite which is capable of sending that signal to the earth. That's how you will achieve ubiquitous coverage. And as our C-Dot colleague talked of, the coverage, it would be good that if this coverage could be provided in unconnected areas today. What is also important is to have seamless interworking between terrestrial network and non-terrestrial network. There is always going to be an overlap between a terrestrial network and a non-terrestrial network. Somewhere those boundaries will come into play, and we need to understand what would be the mechanism if the same 7.1 to 8.4 gigahertz spectrum is being transmitted on the earth, right? While it is also being transmitted from the terrestrial network. So there needs to be, while it is said it should be seamless, but there should be studies which should identify that what should be the buffer zone between a D2C communication from satellite or from a satellite or a terrestrial network. From a user perspective, I may not want to know whether I'm connected to a satellite or I'm connected to a terrestrial network. I would want to keep the user experience same. But is that possible? I'm not so sure. Because if you really look at in a terrestrial network, every 100, 200 meters, you will find a site serving a signal and a capacity. And same from a LEO or a HAPS or a MEO GEO type of satellites, it's a very, very wide area to be covered. There is going to be latencies. We talked of 100 Mbps and whatnot in the morning with so many latencies. Anybody who is connected to the satellite system will have a different experience than terrestrial network. How do we handle that? What mechanisms need to exist? All those needs to be thought of when we are in the technology formation stage. Lastly, it is very important that NTN support is available. If we really want to make use of NTN properly, then NTN support needs to be available in the handsets now, or when the UE seeding is happening in the market. If NTN comes later, then there will always be bifurcation of the market where some users will not have NTN support and some will have. So it is important that for our UE colleagues, that if NTN is to be supported, then it should be supported right from beginning. Afterthoughts bifurcate the market. Next slide, please. What are the things we should look at? The first one is gateway location. All satellites at some point in time needs to talk to the gateways. With multi-tier like MEO, GEO, LEO, and HAPS, it is important to have, they each will have a different constellation. I think our C-Dot colleague talked of that they will have different elliptical orbits. Typically, a gateway today, satellite gateway, looks at one constellation. So if there is going to be multitude of constellations, there needs to be those many gateways. Each gateway sees a satellite up. So it needs to have a clear boundary. Now, if somebody chooses a gateway location, any OPCO chooses a gateway location, there should be protection from any other buildings coming nearby. This is an important operational aspect. And I'm sure in a previous many times in the consultation papers which have come also across, there has been protection sought from the GEO satellites. The same would be case for LEO as well. The gateways will now need to communicate to spectrum. There is a high bandwidth we are talking of, channel bandwidth of 400 megahertz. That will require a lot of uplink communication to the satellite. So a Q and V band would be required. What would be the mechanisms of delivering those Q and V bands to the OPCOs or to the satellite operators needs to be seen and understood for India. Uniformity of spectrum at India level. Of course, we talked of range 7.1 to 8.4, everybody would be happy. But we have states. Our allocation mechanism is based on LSA. The satellite bandwidth on Earth is few hundreds of kilometers. If not, at least the area is that much. The radius is also pretty large in few tens of kilometers. And every such beams, what do we need to do for state boundaries is something we need to understood. We need to understand what should be the mechanisms there. The other point that we need to look at, the same spectrum which is being used for the terrestrial and non-terrestrial. For D2C communication, as I talked of earlier, the satellite would also be transmitting that 7.1 gigahertz and terrestrial network should also be. So what should be the buffer mechanisms? These are aspects and learning that we need to have. Interference handling. Again, this is the same topic, that if across the state boundaries, across the country boundaries, if their spectrum is different, how do we handle that? Second things also which would be there is, so far generally satellite communications have been more FDD bands, but for TDD, which is 7.1 to 8.4, how will that be managed? What will be the implication of that needs to be really understood and outlined. Again, then the finer aspect of whether it is going to be a different PLMN or same PLMN, how will UV switch from terrestrial to non-terrestrial and vice versa. These are some of the studies which I hope that the teams, when they are going through the technology formation, they look at that and also guide OPCOs and the policymakers what should be done here to have the best mechanisms for India. These are my slides. Thank you.
Hello, good evening, everyone. So, so what I wanted to mention has been covered or mentioned briefly by Dr. Dilip and Abhay as well. But I'd like to delve a bit more deeper into 2 points. So, so if we look at 6G from the MediaTek perspective, there are 3 pillars. So one is on sustainability. 6G should ensure ultra low energy consumption and optimize the network for sustainability. And second is intelligence driven user experiences, which are based on this hybrid compute and distributing compute between the cloud and the edge. And the third one is on pervasive services anywhere. So this is actually what the aspect that pertains to NTN. So here we call it pervasive because generally, like when we say ubiquitous, like it's there, but we don't know if people would use it or not. So when we say pervasive, we want NTN and TN to penetrate into the mass market and be useful to the public at large. So if you look at the evolution of NTN in the standards, so it was actually standardized in 3GPP release 17, and basically NTN was added on to the NR and IoT specifications. So NTN capability was added on to NR and IoT, and there were further enhancements in release 18 and 19 and ongoing release 20 as well on GNSS resilient operation. And in parallel, like MediaTek has also been actively involved in demonstrating to the world about the capabilities of NTN. So we conducted the world's first demos of IoT NTN, NR NTN, and also live demos of 5G advanced NTN based on both release 18 and release 19. So when we talk about 6G NTN, there are 3 main aspects. One is integration at the top. So we have already achieved this partially in 5G because like we have the common protocols and architecture to an extent for both TN and NTN. But in 6G, we expect native integration between TN and NTN. Second aspect is convergence. So for convergence, we believe spectrum sharing is crucial. So we would want to have TN and NTN to share the same spectrum. This would help to reduce device costs, and this would lead to a single device being capable of both TN and NTN connectivity. This would truly enable mass market adoption of NTN technology. So now I will just focus on 2 aspects which are necessary for this integration of NTN and TN. So first is on spectrum sharing. So if you look at the traditional NTN, TN frequency allocation, they are mutually exclusive. So NTN uses one frequency band and TN uses another frequency band, and they do not overlap with each other. But this could create issues when there are like a larger number of users using NTN in rural areas, for example, with higher data rates. So then the NTN spectrum itself could get depleted, and then there is no other option for the user to get connected. So in this case, it is best if the user could use TN spectrum, which would be available in those areas. So here, if we share the common spectrum between TN and NTN, we could actually achieve more optimal utilization of spectrum, and this could actually enable more efficient usage. So in the figure, if you see, if you look at a normal kind of pairing or spectrum sharing, you would actually have both the okay, the pointer is not working. So basically, if you look at the left figure, you will have a NTN uplink and TN uplink on the same band, and similarly the NTN downlink and TN downlink on the same band. But if you evaluate the performance of this normal sharing architecture, in the rightmost figure, there is a dot marked as 1, and there is a dot marked as 2. So 1 is the SINR that you can achieve with mutually exclusive frequency bands, and 2 is the SINR that results from this normal spectrum sharing configuration in the leftmost figure. So basically, you observe a drop in SNR in both the NTN downlink and NTN uplink, and the drop is more drastic in the NTN uplink because the interference comes from the TN UEs transmitting in the uplink, so transmitting in the terrestrial uplink. So basically you have a large number of terrestrial UEs which with omnidirectional antennas which cause interference to the NTN uplink. So how do we solve this? So one possibility is to have reverse pairing. So basically you transmit, you use NTN downlink, you use the same frequency band for NTN downlink and TN uplink, and similarly for NTN uplink and TN downlink. So this is the dot marked by 3 in the rightmost figure. So you can see that the NTN downlink and the NTN uplink both see a performance improvement. For NTN downlink, you could almost recover the performance with mutually exclusive frequency bands. Whereas for NTN uplink, you could recover the performance by 5 dB, but still it is quite far from the performance with mutually exclusive bands. So in this second reverse pairing case, the interference source is basically switched. So in the NTN uplink, now the interference comes from the terrestrial G node Bs, and these are actually transmitting with directional antennas, and they are not as many in number as terrestrial UEs. So that's the reason you see an increase in SINR, but you don't really reach the performance levels of the no sharing case. So you can further improve this with some other frequency reuse concepts based on the beam footprint and so on. So that is illustrated by the dot 4. But I won't really go into those details. So this is an area of, definitely an area of research exploration. So this should actually be investigated for more efficient solutions for spectrum sharing. Next slide, please. Yeah, so finally what I would like to mention is about service continuity, which Abhay also touched upon. So this is basically focusing on the mobility of the user when it moves between TN and NTN coverage, and also between like NTN to NTN and TN to TN. So TN to TN, we already know how mobility is handled. So it can be like with handovers and so on. But when you want to have seamless mobility you need to take care of the mobility between TN and NTN. So basically in release 19 there are two network architectures. So first one is on the left side, which is a shared NTN core, which means the NTN RAN as well as the TN RAN both share the same core, which is managed by the terrestrial mobile network operator, or MNO, which is indicated in the figures on the left figure. So in this case, this is kind of preferred by MNOs because they have control over the user subscription in this case. And in this case, NTN just acts as a RAN node or a G node B. And all the user mobility is handled by the terrestrial core network. So here basically mobility needs to be handled using handover procedures. So there needs to be some enhancements in the TN RAN to handle mobility between NTN and TN. So there are certain possibilities like conditional handover between NTN and TN, or like using predictive mobility based on the mobility of the satellite and so on. And in the second architecture, that is using a standalone NTN core. So that means there is a different core network for the satellite as well as the terrestrial network. So this is generally preferred by the satellite network operators or SNOs because they have full control over the user data and subscription. So basically here it is even more challenging, like there are even more delays involved when switching among networks. So basically it is like roaming between two networks. So here this is also another rich area to explore on how to reduce the latency when handing over between these two core networks. Yeah, so these are basically my slides. So basically the key points are to enable tight or native integration between TN and NTN. We need to consider these aspects of spectrum sharing as well as service continuity. And unless these are considered seriously, we will not see a mass market adoption of NTN. Right. Yeah, thank you.
Good evening, everyone. What a day. Thanks for staying back. A lot of information that we have been gaining the whole day. So let me continue that journey for another 600 seconds. We have been talking for milliseconds since morning. So 600 seconds is something which I have targeted to complete my presentation. All right. So the ideology for whatever content I will be showcasing just now is, since we are talking about standardization, and it is very much, when we talk about standardization, any instrument or any, let's say, a base station or a device or a core that we are developing, you need a test bed to test the functionality of that device, and that's where I would be driving my presentation towards that. So, we saw this in some form today. The idea is, we have 3 different constellations, plus there is something called as HAPS. Depending on the height, the complexity increases just because of the latency. So just imagine something, you are sending it from the Earth towards a satellite and then again back to the Earth. So that delay is there. Second important aspect is the speed of the satellite, right? If it is LEO, you would see the satellites moving very quickly. If it is MEO, a bit less, and GEO would be stationary. So it adds to the frequencies that are there, right? If it adds to the Doppler effect to the of the signals that are being sent to the devices. Again, it's the other form of the same thing. We are looking at 550 milliseconds of delay and Dopplers of around 150 kilohertz to almost like 1 kilohertz, right? So it's too big. This is the architecture. I'll skip this, a very complex architecture considering NTN in picture. Lot of moving parts are there. There is one more aspect of HAPS, which is also there. So it adds to the complexity of the terrestrial network if satellite comes into picture. What is the key advantage of having an NTN? Of course, it allows you to have an extended coverage of the terrestrial network because of the cost of the network that needs to be deployed. Areas like, let's say, sea or hills, which are not accessible, we are able to provide the coverage. Second is the second aspect is the services that we can provide over this. Various types of critical services can be provided over this because of the extended network coverage. Then the scalability that it allows. We cannot expect the quality of throughput or the latency that we have been seeing throughout the day, which 6G guarantees. But of course, it has its own advantage in providing that. This is the present specification which 3GPP is following up to release 19. So these are various different aspects of the network of the specification which applies to NTN, and considering 6G, we will see similar type of enhancements or specification that we would see over a period of time. So what all challenges are there? Of course, space environment, which is there, it's a bigger challenge. Weight, power and cost. Deploying a satellite in space in itself is a bigger challenge. Just imagine if just one satellite goes faulty, just to replace that satellite, it will take so much amount of effort, to replace that satellite. Security is one more challenge that would be there whenever we are talking about NTN network. Recently, we saw some attacks on the NTN coverage, or satellite communication, which was there. So security is an important aspect for the NTN network. Second is the choice of payload. Okay, right now the 5G specification talks about transparent and regenerative. In 6G, we do not know. The complexity may increase just because ORAN is there. RU could be deployed, or RU plus DU plus CU could be deployed. So the type of payload is going to be a challenge in itself, and of course the latency is something which would be there, which we have to address going forward. And the movement of satellite is a bigger challenge. Okay, so just to highlight some of the aspects of whatever I mentioned, how those gets added up. So if we see the timing and delay Doppler effect, which is there, which allows which adds just because of the height, which gets added, and just because the satellites are moving, the Doppler effects are there. Second is the link budget, your HARC, your PRAJ, the initial access towards the satellite. That is an important aspect. The timing advance, which would be there, which has to be taken care by the network, is also one of the important factor to have a sustained connectivity between the UE and the satellite or the base station which is deployed on satellite. Interference is an important part because reusing the same frequency is not a choice, or I don't know, maybe could be a choice for the operators also, but a dedicated frequencies have to be assigned to the satellites for communication without interference. Core again is an important part, as mentioned by Dr. George. He mentioned that there could be multiple architectures of core with which you would be able to give services to the user. Nonetheless, AI native validation of all this, because AI is now going to be part of 6G. Considering NTN, that also needs to be tested. Since the data that would be coming in on the LLMs or RAGs, that will have its own challenge with the testing that may happen. Okay, so the use cases where this could be, so some of the use cases for testing could be for the satellite coverage, the auditing that needs to be done, the performance and the quality of experience. This is something needs to be standardized, by the regulators, by the policymakers. Interference claims is, of course, that will get mitigated because of that. The home operator, the dish services that are there, that can also create a challenge in this, or they would have their own claims towards the interference causing. And of course, the direct to sell which is an important part. So the quality of service towards the user is one of the important part. This needs to be tested in the lab as well as it needs to be tested on field. So from a field, so since there are some of the satellite operators globally which have their network already in place, so we did some testing with that. So this was the topology with which we were able to test it. So there were different probes that were deployed at various locations to monitor a set of satellites. So what did we gather? We were able to gather the number of satellites that we saw within an hour, the location, the constellation. Then we were able to figure out the hourly performance of a satellite, right? Hourly, minute wise, or the levels with which the receive levels were seen by the probe at the ground station. This is the RF coverage performance for each and every satellite. That's the reason you see different variation of colors, right? Those are nothing but the receive levels from different satellites. That's what we see in this. So the idea is to ensure that whatever receive level that we see, it is continuous without without losing a coverage towards the satellite. So that's what we are able to figure out. This is one more chart where we see if there is an interference. So was there so in the initial few seconds we see interference which is on the higher side. The upper part is the interference that we see in the green graph that we see. This is the count of satellites per day. One more important indication that will help you to optimize the number of satellites that needs to be deployed to serve a particular area. So that could be something related to the assurance of service. This is the percentage of for what percentage a particular satellite was able to provide a service throughout the day. And this is one chart where we did some testing of sending SMS. So out of a few SMS which were received within 5 milliseconds, which were received 30 milliseconds, and so on and so forth. So we were able to see and were able to decide if some portion of the optimization needed to be done by that operator. So right on dot. Thank you very much.
Just want to thank all the speakers for the extraordinary vision here and bringing it all together. I think there's a huge potential here, and we have global space operators as well, but I would encourage nations to think about a minimalistic set of satellites that could serve for civilian and strategic use cases, and potentially we could have both services, global and national services, coexisting with each other. And I would also encourage anybody who's providing such service to provide tiered services so that it truly reaches the unconnected. And we reached the ubiquitous coverage goal. And so let's lift 6G into space and have some fun. Maybe there's space computing, there's AI in space, hybrid routing, and all that fun stuff as well to do besides connectivity. Thank you.
So thank you so much everyone for this informative session. And ladies and gentlemen, as a token of appreciation, we would now like to felicitate our distinguished speakers, and I request Shri Amit Kumar Srivastava DDG MT to kindly present the mementos as a token of appreciation. So memento to Dr. Dilip Krishna Swamiji. Thank you. And now the memento to Mr. Abhay Kumar Tripathi ji. Memento to Mr. Ruben George Stephen. And now the memento to Mr. Prasad Petkar. So thank you, sir, and thank you everyone for this session. Thank you. So now with this, we come to the conclusion of the international workshop on 6G standardization, and I once again request Shri Amit Kumar Srivastav ji DD GMT to give vote of thanks.
Good evening. So as we have reached the conclusion of the international workshop on 6G standardization, it's my privilege to deliver the vote of thanks on behalf of Telecommunications Engineering Centre, Department of Telecommunications. Firstly, I would like to express my sincere gratitude to Hon'ble MOC, Hon'ble MOSC, Secretary Telecom, Member Finance, Member Technology, Member Services, DG Telecom, and other senior officers from DOT and other organizations for blessing us with their presence. I would like to place on record my sincere appreciation and thanks to Advisor Technology, sir, whose vision and encouragement was instrumental in conceptualizing and organizing the workshop. I would like to sincerely thank Senior DDG TC, sir, for his guidance and support in the successful organization of this workshop. His openness and approachability made it very easy for the team to seek guidance wherever required, quicker decision making and smooth coordination throughout the planning and execution of the event. I would like to extend my sincere thanks to all the distinguished speakers who shared their valuable insights throughout the workshop. Experts from leading global organizations and industry, including Ericsson, Nokia, Qualcomm, Samsung, Rakuten Symphony, MediaTek, Keysight, Tata Elxsi, Tejas Networks, CDOT, and Vodafone India, and IIT Bombay, IIT Kanpur, IIT Hyderabad, IIT Hyderabad from academia. They provided rich perspective across key themes such as global standardization developments, 6G network architecture, spectrum roadmap, RAN evolution, AI native networks, security frameworks, and emerging applications along with NTN integrations. Thanks all of you for enriching our understanding and experience. I would like to thank Vigyan Bhavan Management, ITDC team, our event management team for their successful coordination for making this event successful. I would like to thank all the participants and delegates for their active engagement throughout the session. I would like to thank MC Ratika Mehra ma'am for successfully conducting the event. I would like to thank all the media team for coverage, and particularly Mr. Vineet Malik, Director TEC, for successfully managing the show. Officers from TEC contributed significantly to the successful conduction of this workshop, each playing important roles in ensuring its smooth conduct. To name a few, Dev Pratap ji, Devvrat ji, Vineet Malik ji, Prashant Gemini, Anil Kumar, Mukesh Gupta ji did a lot of work. Finally, I would like to thank my team from MT Division, Sujit, Dhanesh, Jyoti, our RA Sushant, Adarsh, intern Himanshu, who actually worked for the last, I think, 2-3 months for successful conduction of this workshop, and particularly for last couple of days, they have been working hard. With that, I once again extend my sincere thanks to everyone who contributed to making this workshop meaningful and successful. We look forward to continued collaboration with all of you as we move forward in shaping the future of telecommunications. Thank you all and wish you a safe journey ahead. Thank you so much.
So thank you so much, sir. And with this, thank you for being part of this important discussion for future of 6G technology. Have a wonderful evening, everyone. Thank you.